Ladies and gentlemen, please join me in welcoming to the stage your MCs for the AI Engineer Summit, Agent Engineering Day, the founder and CEO of Superintelligent, NLW, and the founder of Turing Post, Ksenia Sa.
Hello, everyone. Welcome to the AI Engineer Summit, the Agent Engineering track. I think it's going to be an incredibly exciting today. Yesterday was all about the leadership. Today is about the builders. So we're super excited to have you here. I'm the host of the AI Daily Brief podcast, the CEO of Superintelligent, which is an agent readiness platform. Most of all, I'm one of your MCs for today.
Good morning, New York, and this is such a beautiful winter day. And good morning to over 13,000 people who are watching us online. It's a live stream. Welcome to AI Engineer Summit 2025. And my name is Ksenia Sa. I'm a founder of Turing Post. It's a newsletter about AI and machine learning. And also, as well, your co-MC today. Yesterday, it was a lot of amazing content, but I was really looking forward for this day because today we will be discussing agents. And this is such a hot topic. So we're talking about agents engineering track, and it's all about builders, all about you who are actually shaping our agentic future.
So across these talks, you're going to see a bunch of different themes, which together I think give you a really good sense of the story of the moment that we're in.
AI agents are in the spotlight, but their development stretches back decades. Research began in the 1950s with symbolic AI, gained traction with expert systems in the 1970s, and evolved into multi-agent systems in the 1980s. So today's leap isn't in theory, but in scale. LLMs and automation frameworks are making agentic workflows practical, driving real-world adoption across industries. And what was once theoretical is now operational on an unprecedented level.
And that shift from theory to practice is one of the absolute key themes of today. You're going to hear a lot about what's actually happening now, things that are real, things that are live, not just things that could be in the future.
Yes, and in fact, things haven't gotten so real that we will hear a number of use cases and deployment stories, such as how agents are impacting the finance space at Jane Street and BlackRock. I'm very excited about that.
But of course, not everything is figured out. The other big theme for today is the big open questions, the challenges that remain, questions of scaling, accuracy, memory.
Yes, we have a very, very exciting lineup today. And as AI engineers, we will go deep on Gemini deep research, how it was built. We will learn from OpenAI and Anthropic, how they think about building their agents. We will explore how reinforcement learning what reinforcement learning means for agents, and discuss how to scaffold wisely while scaling effectively and efficiently. Experts from Weights and Biases, Datadog, Morgan Stanley, Bloomberg, Brightwave, Galileo, and other amazing companies will share their insights. And don't forget, tomorrow we will have hands-on workshops.
Before we start, we have to give a big thank you to our sponsors, especially the AI Engineer Summit's platinum sponsor, Solana. Solana, for those of you who don't know, is a blockchain and crypto ecosystem. It's one of the ecosystems that's most directly at the center of this intersection between AI, agents, and crypto. In short, they are building a permissionless layer for unlocking and allowing your agents to create wealth. I think it's extremely telling that they are here supporting this event in terms of where they see their priorities. So big thank you to Solana. If you want to learn more about them, they have a large booth downstairs with 3 demonstrations in the expo.
And this event would not be possible without all of our sponsors. All the companies you see on the screen are pushing the boundaries of AI engineering and represent a fascinating mix of pioneers shaping the future of the field. The expo area is just down the stairs in the hallway on the lower level. You probably been there yesterday. But please take time to visit our sponsors, chat with their experts and top engineers. There is a wealth of knowledge to gain from them. And you can make connections. There are a lot of opportunities to explore, and these sponsors could be your next collaborators, they can be your service providers, or maybe mentors if you're just starting your AI journey. So take a time to visit them.
Last quick announcement before we get out of here from a logistic perspective. At the break following their sessions, most speakers will be able to answer your questions at one of the 3 speaker Q&A lounges. There's one on this level and then 2 down below just outside the expo. There's also, during break time, the hallway track, which allows you to gather and talk about the topics of the block from the session. It's a way to sort of engage in the conversation in a more direct way. You'll see there's several breaks happening throughout the day. Hopefully you take advantage of those to go engage with the speakers, engage with each other, and make sure, of course, that you do not miss the after party after all of this is done in the expo at 5 p.m.
So are we excited about today? Yeah. Good, yeah. Woo! So please help me to welcome this person who probably all of you know. He's the editor of Latent Space. He's the founder of Small AI. He's a co-founder of this super practical AI Engineer Summit. He'll set the context for today's track and discuss what needs to happen in 2025 to make this year of the agents. Please join me in welcoming Swyx.
Is this thing on? Hi, good morning, everyone. Love that, love that. I'm going to get right into it. One of the challenges we have with Summit is that we actually ask our speakers to do very short talks. So I, as the leader of Summit, I have to do even shorter talks. So let's go. You can see a lot of these. There'll be a lot of show notes and homework. You can see it on the live stream. How is AI engineering doing? It's pretty good. We have an O'Reilly book. That's pretty cool. Chip is actually a good friend, and she's actually speaking at, she's giving our keynote for the workshops session tomorrow, which is pretty cool. Gartner hates us. Gartner thinks we've hit the peak. So it's only downhill from here, guys. I'm sorry to inform you that AI engineering is over. There's nowhere else to go but down. A lot of what I try to do with these talks that I do at each conference is to try to landmark the state of the art or the state of the industry. So with Latent Space, I did the Rise of the AI Engineer. With the first AI Engineer Summit, we talked about the 3 types of AI engineer. And with last year's AI Engineer World's Fair, we talked about how the discipline of AI engineering was maturing and spreading across different disciplines. I think this is starting to get a little stale. By now, a few million people have seen this and used this to form their teams, and I think that was the intended effect. What I am encountering these days is the resistance from 2 sides of the AI engineer spectrum. If you come from an MLE point of view, you think that the AI engineer is just mostly an MLE plus a few prompts. If you come from the software engineering point of view, you think that it's mostly software engineering and calling a few LLM APIs. I think over time, the AI engineering is going to basically emerge as its own discipline, and it's still not there yet. It's still very, very early. I still say things like, oh yeah, AIE is 90% software engineering, 10% AI. I think that will grow over time, and I think this is the year when it starts to spread out, and that's what I'm here to talk about a little bit today. So for example, I think what I try to do with AIE is also is a work in anthropology, how people describe themselves, form groups, form identities, and form industries. So MLE, it leaks out in your language. They say test time compute because the only reason to run inference is to test it. AIE will maybe say inference time compute because we actually really care about inference. Software engineers may be reasoning. And I think you see these differences, and I'm trying to articulate them over time. Part of what I want to do here to set context is to explain why we've kind of pivoted AI Engineer Summit to be the agent engineering conference. It's not a decision that we made lightly, because we're saying no to all these things. We're saying no to RAG, we're saying no to open models, GPUs, and we're just saying, this is the only thing that we're going to do today. But closing all those doors actually opens up others. So when we put out the call for speakers, we made up all this list of other agent engineering disciplines. And I soon realized we didn't have to. I'll talk about this in a bit. I also looked at last year's top performing talks on YouTube, and you guys told us that you really wanted all the agentic things. Now the only problem with this is that we only got speakers who basically made agent frameworks for a living. and everyone's asking the real question, who's putting this in production? So we had a new rule this year of, all right, no more vendor pitches. You complain about, thank you. As a curator, it makes it so much infinitely harder because basically the people that you're about to see have no incentive to come on stage and share what they're sharing, but somehow we talked them into it. So I hope you're looking forward to that. The other thing also, I realized that everything plus agent works, basically. So agent plus RAG works, agent plus codegen works, agent plus search works. And this is kind of like the simple formula for making money in 2025. Most of these names you'll see in the talks that will follow in the sessions. Some of you heard this one before. 2025 is the year of agents, right? If you say it often enough, it might be true. I think that when people make predictions, oftentimes they confuse what they want to happen for what will actually happen. So maybe you believe Satya Nadella, maybe you believe Roman, maybe you believe Greg Brockman, maybe you believe Sam Altman. All of them want you to believe that 2025 is the year of agents. And I'll be very honest, me and my co-host Alessio, I think I saw you over there. Hey! We were pretty skeptical as well. We're on the record being skeptical. Actually, all of you are being on the record because yesterday, Bar played Family Feud with our audience, and the number 2 buzzword that everyone is tired of hearing is agents. But fortunately, you guys are not tired enough because you came to today. I have you for one more day of agents talk. But we're on record March 2024 with David Luan, the former VP of Eng of OpenAI, saying that we tell people to take agents off of their branding. Now we tell them to put it back on. So, okay, I think I'm doing this as a public service. To start any agents conference, we have to define the word agent. Are you guys ready? All right, I actually have one. It's a monumental task. I could do it in one slide. So if you talk, again, this is a very POV sort of anthropological point of view. The machine learning people will talk about some kind of reinforcement learning environment. They want to talk about actions, achieving goals, and all that. AIE, we don't know what they want yet. The software engineers are very reductive. You just put it in a for loop. Okay, it seems like you agree. Fortunately, I think every AIE conference needs to invoke the name of Simon Willison. He is our patron saint. He's actually gone and crowdsourced 300 definitions of what an agent is. So I didn't have to survey all of you. I was thinking about asking every single speaker to start with, what is your definition? Doesn't matter. Here's 6 of them, right? It's either about goals, it's about tools, it's about control flow, it's about long-running processes, it's about delegated authority, and it's about multi-step task completion. Yeah, I see all the phones coming out. Don't worry, it's on the live stream, right? There's like 20,000 people watching along. And then there's a bunch of other things. I think the last one on the bottom right, is an interesting one. Just have some things that everyone defines, agrees as an agent, and make sure that your agent definition is passing those things. So that was my one slide. That was my slide of what defining an agent. And then yesterday, OpenAI went and dropped a new agent's definition on the live stream that you can watch yesterday as well. So this is something they're obviously going to work with. And I think you should definitely pay attention to this because they're building on top of this new definition as well. So that's defining agents. Why now? Why are agents working now when they did not work a year ago, 2 years ago? I have a rough idea. So people are talking about capabilities, and so you can see that capabilities, even on the trajectory of 2023, 2025, have been really growing, and they started around to hit human baselines right about now. And I also have a map of other reasons as well. So I'll just bring you through each of them. Most people will say, oh yeah, we have better reasoning now, we have better tool use now, we have better tools, including MCP, which you're doing a workshop on tomorrow. But I think there are some other less appreciated things which I'm going to bring up to you right now. Model diversity, right? The OpenAI market share has gone from, let's say, 95% 2 years ago down to 50%. It's a much more diverse landscape, including this past week, 2 frontier model labs that are possible challenges to OpenAI have emerged, and which I think is really exciting for 2025. We don't actually know what is going to shake out to it by the end of the year. The second thing is that the cost of intelligence is super Moore's law is what I call it. It's gone. The cost of GPT-4 level intelligence has gone down 1,000 times in the last 18 months, and you can see the same curve starting for the O1 level intelligence. And also, we now start to have RL fine-tuning options. I have zero experience in this area. But fortunately, one of our speakers is going to talk to us later today about this. So we have all these reasons. I have a few more. In our conversation with Brett Taylor, he talked about charging for outcomes instead of costs. There's a lot of work on multi-agents as well as faster inference as well that's coming out from the better hardware that we have. There's more homework there if you want. This is all sourced and has some backing in our latent space conversations, but I don't really have time for that. Okay, so one last thing for you guys on agent use cases. So I think most people agree with like Barry's building effective agents talk. He's going to talk about how coding agents and support agents have product market fit. I think now it's fair to say deep research has PMF. But also I would say up and coming are some of these use cases, some of which you're going to see in the talks later. But I also want to offer anti-use cases. Can we please stop demoing agents that book flights? Yeah? No more flight booking agents. I want to book my own flights, thank you very much. I want to book my own Instacart orders. And also, please don't AstroTurf Reddit. Right, okay, so and I think the reason that so this is the headline that I saw yesterday. I had to put this in. OpenAI reported 400 million users, which is a 33% growth from 3 months ago. And then you can ask deep research to research OpenAI and draw this chart of ChatGPT growth, going from 0 to 400 million users in 2.5 years. I remember this chart very well because ChatGPT spent a year not growing. And why did it spend a year not growing? Because they didn't ship any agentic models. And if you actually just look at the sort of weekly active user chart and stretch it out, you actually get this chart, which is actually super interesting because it basically shows that the sort of O1 models have doubled ChatGPT usage. And if you stretch it out, ChatGPT is going to hit 1 billion users by the end of this year. It's basically going to quintuple the number of users it had as of September of last year. And so like the growth of ChatGPT and the growth of any AI product is going to be very, very tied to reasoning capabilities and the amount of agents that you can ship for your users. It is real. It is huge numbers. This is 1/8 of the world population that's going to be using ChatGPT by the end of this year. And I think there's a lot of money left on the table for everyone else. So I hope you enjoy doing that. I'm well past time, so I'm going to skip all this. But basically, I think that the job of AI is now evolving towards building agents in the same way that MLEs build models, software engineers build software. I'm going to skip all that. You can see all that on the live stream. But we're actually just here to welcome you to the show. And I'm really excited to introduce you to everyone. So thank you, and I hope you enjoy. Thank you.
Will 2025 be the year of the agents? Here to present how to build and evaluate agents is the author of AI Snake Oil, Sayash Kapoor.
The theme of this conference today is agents at work. Unfortunately, for the next 18 minutes, you'll be stuck with me talking about how agents don't work very well today and how we can do better when it comes to AI engineering. So there is so much interest in agents from all fronts. In the product world and in the industry world, in academic labs, in research. If you're someone who doesn't think that companies will be able to scale language models all the way to AGI, then what we are going to see more and more of in the near future is agents that are not really deployed directly, but function as small parts of larger products and systems. And this is what AI is probably going to look like in the near future. Swyx came up with a few dozen definitions of AI agents. This is one of them, where language models control the flow of a particular system. In fact, even when people naively think of ChatGPT and Claude as models, these tools are actually examples of rudimentary agents at some level. They have input and output filters. They can carry out certain tasks. They can call these tools, and so on. So in some sense, agents are already widely used as well as successful. We've now seen mainstream product offerings that can do a lot more. OpenAI's operator can carry out open-ended tasks on the internet that deep research tool can carry out 30-minute-long report writing tasks on any conceivable topic. So that's the first reason I think today's conference is timely. But the second reason is that on the flip side, the more ambitious visions of what agents can do are far from being realized. So on the left here is a vision for what agents can do, something out of science fiction films like the film Her. And on the right-hand side are how these ambitious products have failed in the real world so far. Now, I'm pointing this out not to criticize the specific products on the slide, but to genuinely challenge the audience into the challenge of building AI agents that really work for the people who are about to use them. And so over the course of this talk, I'll talk about 3 main reasons why agents don't yet work and what we can do to realize the potential of agents to get past some of these failures. The first one is that evaluating agents is genuinely hard. So to begin, let's see some examples of how, when people have tried to productionize agents, these agents have sort of failed in the real world. Do Not Pay is a US startup that claimed to automate the entire work of a lawyer. The startup co-founder even offered $1 million for any lawyer who would be willing to argue in front of the US Supreme Court using Do Not Pay in an earpiece. In reality, a couple of years later, in fact, very recently, the FTC fined Do Not Pay hundreds of thousands of dollars. The reason for the fine was that the performance claims that Do Not Pay seemed to be making were actually entirely false. Now, you might consider this a case of rushed invention of a small startup making claims that it cannot back. So let's look at some of the work from more well-established companies. Law firm LexisNexis, as well as Westlaw, are widely regarded to be some of the leading law tech firms in the US. A couple of years ago, LexisNexis launched this product, which it claimed was hallucination-free in its ability to generate legal reports and reasoning. But when Stanford researchers evaluated LexisNexis and Westlaw products, they found that in up to a third of cases, and at least a sixth of cases, these language models hallucinated. In particular, in some cases, the hallucinations basically completely reversed the intentions of the original legal text. In others, the paragraphs were made up. They have about 200 examples of such errors in leading law tech products. We've also heard examples of AI agents soon automating all of scientific research. So this is an example from startup Sakana.ai. Sakana claimed they had built a research scientist that could fully automate open-ended scientific research. Now, our team at Princeton wanted to test this claim in the real world, in part because automating scientific research is one of our main research interests. So we built a benchmark. We created this benchmark called Core Bench. The tasks in this benchmark are way simpler than what you might expect from open-ended real-world scientific research. They just try to reproduce a paper's result, even providing the agent with the code and the data needed to reproduce it. So as you can imagine, this is far simpler than automating all of science. What we found is that the best agents as of today cannot even automate scientific research reliably. Less than 40% of the papers can be reproduced by the leading agents. Now, of course, you can see these models getting better. And even if an agent can automate only 40% of reproducibility, that is a huge boost because researchers spent a lot of time reproducing baselines from past results. But on this basis, to argue that AI can soon automate all of science or that agents will render scientific researchers obsolete is way too premature. In fact, when people actually looked at how well Sakana AI's AI scientist worked, they found that it was deployed on toy problems, that it was evaluated using an LLM as a judge rather than human peer review, and that, in fact, once you start looking at the results, they turn out to be very minor tweaks on top of other papers. Think undergrad research projects rather than fully automating all of science. Now, a couple of days ago, as I was preparing the slides for this talk, I came up with another claim, or Sakana came up with another claim, where they claimed to build an agent for optimizing CUDA kernels. The claims were indeed very impressive. They could lead to a 150x improvement over the standard CUDA kernels that PyTorch comes with. The issue, though, was that if you sort of analyze their claims one level deeper, you would see that they were claiming to outperform the theoretical maximum of the H100 by 30 times. Clearly, this claim was false, and once again, it was because of the lack of rigorous evaluation. It turned out that the agent was simply hacking the reward function rather than actually improving the CUDA kernels. Once again, the point is not to call out a single company, but rather to flag that evaluating agents is genuinely a very hard problem. It needs to be treated as a first-class citizen in the AI engineering toolkit, or else we continue risking failures like the ones on the slide. The second reason why building agents that work in the real world is hard is because static benchmarks can be quite misleading when it comes to the actual performance of agents. And that's because for the longest time, we focused on building evaluations that might work pretty well for evaluating how well language models do. But agents are not the same as models. For example, for most language model evaluations, all you need to do is to consider an input string and an output string. Those are the domains where language models work. It's really enough to construct evaluation. On the other hand, when you're thinking about agents, these agents need to take actions in the real world. They need to interact with an environment. And so building this sort of evaluation that makes these changes possible, that creates the virtual environments within which these agents operate, is a way harder problem. A second difficulty in evaluating agents is that for LLMs, the cost of evaluating a model is bounded to the context window length of these language models. You can basically look at these evaluations as having a fixed ceiling. But when you have agents that can take open-ended actions in the real world, there isn't any such ceiling. You can imagine these agents calling other sub-agents. There can be recursions. There can be all sorts of systems, maybe just LLM calls in a for loop. And because of this, cost needs to be, once again, a first-class citizen in all evaluations of agents. If you don't have cost as an axis alongside accuracy or performance, you're not going to really understand how well your agent works. And finally, when you build a new benchmark for a language model, you can basically assume that you can evaluate every single language model on this benchmark. But when it comes to evaluating agents, these agents are often purpose-built. So for instance, if there is a coding agent you want to evaluate, you can't really use a web agent benchmark to evaluate it on. And this leads to a second hurdle, which is how do you construct these meaningful multidimensional metrics to evaluate your agents rather than relying on a single benchmark to evaluate how well it works. Now, all of these concerns might be thought of as theoretical. You could reasonably ask, why do we care if static evaluations don't really work well for agents? The reason is that because of these differences with the cost and the accuracy, because of the singular focus on optimizing for a single benchmark, we are basically unable to get a coherent picture of how well an agent works. So at Princeton, we developed this agent leaderboard that tries to solve some of these issues. In particular, for example, for the core bench leaderboard I mentioned earlier, you can have multiple agents which are evaluated with cost alongside accuracy. So here on this Pareto frontier, you can see agents like Claude 3.5 scoring about as much as the OpenAI's O1 models. But the Claude model actually costs $57 to run, whereas O1 costs $664. Even if the performance of OpenAI's O1 was a couple of percentage points higher, which it wasn't in this case, by the way, but even if it were, for most AI engineers, the choice here is obvious. You would, any day of the week, take a model that costs 10 times lesser while performing about as well. Now, in response to this sort of two-dimensional Pareto, I've often been asked, are LLMs becoming too cheap to meter? In other words, why do we even need to care about the cost of running an agent if the cost of creating these models is dropping drastically? And it is indeed true that costs have dropped drastically in the last few years. If you compare Text DaVinci 003, which was OpenAI's model back in 2022, to today's GPT-4o Mini, which in most cases outperforms this older model, the cost has dropped by over 2 orders of magnitude. But at the same time, if you're building applications that need to scale, this type of approach is still quite costly. And especially from the point of view of releasing prototypes, one of the barriers is for AI engineers is you really need to sort of iterate in the open. And so if you don't account for cost, your prototype might soon end up costing you thousands of dollars. And finally, even if the cost of scaling inference time LLM calls continues to drop, what is known as the Jevons paradox, I suspect, will keep increasing the overall cost of running agents. So Jevons paradox is this theory from a 19th century British economist who figured out that as the cost of mining coal reduced, the overall usage of coal increased, not decreased, along several industries. The same happened when the ATM machines were introduced all over the US. People expected a loss of jobs for bank tellers. But what happened was the opposite. Because ATMs were so easy to install, the number of bank branches actually drastically increased, leading to an increase in the number of bank tellers employed. This is also what I expect will happen as the costs for language models keep dropping drastically. And that's why, for the foreseeable future at least, we do need to account for cost when it comes to agent evaluations. So how do we do all of this in an automated way? Well, with the Holistic Agent Leaderboard, or HAL, we've come up with a way to automatically run agent evaluations on these 11 different benchmarks already, and very many more are on the way. Beyond that, though, even if we come up with these multidimensional benchmarks, even if we do come up with cost-controlled evaluations, there are still certain issues with this type of evaluation. And that's because agent benchmarks have sort of become the metric against which VCs fund companies. An example is Cosign, which raised its seed round of funding based on its results on swybench. In fact, agent developer Cognition raised $175 million at a valuation of $2 billion, driven primarily by the fact that the agent did very well on swybench. Unfortunately, benchmark performance very rarely translates into the real world. So this is an excellent analysis of how well Devin works. Devin is the agent developed by Cognition from the very impressive folks at Answer.ai. Instead of relying on standard benchmarks, they actually tried to incorporate Devin into their real world. And what they found was that over a month of use, they tried it for 20 different tasks, and it was only successful at 3 of them. So this is the other reason why this over-reliance on static benchmarks can be really misleading. How do we get over this? One of my favorite frameworks to think through this is the work by folks at Berkeley called Who Validates the Validators. On the top is the typical evaluation pipeline, which consists of singular LLM calls against static metrics, which is the sort of broken paradigm for AI evaluations that we just discussed. And at the bottom is what they propose. They propose having humans in the loop who are domain experts who proactively edit the criteria based on which these LLM evaluations are constructed. And that can lead to much better evaluation results overall. This brings me to the last key takeaway for why agent performance does not really translate into the real world, which is the confusion between what capability is and what reliability is. So very roughly speaking, capability means what a model could do at certain points of time. For those of you who are technically minded, this means the pass at k accuracy of a model for a very high k. That means that one of the k answers that the model outputs are correct. On the other hand, reliability means consistently getting the answer right each and every single time. When agents are deployed for consequential decisions in the real world, what you really need to focus on is reliability rather than capability. That's because language models are already capable of very many things. But if you trick yourself into believing this means a reliable experience for the end user, that's when products in the real world go wrong. So in particular, I think the methods for training models that get us to the 90% of it, what in Swyx's term would be the job of a machine learning engineer, don't necessarily get us to the 99.999%, what is often known as the 5 nines of reliability. And closing this gap between the 90% and the 99.9% is the job of an AI engineer. And I think this is what has led to the failures of products like Humane Spin and Rabbit R1. It's because the developers did not anticipate that not having reliability in products like these would lead to a product failure. In other words, if your personal assistant only orders your DoorDash food correctly 80% of the times, that is a catastrophic failure from the point of view of a product. Now, one thing people have proposed to fix this sort of issue, to improve reliability, is to create a verifier, something like a unit test. And on this basis, there have been several claims that if we could improve the inference scaling capabilities of these tools and get to very reliable models. Unfortunately, what we found is that verifiers can also be imperfect in practice. For instance, two of the leading coding benchmarks, Human Eval and MBPP, both have false positives in their unit tests. That is, a model could output incorrect code and still pass the unit test. And once we account for these false positives, what we have are these inference scaling curves bending downwards. So rather than model performance continuing to improve, if there are false positives in your verifiers, the model performance sort of bends downwards, simply because the more you try, the more likely it is you'll get a wrong answer. And so this is also not a perfect solution to the problem of reliability. So what is the solution? I think the challenge for AI engineers is to figure out what sorts of software optimizations and abstractions are needed for working with inherently stochastic components like LLMs. In other words, it's a system design problem rather than just a modeling problem, where you need to work around the constraints of an inherently stochastic system. And I want to argue in the last 1 minute of my talk that this means looking at AI engineering as more of a reliability engineering field than a software or a machine learning engineering field. And this also brings me to the clear mindset shift that is needed to become successful from the perspective of being an AI engineer. If you look at the title slide of my talk, this title slide sort of pointed to one such area where we've already overcome certain types of limitations of stochastic systems. And that is with the birth of computing. The 1946 ENIAC computer used over 17,000 vacuum tubes, many of which, at the beginning of this process, used to fail so often that the computer was unavailable half the time. And the engineers who built this product knew that this is a failure from the point of view of the end users. So their primary job in the first 2 years of this computer was to fix the reliability issues, to reduce it to a point where it becomes well enough, it works well enough to become usable by the end user. And I say that this is precisely what AI engineers need to be thinking about as their real job. It is not to create excellent products, though that is important, but rather to fix the reliability issues that plague every single agent that uses inherently stochastic models as its basis. So this is what I'll leave you here with today. To become successful engineers, you need a reliability shift in your mindset, to think of yourselves as the people who are ensuring that this next wave of computing is as reliable for end users as possible. And there's a lot of precedent for this type of thing happening in the past. All right, with this, I'll leave you with the 3 key takeaways. It was a pleasure being here. Thank you.
Let's dive with our next presenters into Gemini deep research. Please join me in welcoming to the stage Staff ML Software Engineer of Google, Mukund Sridhar, and Product Manager of Google Gemini, Arush Selvan.
Cool. Hey, everyone. I'm Arush. I'm a product manager here at Google.
Hey, I'm Mukund. I'm a software engineer at Google working on deep research.
I don't know if people have had a chance to try deep research on Gemini or are familiar with the product, but you can try it if you go to Gemini Advanced, and if you scroll past 2.0 Flash, 2.0 Flash Thinking Experimental, 2.0 Flash Thinking Experimental with apps, 2.0 Pro Experimental, you will find 1.5 Pro with deep research, which is what we built. And if you have the chance to use it and you pay the $20, you'll see that it's a personal research agent that can browse the web for you to build the reports on your behalf. And so our motivation and what we want to talk about today is kind of why we built it, some of the product challenges we overcame, and some of the technical challenges you'll face if building a web research agent. So our motivation was really we wanted to help people get smart fast. We saw that research and learning queries are some of the top use cases in Gemini. But when you bring like really hard questions to chatbots in general, what we were finding is that it would often give you a blueprint for an answer rather than actually give you the answer itself, right? So we had this query that we used to throw around of like, tell me what does it take to get an athletic scholarship for shot put, and like how do I go get one? And often the answers would be things like, you should talk to coaches, you should find out how far you should be able to throw, and you should make sure you have good grades. But really what I want to know is like, okay, what are the grade boundaries? Like, how far do I need to actually be able to throw? I want something super comprehensive, and that's where we saw a big opportunity.
Yeah, so we said, what if you remove the constraints of compute and latency at inference time? Let Gemini take as long as it wants, browse the web as much as it needs, and see if we can trade that off for a much comprehensive answer for the user.
But you got to do it in 5 minutes, because beyond that, we don't have the chips. This brought a bunch of product challenges for us. Gemini, up to this point, is an inherently synchronous feature. It's a chatbot. And so we needed to figure out how do you sort of build asynchronous experiences in an inherently synchronous product. You also wanted to set expectations with users, right? Deep research is good for like one very specific thing. But a lot of user queries to Gemini are things like, what's the weather? Write me a joke. Things like that, where waiting 5 minutes is not going to get you a good answer, and we wanted to set expectations. And the last thing is, our answers can be thousands of words long, and we needed to figure out how do you make it easy for users to engage with really long outputs and in a chat experience. So let's walk through kind of the UX and kind of think about how we solve some of these, right? So imagine you're a VC, and everybody's talking about investing in nuclear in America, and so you come with this query like, hey, help me learn the latest technology breakthroughs in small nuclear reactors, and tell me interesting companies in the supply chain. So the first step, when you bring this query to deep research, is that Gemini will actually put together a research plan for you and present it in a card. And so this is the first way in which we're able to communicate with users. Like, this is different. This isn't your standard chatbot experience. Something's going to happen. You're going to hit start. But it's also an opportunity for us to actually show the user a research plan that they can edit and engage with, kind of like a good analyst, right? They wouldn't just get to work. They'd actually show you, OK, here's how I'm going to approach this. And it's a way for users to, if they want, kind of engage and steer the direction of the research further. Now, once you hit start, we actually try and show you what Gemini is doing under the hood in real time by showing you the websites it's browsing. And this is a feature that was built before thinking models, and thoughts are also a really great way of kind of showing transparency of what the model is thinking. But what's really nice here is while you wait, you can sort of click through the websites, dive into any of the content. But what we also inadvertently saw is people trying to game that number to see how high it could go. So we definitely saw people push that number into the thousands to try and see how many websites deep research could read. Finally, we kind of get this report that's thousands of words long. And we're really inspired by what Anthropic does with artifacts. And so we thought that was a really great way of sort of being able to pin an artifact so that users can actually ask questions about the research while reading the material. They don't have to scroll back and forth. And what's really neat about this is it means it's easy for you to engage in sort of changing the style of the report, adding sections, removing sections, asking follow-up questions. And it sort of makes that really easy. And the last part that's super important is kind of user trust and also doing right by the publishers. So we try and always show as all the sources we read as well as all the sources we used in the report, because not everything that we read is used, but it stays in context for follow-up questions. And also sort of these are all things that carry over to Google Docs as citations and things like that if you choose to export.
So I thought today we can pick some of the challenges that one has to encounter while building a research agent and talk through some of them. So I picked 4 for today. So one is this long-running nature of tasks introduces a couple of things that we need to look into. Second is the model has to plan iteratively and spend its time and compute during this time effectively. So what are those challenges there? And it has to do this while interacting with a very noisy environment that is the web. And as you do this and read through information, very quickly you can start seeing your context grow and how do you effectively manage context. So if you think about a job that runs for multiple minutes and something that can make many different LLM calls and calls to different services, there are bound to be failures, right? And today we're talking about of minutes, but you can very easily think in the future of these kind of research agents taking like multiple hours. So it's important to be robust to intermediate failures of these various services of various reliabilities. And so being able to build a good state management solution, being able to recover from errors effectively so that you just don't drop the whole research task due to one failure, that's one. The second aspect of doing this, what it enables us is to enable this feature cross-platform. So we believe more and more users will start kind of registering your asks or your research tasks and just like walk away, do their thing, and then you need to get notified. And this can happen now across devices, and you can pick off reading it once it's done. So now what is the model doing at through these few minutes? So let's take an example, right? So here we're looking for athletic scholarships for shot put. There are many facets to this query, and we kind of show this in a research plan like Arush showed. The first thing the model has to do is try to figure out which of these subproblems it can start tackling in parallel versus things that are inherently sequential, right? So the model has to be able to reason to do that. And the other challenge is, here you see, you're always going to land in this state where there's partial information. So it's important to look at all the information found so far before you decide what to do next. So in this instance, the model found, hey, it knows the qualifying standards for the D1 division, but in order to provide a complete report and answer the user's question, it has to go figure out what the equivalent for the D2 and D3 divisions are. So this notion of being able to ground on information you find and then plan your next step is key. Another example of partial information could be when you make searches. So in this case, we're trying to find the best roller coaster for kids. You might find results that provide partial information again. So here, you end up at a link which talks about the top 10 roller coasters, but does not mention anything about them being suitable to kids. So the planner has to recognize this fact and then go ahead and, in the next steps of planning, try to resolve this disambiguity. Another example of challenges in planning is information is often not found in one place. You find facets of information spread across different sources. So here, we're trying to find what would it take to get a certification for a scuba dive in some dive centers nearby. So you see one part or one source has the structure of what you have to go through to get a certification, but in a completely different source, you have this notion of the pricing for this diving center. So the model has to weave this together to figure out what the cost structure for such a certification would look like. Then there's the classic entity resolution problem. So you might find mentions of the same entity across different sources. So you need to be able to reason about some information indicators to kind of figure out if they're talking about the same entity, or you need to explore more to verify such disambiguities. I think most people here have worked on some notion of a web problem, and we know like it's super fragmented. So here you see two different websites talking about the same thing, about music festivals in Portugal this year. On the left, if you end up at such a website, it's easier and you get most of your information in one go. On the right, the layout is different. So having a robust browsing mechanism if you want to navigate the web for your research tasks is another important challenge. So like we saw, there is a lot of these intermediate outputs. And as you do this and you start getting streams of information during your planning, you can imagine your context size growing very quickly. The other challenge about context size is your research task doesn't typically end with your first query. People have follow-ups. People can say, hey, can you also do the same for this other topic? So there is like this kind of a follow-up deep research. And that also adds pressure on the context. We at Gemini have the liberty of really long context models. But even then, you have to design some way to make sure you effectively manage your context. And there are multiple choices here. Each come with various different trade-offs. We're showing one here where we kind of have like this recency bias. So you have a lot more information about your current and your previous tasks. But as you get to older tasks, we kind of selectively pick out things what we call as research notes and put it in a RAG. That way the model can still access it, but it's being selective. I'll hand it back to Arush to talk about what's next.
Yeah, so we were super excited to put this feature out in December. We weren't actually sure if anyone was going to use it, if anyone was going to care to wait 5 minutes for something. And we were really positively surprised by the reception. And really what we saw was, hey, we've built something that's maybe as good as like a McKinsey analyst, right? And we give it away for 20 bucks. But that's really great. And but what it does is it just retrieves from the open web, and it's a text-in, text-out only system, right? And so where we sort of see a few different directions of where research agents are going to go next. And the first one is around expertise, right? So how do you go from a McKinsey analyst to a McKinsey partner, or a Goldman Sachs partner, or like a partner at a law firm, right? So that's really around not just being able to aggregate information and synthesize it, but also think through the so what of what are the implications for what we're going to do, and what are the most interesting insights and patterns that come out of it. The other thing is, there are plenty of domains beyond professional services, like the sciences, where you want to get really good. You want something that can read many papers, form hypotheses, find really interesting patterns in what methods we used, and come up with novel hypotheses to explore. However, just because you build something that can be really smart doesn't mean that it's useful to someone, right? So if we were thinking about a use case of running a due diligence on a company, the way you'd present that information to me would be very different to the way you'd present that information to, say, a Goldman Sachs banker, right? For me, you really want to talk through what is this company and how's it positioned strategically. But a banker would want to know all the financial information, actually have a DCF that they could look at, right? Actually have a much more fine-grained financial modeling and analysis. And that really should shape the way in which you browse the web, right? The way you browse the web, the way you frame your answer, the kind of questions that you pursue should be very personalized to kind of meeting the user where they're at. I think the last part is sort of something that goes across domains of what models can do, right? So not just being able to do web research with text, but being able to combine that with abilities in coding, data science, even video generation, right? So coming back to this example, if you're doing a due diligence, what if it could go and do a lot of statistical analysis and actually build financial models to inform the research output that it gives you, right? Telling you, hey, why is this a good company or not? I should say Google doesn't give financial advice, and it's not a financial advisor. But yeah, and so we're really excited about the potential. We think there's a ton of headroom to make research agents better. And we are really glad we didn't call this Gemini Deep Dive, which was our best name before launching this feature. That's it. Thank you so much.
Thank you.
Our next presenter is member of technical staff at Anthropic, here to present how they build effective agents. Please join me in welcoming to the stage Barry Zhang.
You guys hear me? Yeah. All right, awesome. Wow, it's incredible to be on the same stage as so many people I've learned so much from. Let's get into it. My name is Barry, and today we're going to be talking about how we build effective agents. About 2 months ago, Eric and I wrote a blog post called Building Effective Agents. In there, we shared some opinionated take on what an agent is and isn't, and we give some practical learnings that we have gained along the way. Today, I'd like to go deeper on 3 core ideas from the blog post and provide you with some personal musings at the end. Here are those ideas. First, don't build agents for everything. Second, keep it simple. And third, think like your agents. Let's first start with a recap of how we got here. Most of us probably started building very simple features. Things like summarization, classification, extraction, just really simple things that felt like magic 2 to 3 years ago and have now become table stakes. Then, as we got more sophisticated and as products mature, we got more creative. one model call often wasn't enough. So we started orchestrating multiple model calls in predefined control flows. This basically gave us a way to trade off cost and latency for better performance, and we called these workflows. We believe this is the beginning of agentic systems. Now, models are even more capable, and we're seeing more and more domain-specific agents start to pop up in production. Unlike workflows, agents can decide their own trajectory and operate almost independently based on environment feedback. This is going to be our focus today. It's probably a little bit too early to name what the next phase of agentic system is going to look like, especially in production. Single agents could become a lot more general purpose and more capable, or we can start to see collaboration and delegation in multi-agent settings. Regardless, I think the broad trend here is that as we give these systems a lot more agency, they become more useful and more capable. But as a result, the cost, the latency, the consequences of errors also go up. And that brings us to the first point. Don't build agents for everything. Well, why not? We think of agents as a way to scale complex and valuable tasks. They shouldn't be a drop-in upgrade for every use case. If you have read the blog post, you'll know that we talked a lot about workflows. And that's because we really like them, and they're a great, concrete way to deliver values today. Well, so when should you build an agent? Here's our checklist. The first thing to consider is the complexity of your task. Agents really thrive in ambiguous problem spaces, and if you can map out the entire decision tree pretty easily, just build that explicitly and then optimize every node of that decision tree. It's a lot more cost-effective, and it's going to give you a lot more control. Next thing to consider is the value of your task. That exploration I just mentioned is going to cost you a lot of tokens. So the task really needs to justify the cost. If your budget per task is around 10 cents, for example, you're building a high-volume customer support system, that only affords you 30 to 50,000 tokens. In that case, just use a workflow to solve the most common scenarios, and you're able to capture the majority of the values from there. On the other hand, though, if you look at this question and your first thought is, I don't care how many tokens I spend, I just want to get the task done, please see me after the talk. Our go-to-market team would love to speak with you. From there, we want to de-risk the critical capabilities. This is to make sure that there aren't any significant bottlenecks in the agent's trajectory. If you're doing a coding agent, you want to make sure it's able to write good code, it's able to debug, and it's able to recover from its errors. If you do have bottlenecks, that's probably not going to be fatal, but they will multiply your cost and latency. So in that case, we normally just reduce the scope, simplify the task, and try again. Finally, the last important thing to consider is the cost of error and error discovery. If your errors are going to be high stake and very hard to discover, it's going to be very difficult for you to trust the agent to take actions on your behalf and to have more autonomy. You can always mitigate this by limiting the scope, right? You can have read-only access. You can have more human in the loop. But this will also limit how well you're able to scale your agent in your use case. Let's see this checklist in action. Why is coding a great agent use case? First, to go from design doc to a PR is obviously a very ambiguous and very complex task. And second, a lot of us are developers here, so we know that good code has a lot of value. And third, many of us already use Cloud for coding, so we know that it's great at many parts of the coding workflow. And last, coding has this really nice property where the output is easily verifiable through unit tests and CI. And that's probably why we're seeing so many creative and successful coding agents right now. Once you find a good use case for agents, this is the second core idea, which is to keep it as simple as possible. Let me show you what I mean. This is what agents look like to us. They're models using tools in a loop. And in this frame, 3 components define what an agent really looks like. First is the environment. This is the system that the agent is operating in. Then we have a set of tools, which offer an interface for the agent to take action and get feedback. Then we have the system prompt, which defines the goals, the constraints, and the ideal behavior for the agent to actually work in this environment. Then the model gets called in a loop, and that's agents. We have learned the hard way to keep this simple because any complexity up front is really going to kill iteration speed. Iterating on just these 3 basic components is going to give you by far the highest ROI, and optimizations can come later. Here are examples of 3 agent use cases that we have built for ourselves or our customers, just to make it more concrete. They're going to look very different on the product surface. They're going to look very different in their scope. They're going to look different in their capability. But they share almost exactly the same backbone. They actually share almost the exact same code. The environment largely depends on your use case. So really, the only 2 design decisions is what are the set of tools you want to offer to the agent, and what is the prompt that you want to instruct your agent to follow. On this note, if you want to learn more about tools, my friend Mahesh is going to be giving a workshop on Model Context Protocol, MCP, tomorrow morning. I've seen that workshop. It's going to be really fun, so I highly encourage you guys to check that out. But back to our talk. Once you have figured out these 3 basic components, you have a lot of optimizations to do from there. For coding and computer use, you might want to cache the trajectory to reduce cost. For search, where you have a lot of tool calls, you can parallelize a lot of those to reduce latency. And for almost all of these, we want to make sure to present the agent's progress in such a way that gain user trust. But that's it. Keep it as simple as possible as you're iterating. Build these 3 components first, and then optimize once you have the behaviors down. All right, this is the last idea, is to think like your agents. I've seen a lot of builders, and myself included, who develop agents from our own perspectives and get confused when the agents make a mistake. It seems counterintuitive to us. And that's why we always recommend to put yourself in the agent's context window. Agents can exhibit some really sophisticated behavior. It could look incredibly complex. But at each step, what the model is doing is still just running inference on a very limited set of contexts. Everything that the model knows about the current state of the world is going to be explained in that 10 to 20K tokens. And it's really helpful to limit ourselves in that context and see if it's actually sufficient and coherent. This will give you a much better understanding of how agents see the world, and then kind of bridge the gap between our understanding and theirs. Let's imagine for a second that we're computer use agents now, and then see what that feels like. All we're going to get is a static screenshot and a very poorly written description. This is by yours truly. Let's read through it. You're a computer use agent, you have a set of tools, and you have a task. Terrible. We can think and talk and reason all we want, but the only thing that's going to take effect in the environment are our tools. So we attempt a click without really seeing what's happening, and while the inference is happening, while the tool execution is happening, this is basically equivalent to us closing our eyes for 3 to 5 seconds and using the computer in the dark. Then you open up your eyes and you see another screenshot. Whatever you did could have worked, or you could have shut down the computer. You just don't know. This is a huge leap of faith. And the cycle kind of starts again. I highly recommend just try doing a full task from the agent's perspective like this. I promise you it's a fascinating and only mildly uncomfortable experience. However, once you go through that mildly uncomfortable experience, I think it becomes very clear what the agents would have actually needed. It's clearly very crucial to know what the screen resolution is, so I know how to click. It's also good to have recommended actions and limitations, just so that we can put some guardrails around what we should be exploring, and we can avoid unnecessary exploration. These are just some examples, and do this exercise for your own agent use case and figure out what kind of context do you actually want to provide for the agent. Fortunately, though, we are building systems that speak our language. So we could just ask Claude to understand Claude. You can throw in your system prompt and ask, well, is any of this instruction ambiguous? Does it make sense to you? Are you able to follow this? You can throw in a tool description and see whether the agent knows how to use the tool. You can see if it wants more parameter, fewer parameter. And one thing that we do quite frequently is we throw the entire agent's trajectory into Claude and just ask it, hey, why do you think we made this decision right here? And is there anything that we can do to help you make better decisions? This shouldn't replace your own understanding of the context, but it will help you gain a much closer perspective on how the agent is seeing the world. So once again, think like your agent as you're iterating. All right, I've spent most of the talk talking about very practical stuff. I'm going to indulge myself and spend one slide on personal musings. This is going to be my view on how this might evolve and some open questions I think we need to answer together as AI engineers. These are the top 3 things that are always on my mind. First, I think we need to make agents a lot more budget aware. Unlike workflows, we don't really have a great sense of control for the cost and latency for agents. I think figuring this out will enable a lot more use cases as it gives us the necessary control to deploy them in production. The open question is just what's the best way to define and enforce budgets in terms of time, in terms of money, and in terms of tokens, the things that we care about. Next up is this concept of self-evolving tools. I've already hinted at this 2 slides ago, but we are already using models to help iterate on the tool description. But this should generalize pretty well into a meta tool, where agents can design and improve their own tool ergonomics. This will make agents a lot more general purpose as they can adopt the tools that they need for each use case. Finally, I don't even think this is a hot take anymore. I have a personal conviction that we'll see a lot more multi-agent collaborations in production by the end of this year. They're well parallelized. They have very nice separation of concerns. And having sub-agent, for example, will really protect the main agent's context window. But I think a big open question here is how do these agents actually communicate with each other? We're currently in this very rigid frame of having mostly synchronous user assistant turns. And I think most of our systems are built around that. So how do we expand from there and build in asynchronous communication and enable more roles that afford agents to communicate with each other and recognize each other? I think that's going to be a big open question as we explore this more multi-agent future. These are the areas that take up a lot of my mind space. If you're also thinking about this, please shoot me a text. I would love to chat. OK, let's bring it all together. If you forget everything I said today, these are the 3 takeaways. First, don't build agents for everything. If you do find a good use case and want to build an agent, keep it as simple for as long as possible. And finally, as you iterate, try to think like your agent, gain their perspective, and help them do their job. I would love to keep in touch with every one of you. If you want to chat about agents, especially those open questions that I talked about, you'll be incredibly lovely if you can just jam on some of these ideas. These are my socials if you want to get connected. And I'm going to end the presentation on a personal anecdote. So back in 2023, I was building AI product at Meta. And we had this funny thing where we could change our job description to anything we want. After reading that blog post from Swyx, I decided I was going to be the first AI engineer. I really loved the focus on practicality and just making AI actually useful to the world. And I think that aspiration brought me here today. So I hope you enjoy the rest of the AI Engineer Summit. And in the meantime, let's keep building. Thank you.
Our next speaker works for a company that's built industrial-grade AI agents for consumer brands like Sonos, ADT, and SiriusXM. Here to give us a peek into how they do it is AI Product Manager at Sierra, Zach Renaud-Wadine.
Hey everyone, my name is Zach Renaud-Wadine. I'm going to be telling a few stories, and hopefully we'll leave you all entertained and with an idea of how we build agents and improve them at Sierra. So in a nutshell, Sierra is the conversational AI platform for businesses. And just poll of the room, out of curiosity, how many people have heard of Sierra? So most of the room, but not all. If you've heard of us, you probably associate us with chat experiences and perhaps with customer service. And that's a lot of what we do. But I would say that we're kind of broadening out in both cases. Probably by the end of this year, most of our interactions will be over the phone. So that's already a big area for us. And we'll also have a lot more touch points. We have a lot of customers, which I'll show today, who are using us for sales, for subscription management, for product recommendations, kind of all pieces of the customer experience. I noticed yesterday, were a lot of people here yesterday? Some people. So it was funny to watch. People were reflecting on how much has happened in AI, and they had these timelines, and they went way back in time. And so Colin from Augment Code went all the way back to 2023. Wasim from Writer was talking about purpose-built models and went all the way back to 2020. And Grace from Lux Capital went even further. She went back to 2019, although if you zoom in, you can see actually the first thing here is still from 2020. So everyone was reflecting on ancient history in AI, and it was all this decade. So I'm going to zoom back even further, 2016, in the AI caves. And I know what you're thinking. AI goes back to the 70s and all that, but it definitely felt like the caves in 2016. I know because if you zoom in on the bottom right, you can see I'm actually down there. I was working at Google with a bunch of amazing computer vision engineers. And what that meant in 2016 is we were really trying to help computers understand the difference between chihuahuas and blueberry muffins. And it's not actually that simple. It's not just chihuahuas and blueberry muffins. It's dogs and bagels, dogs and mops, and of course, dogs and fried chicken. And so in other words, what we were doing is we were building the first version of Google Lens. And at this time, I lived in New York City. I was in the East Village, and I had about a 30-minute walk to work. And on my walk, I would see a bunch of stuff. New York's one of the greatest walking cities in the world. And I would say, what's going on there? What are they even doing? Or, oh, I wonder if that bookstore is nice. Or, I wonder if this restaurant is tasty. Or, oh my goodness, look at that dog. And so there were also a bunch of flowers on the walk. At this time, Google Lens was in its infancy, and one of the very few things that computer vision models were actually good at that had some consumer application was identifying plants. You might still know this today. It's kind of in the, is that bug poisonous category. And so I'd ask questions on the walk like, can it tell the color of the plant in addition to the species? Or what's that? What type of fern or palm is that? And there's a bunch of flower shops on this walk, so I'd even walk in. And these are all actually photos from 2016 from my walks to work. And I would go in and test them all out. And as you can imagine, sometimes it was accurate. And sometimes it wasn't necessarily wrong, but it wasn't really on the nose either. And so it felt like a slot machine. And I think everyone here who's building with AI can probably understand that feeling of, oh, it worked 5 times in a row. Why didn't it work the 6th time? Whether it's the non-determinism of the inputs or the non-determinism of the outputs, that's just part of what it means to be building with AI. So let's fast forward a bit to present day. Google Lens, you can not only search what you see, you can also shop what you see. You can do this on Google Images, on YouTube, you can do it with your camera. You can translate non-Latin character sets into English so you can read the washing machine in Tokyo and actually figure out what settings in your Airbnb you should use. You can do your math homework. I'm a little bit too old to have benefited from this, but apparently it's a brave new world out there for the kids. And of course, this is from the Google Lens homepage. You can still identify flowers. So this is all very mind-blowing. But in my opinion, it comes down to consistent, step-by-step iteration over a decade. And when we think about what drives this, we're all engineers in the room. We understand that you need a process to iteratively improve, to get better without also getting worse. And this, over time, has kind of been considered software development lifecycle. How do you continuously improve? How do you implement, test, maintain, analyze, design, and go through this as many times as you can? Let's rewind a bit more. 2012. The AI caves, the drawings are a little bit less sophisticated. I'm not there yet. I've been ablated. And I pulled some headlines from around this time. You can see this is around when Google Brain was watching cat videos and identifying them on YouTube, and it was a big breakthrough. I don't know if anyone remembers how big this model was. It was about 1 billion parameters. And this was a huge breakthrough. If you think today, the frontier models are about 1 trillion parameters. So it was 1/1000th. It was as if this whole room had like 1/4 of a person in it. And so it was still very impressive at the time. There was also a theory, everyone thought computers would be limited in terms of what they can achieve. I think this is a less popular theory today. What I'm trying to say is it was a long time ago. This is also around the time that Marc Andreessen published his famous essay that said software is eating the world. And that took a lot of people by storm. If you looked at Stanford University on campus, You would have seen some early stage startups forming on the lawn. Does anyone know which startups I'm talking about? You can call it out. OK. You might be thinking Snapchat. Not that one. I did actually hear DoorDash in the back. Very good guess. Not that one either. Of course, you look like stylish people, so I think you'll know what I'm talking about. I'm talking about Chubbies. Chubbies had a contrarian idea that was also right, which was not only is software eating the world, but teeny shorts for men are also going to take over. And as I mentioned, they were correct, which you can see here, and you can also see here. Fast forward to 2024. Kit Garton, SVP of Commercial at Chubbies, we were fortunate enough to host her in Sierra's office. And Chubbies has had an amazing brand since they were founded, and they've always been on the forefront of customer experience. They've always been thinking about how to level up and how to make the experience more fun and better for their customers. And so it clicked immediately for Kit that the same way you needed a website in 1995, the same way your business needed a social profile and a mobile app this millennium, in 2025, you need an AI agent to represent your business and to help your customers. So Kit and Chubbies partnered with Sierra. We came up with an AI agent, which is affectionately called Duncan Smothers. First and foremost, he's incredibly capable, but almost as importantly, he's always down to clown. Duncan Smothers is on the Chubbies website and can help you with a variety of cases. I got permission from Kit to show some of these conversations to you today, so you can see what some of the Sierra interactions look like under the hood and some of the things that these agents are capable of. So on the left here, you have a customer asking a question about sizing and fit. Duncan is able to empathetically help them while asking questions like, what's your waist size? And offer product recommendations. At the end, he gets a thumbs up from the customer. Another example, another thumbs up. This is inventory tracking. Duncan can tell what's in stock and help customers choose new items. And then finally, package tracking and refunds. So more customer love. In this case, Duncan is able to inform the customer, actually, there's a couple different tracking numbers for your order. And in the second case, issue a refund. And so when we talk about autonomous agents, agents actually taking action, not just answering questions, this is what we're talking about. And the results for Chubbies have been they're able to help more customers more quickly and with higher satisfaction. The way that we get to this is because we believe at Sierra that every agent is a product. That means that you can't just drag and drop a bunch of boxes. You need a fully featured developer platform. You need a fully featured customer experience operations platform in order to work on this the same way you would work on your mobile app, the same way that you would work on your website if you want the best results. And so when Chubbies is partnering with Sierra, it's not just using the product. It's actually partnering with our team. And so we have dedicated agent engineering and agent product management functions that you can think of sort of as forward deployed with our customers, working closely with Kit and her team on a daily basis. By the way, remember that face that you just saw on the last slide? Was anyone here at the AI Engineering World's Fair back in June? Nice, got some whoops from the audience. So I know Ben was there. He's up there on stage introducing everyone, and the energy was electric. You can see the crowd is packed. When I got there, the first thing I did was I sat down at the DeepGram workshop. This was about 3 months into me building voice agents at Sierra, and I was very interested in what DeepGram had to say. What did they think of the latest multimodal models? How are they handling latency? How are they handling tone and phrasing? All of these problems that were new at the time. And I sat down next to a man named Sean. And Sean and I were nerding out about how to increase the speed of our developer loop by using the say command on Mac and then using a program called Loopback in order to pipe that into the browser so that we didn't have to wear headphones and talk and look awkward in the office. Sean gave me his contact info. He was interested in Sierra. And a few months later, there we are working together in the office. So when I told our company and our founders, hey, I'm going to the AI Summit, I hope it's as productive as the last one. I'm excited to learn. They said, go find more Seans. So I'm hopeful that people in the audience will say hi after this. Whether or not you're interested in working at Sierra, I'm interested in meeting you. And so I hope to meet you later today. Anyway, back to Duncan Smothers. The point of the software development lifecycle, the point of our agent engineering team, is that even if Duncan is not perfect today, he should be getting better every single day. And so what we did is we sought out to build something like the software development cycle, borrowing as many concepts as we could and inventing new ones where we needed to. The issue is that large language models are like building on top of a foundation of Jell-O. And so you can't just take everything out of the box and have it just work. While traditional software is deterministic, fast, cheap, rigid, and governed by if statements that always follow logic, large language models can be non-deterministic. They can be slow. They can be expensive to run. They're very flexible, though. They're creative. They can reason through problems. And so we wanted to create a methodology that takes advantage of all the strengths of large language models and then also is able to invoke traditional software where it's helpful. And that brings me to slide 78, the agent development lifecycle. So at Sierra, this is the process by which we build and improve AI agents. You might be thinking about it like, oh, that looks kind of like the software development lifecycle. And I think the devil is in the details, so I'm going to dive in a little bit. It's not that these are revolutionary or innovative concepts. It's that each one of them involves iterative refinement with customers in production to make it as productive and as bulletproof as possible. So if we dig into quality assurance, for example, if you work at one of our customer companies, you have access to Sierra's Experience Manager. What that means is that you can dive in and look at every conversation, and you can look at high-level reports of how is the agent performing in real time. You can provide feedback. So, for example, if Duncan Smothers has incorrect inventory, maybe it made one API call to one warehouse, but it didn't make all the API calls that it needed to, or one of them timed out, whatever it may be. You can report this issue. It then will lead to an issue being filed, which leads to a test being created, and then once that test is passing, we can make a new release. And over the course of time, a Sierra agent will go from having a handful of tests at launch to hundreds and then thousands of tests as it improves. Another example here is it's not always that the agent is making a mistake. Sometimes there's an opportunity to go above and beyond. Chubby's actually has each of its agents have a budget in order to delight customers. And so in this case, Duncan Smothers could actually DoorDash the shorts from a retail location if they're not available online. So this is the agent development life cycle at work. But the thing is, a year ago, we were doing this all manually. This was kind of early on in the history of Sierra, and we were learning what works at each of these stages. And with the improvements to AI, we're actually able to add AI to each part of this life cycle and speed up the improvements in the present day. But it's bigger than just Duncan. The agent development lifecycle is more effective the larger the customer is. And while Duncan handles hundreds of thousands of requests, we have customers that are doing tens of millions. So the more valuable the velocity and change management are when you're that big. And the change also comes from everywhere. It's not just that, oh, there's an issue with the agent and we need to improve it. There's tons of stuff going on outside. There's all those graphs at the beginning of this presentation showing how fast our space is moving. You have models being upgraded. You have new paradigms like reasoning models. You have multimodality, and more and more. When we think about how these impact the agent development lifecycle, reasoning models are a force multiplier toward each step. We're actually able to be more effective applying AI to development, to testing, to QA, and every step in between. Now, another one that's near and dear to my heart, I mentioned the DeepGram workshop 8 months ago, which was an accelerant in my understanding of the voice landscape, is building for voice. And I started working on this about a year ago, and in October, we were able to launch voice generally available at Sierra. One of our large customers that has benefited from the agent development lifecycle that has tens of millions of customers in the United States is SiriusXM. And with Sierra's voice capabilities, they're able to pick up the phone right away every time to answer their customers. The way that we think about voice, I think, is similar to the way that we think about web development today. If you remember 10, 15 years ago, a lot of websites were m.website.com. You had 2 separate websites for mobile phones and for desktops. And then we graduated to responsive design. And this is how we think about our AI agents at Sierra too. Under the hood, it's the same platform, it's the same agent code, but it's able to be responsive to whatever channel someone reaches out in and whatever modality you're operating in. Of course, you can still customize the same way you might have a different layout. You can still have different phrasing. You can still parallelize requests to achieve lower latency. But it basically just works out of the box. I'll close with a few thoughts. This is something I've been thinking about a lot lately. One of the most fascinating and fun parts about building with AI is that large language models remind us of ourselves. In short, they're unpredictable, they're slow, and they're not that great at math. But also, it allows us to be great designers by having empathy in a way that we probably couldn't ever before with computers. And so you can actually put yourself in the shoes of the robot. You can put yourself in the, I don't know, primordial soup of the Jell-O. And you can think about what it would mean to actually build a good experience. And as someone who's building voice agents, and a bunch of you I bet in the audience are, I know there's kind of this thought on, are these multimodal agents the real deal? You know, should I just kind of wire everything together and hope it works? And the question I've been asking myself a lot lately, and what our results have kind of shown us is, you know, how would you do if someone just passed you transcribed text of your conversation partner with a few hundred milliseconds of delay, and then you had to respond on the spot? And so what we're building at Sierra is much more robust and very exciting to me. And I hope to talk to you all about it. I think on my badge it says voice-to-voice models is the thing that I'm excited about. And so here is kind of a sense of the robustness and the richness of what you can create when you let large language models have the same inputs and same experiences that humans have. And so thank you for your time today. I look forward to a lot of engaging discussions, and it's great to talk to you all.
Our next presenter is a researcher at Morgan Stanley. Please join me in welcoming to the stage Will Brown.
Hello, everyone. Thanks, swyx and the whole AI Engineer Conference team for putting this together and having me. I am Will Brown. I am a machine learning researcher at Morgan Stanley. And today I want to talk to you all a bit about what I think reinforcement learning, or RL, means for agents. So I was in grad school at Columbia for a while, and I mostly worked on theory for multi-agent reinforcement learning. And over the past couple of years, I have been working at Morgan Stanley on a wide range of LLM-related projects, some of which look kind of like agents, but I will not really be talking too much about that today. I'm also relatively active on X, the Everything app, and that will become relevant later in the talk. This talk, I think, will be probably a little different from most of the talks at the conference. It's not about things we ship to prod. It's not about things that definitely work and you should go do tomorrow that are like proven science or best practices. It's about where we might be headed, and I want to really just tell a story that will synthesize some things that have been happening in the broader research community, and where these trends might be pointing, do some speculation, and also talk about some recent open source work of my own. And the goal of this is to help you plan and understand what reinforcement learning means, what it means for agents, and how to best be ready for a potential future which may involve reinforcement learning as part of the agent engineering loop. So where are we today? Most LLMs that we work with are essentially chatbots. I think it's helpful to think about OpenAI's 5 levels framework here. So we did pretty well with chatbots. Seems like we're doing pretty well with reasoners. These are great models for question answer. They're very helpful for interactive problem solving. We have the O1, O3, R1, Grok 3, Gemini, et cetera, models that are really good at kind of thinking longer. And we're trying to figure out how we take all of this and make agents level 3. And these are systems that are taking actions. These are systems that are doing things that are longer and harder and more complex. And currently, the way we tend to do this is chaining together multiple calls to these underlying chatbot or reasoner LLMs. And we do lots of things like prompt engineering, tool calling, evals, ops, giving the models tools of their own to use, having humans in the loop, and the results are like pretty good. There's a lot of things that we can do, and then there's a lot of stuff that it feels like is around the corner that we're all imagining about AGI. but we're not really to the point yet where these things are going off and doing the things that we would imagine an AGI is really doing to the degree of autonomy that that would, I presume, entail. So I think it's useful a bit to distinguish between agents and pipelines. I think Barry's talk earlier was a good way to kind of frame this. I'm going to use pipelines to encapsulate what Barry called workflows. And I think these are really systems with fairly low degrees of autonomy, and there's a very non-trivial amount of engineering required to determine these decision trees to say, how does one action or call flow into another, how do we refine the prompts? And it seems like a lot of the winning apps in the agent space have very tight feedback loops. And so whether or not you want to call these agents or pipelines, these are things where a user is interacting with some sort of interface, they're telling it what to do, the thing will do some stuff, and come back relatively quickly. Things like the IDEs like Cursor, Windsurf, and Replit, and search tools that are really good at harder question answer, maybe with some web search or research integrated. But there's not that many agents nowadays that will go off and do stuff for more than 10 minutes at a time. I think Devin, Operator, and OpenAI's deep research are the three that really come to mind as like feeling a little more in the like autonomous agent direction. And I think a lot of us might be wondering, how do we make more of these? And the kind of traditional wisdom is like, okay, we'll just wait for better models. Once better models are around, we can just like use those, we'll be good. But I think it's also to kind of take note of like the traditional definition of reinforcement learning and what an agent means there, which is this idea of a thing that is interacting with an environment with a goal, and the goal and this system is designed to learn how to get better at that goal over time via repeated interaction with the system. And I think this is something that a lot of us are either doing manually or don't really have the tools to do, which is once we have our thing, that it's set up to make the calls we want, and the performance is like 70%, and we've done a lot of prompt tuning, and we wanted to get it up to 90%, but we just like don't have the models to do it, or the models struggle to get the success. What's our path forward? And so in terms of model trends, I think I won't spend too much time talking about this, but pre-training seems to be having diminishing returns to capital at least. We're still seeing kind of like loss go down, but it does kind of feel like we need new tricks. Reinforcement learning from human feedback is great for making kind of friendly chatbots, but it doesn't really seem to be continually pushing us at the frontier of smarter and smarter and smarter models. We talk a lot about synthetic data, and I think synthetic data is great for distilling larger models down into smaller models to have kind of really tiny models that are really performant. But on its own, it doesn't seem to be an unlock for like massive capabilities getting better and better, unless we throw in verification in the loop or rejection sampling or any of these things. And that really takes us to the world of reinforcement learning, where this seems to be the trick that unlocked test time scaling for O1 models and R1. It's not bottlenecked by needing manually curated human data, and it does seem to actually work. I think we all kind of took note about a month ago when DeepSeek released the R1 model and paper to the world, and I think this was really exciting because it was the first paper that really explained how you build a thing like O1. We'd had kind of speculation and some rumors, but they really laid out the algorithm and the mechanisms for what it takes to get a model to learn to do this kind of reasoning. And it turns out it was essentially just reinforcement learning, where you give the model some questions, you measure if it's getting the answer right, and you just kind of turn this crank of giving it feedback to do more like the things that worked well and less like the things that didn't work. And what you end up seeing is that the long chain of thought from models like O1 and R1 actually emerges as a byproduct of this. It wasn't kind of manually programmed in where the models were like given data of like 10,000 token reasoning steps. This was the thing the model learned to do because it was a good strategy. And reinforcement learning at the core is really about identifying good strategies for solving problems. It also seems like open source models are back in a big way. There's a lot of excitement around the open source community. People have been working on replication efforts for the O1 project and have also been trying to distill data from O1 down into smaller models. And so what next? How does this relate to agents? I think it'll be helpful to know a little bit about how reinforcement learning works. The key idea is to explore and exploit. So you want to try stuff, see what works, do more of the things that worked, less of the things that didn't. And so in this feedback loop, demonstrated here in the image, we can see a challenge where a model is supposed to be writing code to pass test cases, and we give it rewards that correspond to things like formatting, using the right language, and then ultimately whether or not the test cases are passing. And so this is kind of a numerical signal that rather than like training on data, where we were kind of curating this in advance, we are letting the model do synthetic data rollouts and seeing scores from these rollouts, which then are fed back into the model. And so the GRPO algorithm, which maybe some of you have heard about, is the algorithm DeepSeek used. I think it's less of like a technical breakthrough in terms of it being a really important new algorithm to study, but I think it's very conceptually simple. And I think it's a nice way to think about what reinforcement learning means. And the idea really is just that you, for a given prompt, sample n completions, you score them all, and you tell the model, be more like the ones with higher scores. This is still in kind of the single-turn reasoner model, non-agentic world. And so the challenges that lie ahead are going to be about how do we take these ideas and extend them into more powerful, more agentic, more autonomous systems. But we do know that it can be done. So OpenAI's deep research still has a lot of questions that we do not know the answers to about how it works, but they have told us that it was end-to-end reinforcement learning. And so this is a case where the model is taking up to potentially 100 different tool calls of browsing or querying different parts of the internet to synthesize a large answer. And it does seem, I think, to many people's vibe check opinions, very impressive. But it also is like not AGI in the sense of you can't get it to go like work in a repo or like solve hard software engineering tasks. And people have kind of anecdotally found that it does struggle a bit for like out of distribution tasks, or like if you want it to fill out a table with like 100 very manual calculations, it can struggle there. And so it seems like reinforcement learning, on one hand, is a big unlock for new skills and more autonomy, but it's not a thing that so far has granted us agents that can just do everything and know how to solve all kinds of problems. But it is a path forward for teaching a model skills and having the model learn how to get better at certain skills, particularly in conjunction with environments and tools and verification. And so there is infrastructure out there for doing this on our own, kind of. A lot of it is still RLHF style, by which I mean it's about kind of single-turn interactions where the goal is we have reward signals that come from kind of human data that has been combined into a reward model. And if we want to have RL agents becoming part of our systems, maybe we will get really good API services from the large labs that let us build these things and hook into GPT, whatever, or Claude, whatever, and train these sorts of models on our own with fine-tuning. But we also don't really have these options yet. OpenAI has kind of teased their reinforcement fine-tuning feedback, but it's not multi-step tool calling yet. And so I think if we want to plan ahead, it's worth kind of noting and asking, what would this ecosystem look like? And there's a lot of unknown questions like how much this will cost? How small can the models be? Will it generalize across tasks? And how do we design good rewards and good environments? And there's a lot of opportunity here. Open source infrastructure, there's a lot of room to build and grow and determine what the best practices are going to be, what the right tools will be, as well as companies that can build tools to support this ecosystem, whether or not they're already in the fine-tuning world or not, and services for supporting this kind of agentic RL. And I think also it is worth thinking about things that are like not literal RL in the sense of training the model, but at the prompt level, there's all sorts of automation we can do. So if you've used DSPy, I think that is kind of adjacent to RL in the flavor of having a signal that we can then bootstrap from to improve our underlying system based on improving some downstream scores. Now I want to share a story with you about a single Python file I wrote a couple weeks ago. So this was the weekend after R1 came out, and I'd been reading the paper and thought it was really cool. We had not had the NVIDIA stock crash quite yet. I was just playing around with some experiments. I was taking a trainer from Hugging Face that had the GRPO algorithm, and I was getting a really small language model, Llama 1B, to do some reasoning and then give an answer for math questions. And I started with like a pretty simple system prompt, and I was just training the model to let it see what it did, and I had kind of manually curated some rewards in terms of what the scoring function should look like. And I just kind of like tweeted it out, where I had an example of the model kind of looking like it's doing some self-correction and showing that the accuracy gets better, as well as the length of response will initially drop once it learns to kind of follow the format. Then it goes back up as it learns to kind of take advantage of longer chains of thought to do its reasoning. And this was not the first thing to replicate in any sense. I wouldn't really call it a true replication. It was far from the most complicated, and I think that actually caught a lot of people's imaginations, and it became kind of a thing. So over the next 2 weeks after that, it just took on a life of its own where a lot of people were kind of tweeting about it and forking it and making modifications to it and making it something you could run in a Jupyter notebook, making it more accessible, writing blog posts about it, and it was interesting. because it, to me, didn't feel like a thing that kind of merited this level of excitement. But what I think was catching people's imagination was that it was one file of code. It was really simple, and it invited modification in a very user-friendly, engaging way, which I like to call rubric engineering. And so the idea of rubric engineering here is that, similar to prompt engineering, to have a model do reinforcement learning, it's going to get some reward. But what should this reward be? In the most simple version, it's just like, did it get the question right or wrong? Like, does A equal B? But there's a lot more you can do beyond this. And so I think the single file of code exposed examples of this where you can give the model points for things like following this XML structure. Like if it gets a certain tag right, you give it +1 point. If it has an integer answer that's still the wrong answer, but it's learned that the format should be an integer answer, get some points for that. And there's a lot of room here for getting creative and for designing rules that are not just downstream evals to, for our own sake, know whether a thing is working, but to allow the model itself to know whether it's working and use that as feedback for going further and training more. And this is very early stages. There's a lot of things we don't know, and I think there's a lot of opportunity to get creative and explore and try things out, such as using LLMs to design these rubrics, auto-tuning these rubrics, or auto-tuning your prompts with frameworks like DSPy, incorporating LLM judges as part of the scoring system. And then also, I think reward hacking is an issue to be very cautious of, where the idea is you want to ensure that the reward model you're using is actually capturing the goal, and it doesn't have kind of these backdoors where a model can kind of cheat and do something else that ultimately results in it kind of getting a super high reward without learning to do the actual task. And following this, I have been trying to learn from those lessons of what I saw people using out in the wild and make something that is a little more robust and usable for actual projects beyond just one file of code. This has been a kind of very recent effort. It's not a thing that I'm telling you to go use for all your problems tomorrow, but I think it's my attempt at doing some open source research code that will help people potentially try these things out easier and answer some questions about this. And so what this really is it's a framework for doing RL inside of multi-step environments. So the idea here is that lots of us have built these great agent frameworks for using API models, and the hope would be that we can leverage those existing environments and frameworks to actually do RL. So here the idea is you can just create this environment thing that the model plugs into, and you don't have to worry about the weights or the tokens. You can just write an interaction protocol, and then this gets fed into a trainer. And so once you build this environment, you can just kind of let it run and have a model that, once you give it some rewards, learns to get better and better over time. And to conclude, I want to talk about what I think AI engineering might look like in the RL era. So this is all still something that is very new. We don't know whether the off-the-shelf API models are going to just work for the tasks we throw at them. It might be the case that they do. It might be the case that they don't. One reason I think that they might not be the entire solution is that it is really hard to include a skill in a prompt. You can include knowledge in a prompt, but a lot of us, when we try something, we don't nail it the first time, and it takes a little bit of trial and error. And it seems to be the case that models are like this as well, where a model does get better at a thing and really gets a skill nailed down by trial and error. And this has been the most promising unlock we've seen so far for these higher autonomy agents like deep research. Fine-tuning might still be important. I think a lot of people wrote off fine-tuning for a while because open models were far enough behind the frontier that like a prompted frontier model API was just going to beat a smaller fine-tuned model. I think, one, we're now seeing the open and closed source gap be close enough that this is less of a concern. A lot of people are using open source hosted models in their platforms. And also, RL, the most kind of true version of RL that DeepSeek did for their R1 model, that OpenAI has talked about doing for deep research, requires doing some reinforcement learning. There's a lot of challenges here. There's a lot of research questions we don't know the answers to. But there's a lot of things that I think these skills we've learned from doing AI engineering over the past couple of years translate very directly to, which is that the challenge of building environments and rubrics is not that different from the challenge of building evals and prompts. We still need good monitoring tools. We still need a large ecosystem of companies and platforms and products that support the kinds of agents we want to build. So I think all the stuff we've been doing is going to be essential. And it's worth looking ahead a little bit to see if we end up in a world where we have to do a little bit more reinforcement learning to unlock things like true autonomous agents or innovators or organizations that are powered by language models. What does that look like? We will find out.
Ladies and gentlemen, please welcome back to the stage MC for the AI Engineer Summit, Agent Engineering Day, the founder and CEO of SuperIntelligent, NLW.
All right, awesome first session. Thank you all for being here. Thank you, Will, for a great way to close us out and for all the other great presenters as well. Quick clarification before I let you guys go tonight. So there is no on-site after party. The expo closes at 4 p.m. The venue closes at 6 p.m. However, there are a number of affiliated events. If you check the website homepage for info and RSVP instructions, that's all there. But again, expo closes at 4. This venue closes at 6. So we'll be wrapping up conversations and evening plans at around 5:30. With that, we wrap block one. And so we're going to do a 30-minute break now. If you want to check out and have discussions with the speakers, the Q&A lounges are available to meet them. The first one is on the first floor to the right as you exit the theater, and there are 2 downstairs as well. Also, we recommend making time to stop by the Sponsor Expo. You're going to find coffee, snacks, and also the amazing products and services of our sponsors. So thank you very much, and we will see you back here in about half an hour.
Please welcome to the stage MC for the AI Engineer Summit, Agent Engineering Day, founder and CEO of SuperIntelligent, NLW.
All right. Welcome back to another excellent session. This sprint is really, really interesting. We have sessions from Jane Street about how they do AI engineering, challenges to scaling agents by Bloomberg, a session on trusting but verifying from Brightwave, and kicking it off, we'd like to welcome to the stage Brennan Rosales to talk about agents and investment management at Aladdin Copilot from BlackRock.
Our next presenter is a software engineer at Jane Street, presenting how they build AI-powered developer tools. Please join me in welcoming to the stage John Crepesi.
Sorry. My name is John Crepesi, and I work on a team at Jane Street called AI Assistants. Our group roughly is there at Jane Street to try to maximize the value that Jane Street can get from large language models. And I've spent my entire career in dev tools. Before I worked at Jane Street, I was at GitHub for a long time, and then before that, I worked at a variety of other dev tools companies. And LLMs kind of present this really amazing opportunity in that they're so open-ended that we can build kind of anything that we can imagine. And it seems like right now, the only thing moving faster than the progress of the models is kind of our creativity around how to employ them. At Jane Street, though, we've made some choices that make adoption of off-the-shelf tooling a little bit more difficult than it is for other companies. And kind of the biggest reason that we have this problem is that we use OCaml as a development platform. For those not familiar with OCaml, it is a functional, very powerful language, but it's also incredibly obscure language. It was built in France, and its most common applications are in things like theorem proving or formal verification. It's also used to write programming languages. We use OCaml kind of for everything at Jane Street. So just a couple quick examples. When we write web applications, of course, web applications have to be written in JavaScript. But instead, we write OCaml, and we use a library called JS of OCaml that is essentially a OCaml bytecode to JavaScript transpiler. When we write plugins for Vim, those have to be written in Vim script. But we actually use a library called vCaml, which again is OCaml to Vim script transpiler. And even people at the company that are working on FPGA code, they're not writing Verilog, they're writing in an OCaml library called HardCaml. So why are the tools on the market available not good for working with OCaml? I think it kind of comes down to a few primary reasons. The first and the most important is that models themselves are just not very good at OCaml. And this isn't the fault of the AI labs. This is just kind of a byproduct of the amount of data that exists for training. So there's a really good chance that the amount of OCaml code that we have inside of Jane Street is just more than like the total combined amount of OCaml code that there exists in the world outside of our walls. The second is that we've made things really hard on ourselves. Partially as a byproduct of working in OCaml, we've had to build our own build systems. We built our own distributed build environment. We even built our own code review system, which is called Iron. We develop all of our software on a giant monorepo application, and just for fun, instead of storing that monorepo in Git, we store it in Mercurial. And at last count, 67% of the firm uses Emacs instead of normal editors, maybe like VS Code. We do have people using VS Code, but Emacs is the most popular. And the last thing is we're dreamers. I mean, kind of everyone in this room hopefully is a dreamer in a way. And what I mean by this is we want the ability to kind of take LLMs and apply them to different parts of our development flow and light up different parts. So maybe we want to use large language models to resolve merge conflicts or build better feature descriptions or figure out who reviewers for features be. And we don't want to be hampered by the boundaries between different systems when we do that. Over the next 15 minutes, I'm going to cover our approach to large language models at Jane Street, particularly when it comes to developer tools. I'm going to talk about custom models that we're building and how we build them. I'm going to talk about editor integrations. So these are the integrations into to VS Code, Emacs, and NeoVim. And I will talk about the ability that we've built over time to evaluate models and figure out how to make them perform best. And I guess at first glance, it's not really obvious that training models at all is a good idea. I mean, it's a very expensive proposition. It takes a lot of time, and it can go wrong in a ton of different ways. Who here has trained a model before or tried to train something like a model? Maybe you took a foundation model and trained on top of it. Cool. We were more convinced after we read this paper. This is a paper from Meta about a project called Code Compose. And in this paper, they detail their results fine-tuning a model specifically for use with Hack. Hack is actually pretty similar to OCaml, not in its like syntax or function, but really just in the fact that it's used primarily at one company and not really used much outside of that company, even though it's open source. So, oh, actually, a fun fact, Hack is implemented in OCaml. I think that's just like a total coincidence, but we were pretty naive early on. We read this paper, and we decided that it would be really cool if we could replicate the results. We thought we would just take a model off the shelf, we would show it a bunch of our code, and then we would get back a model that worked like the original model, but knew about our libraries and idioms. It turns out that's just not how it works. It's not that easy. In order to get good outcomes, you have to have the model see a bunch of examples that are in the shape of the type of question that you want to ask the model. So we needed to first create a goal, a thing that we wanted the model to be able to do. And in our world, the goal that we came up with was this. We wanted to be able to generate diffs given a prompt. So what that means is we wanted a user inside of an editor to be able to write a description of what they wanted to happen, and then have the model suggest a potentially multi-file diff. So maybe you want to modify the test file, an ML file, and an MLI, which is kind of like a header file. We wanted the diffs to apply cleanly, and we wanted them to have a good likelihood of type checking after they had been applied. And we were kind of targeting this range of up to 100 lines as an ideal zone of what we thought LLMs would actually be capable of. And in order for that to work, we needed to collect data, like I was talking about before. We needed data of the training shape that looked just like the test shape. And this is what that shape looks like for this task. You need to be able to collect a bunch of examples of what context the model would have had beforehand, and then some prompt of what you want the model to do, written hopefully in the same way that a human would write it, and then some diff that would accomplish that goal. So context, prompt, diff, and we need a bunch of these examples. So how do we get these? How do we get these training examples? Kind of the first place to look is features. Features is, I mentioned a code review system that we built internally. This is what it looks like. It's called Iron. Features are very similar to pull requests. I think you can just swap that term in your head. And features at first glance have exactly the data they want. On the description tab, they have a human-written description of a change. And on the diff tab, they have the code that accomplishes the goal of the developer. But on closer look, they're not exactly what you want, right? The way that you write a feature description or a pull request description is really very different from what you might want to say inside of an editor. So you're not writing multiple paragraphs in the editor. You're just saying something like, fix that error that's happening right now. And that's just not how we write feature descriptions. Another problem with these features or pull requests is that they're really large, right? Often it's a feature is 500 lines or 1,000 lines. So in order to use it as training data, we would need to have an automated way to pull features apart into individual smaller components that we could train on. So we need smaller things than features. What are those? Well, maybe commits. Commits are smaller chunks than features. This is what a typical commit log looks like at Jane Street. So this is not like a Git short log. This is literally just like an actual, I want you to look at this as an actual Git log. And where it says summary Z, that's my commit message. We don't really use commits the same way that the rest of the world uses them. So we use commits mostly as checkpoints between different parts of a development cycle that you might want to revert back to. Commits don't have a description, and they also have the same problem in that they're not isolated changes. They're a collection of changes. What we actually ended up with was an approach called workspace snapshotting. And the way that that works is we take snapshots of developer workstations throughout the workday. So you can think like every 20 seconds, we just take a snapshot of what the developer's doing. And as we take the snapshots, we also take snapshots of the build status. So this is the build that's running on the box. We can see what the error is or whether the build is green. And we can kind of notice these little patterns. If you have a green to red to green, that often corresponds to a place where a developer has made an isolated change, right? You start writing some code, you break the build, and then you get it back to green. And that's how you make a change. Maybe this one, the red to green, this is a place where the developer encountered an error, whether that's a type error or a compilation error, and then they fixed it. So if we capture the build error at the red state, and then the diff from red to green, we can use that as training data to help the model be able to recover from mistakes. The next thing we need is a description, and the way that we did that, we just used a large language model. So we had a large language model write a really detailed description of a change in as much words as it possibly could, and then we just kept filtering it down until it was something that was around the right level of what a human would write. So now we have this training data, and training data is kind of only half the picture of training a model. So you have the supervised training data, and then you need to do the second part, which is the reinforcement learning. This is really where models get a lot of the power, right? We align the model's ability to what humans think is actually good code. So what is good code? I guess on the surface, good code is, I mean, it's code. It has to parse as code, meaning if a piece of code doesn't go through the OCaml parser and come out with a green status, that is not good code, I would say, by most definitions. Good code in OCaml, because it's statically typed, is code that type checks. So we want to have good code be code that, when it is applied on top of a base revision, can go through the type checker, and the type checker agrees that the code is valid. And of course, the gold standard is that good code is code that compiles and passes tests. So ideally, during the reinforcement learning phase of a model, you could give the model a bunch of tasks that are like verifiable. We have the model perform some edit, and then we check whether or not it actually passes the test when applied to the code. So we did that. We've done this as part of our training cycle, and we built this thing that is called CES. It's the Code Evaluation Service. You can think of it kind of like a build service, except with a slight modification to make it much faster. And that's that first we pre-warm a build. It sits at a revision and is green. And then we have these workers that all day just take diffs from the model, they apply them, and then we determine whether the build status turns red or green. And then we report that error or success back up to the build function. And through continued use of this service over the course of like months, we're able to better align the model to write code that actually does compile and pass tests. It turns out this exact same setup is the one that you would want for evaluation. So if you just hold out some of the RL data, you can also use it to evaluate models' ability to write code. Kind of looks like this. You give the model a problem, you let it write some code, and then you evaluate whether or not the code that it writes actually works. And training is hard, and it can have kind of catastrophic but hilarious results. So at one point, we were training a code review model, and this is a totally separate model, but the idea was we want to be able to give some code to this model and have it do a first pass of code review just like a human would do to try to save some of the toil of code review. We trained this model, we put a bunch of data into it, we worked on it for months, we were real excited, and we put our first code in for code review through the automated agent. It spun for a bit, and it came back with something along the lines of, I'll do it tomorrow. And like, of course it did that, because it's trained on a bunch of human examples, and humans write things like, I'll do things tomorrow, or I'll do this tomorrow. So it's not very surprising. So having evaluations that are meaningful is kind of a cornerstone of making sure that models don't go off the rails like this and you don't waste a bunch of your time and money. In the end, though, the real test of models is whether or not they work for humans. So I'm going to talk a little bit about the editor integrations that we've built to expose these models to developers at Jane Street. Kind of when we were starting building these integrations, we had 3 ideas in mind. The first idea was, wow, we support 3 editors. We have NeoVim, VS Code, and Emacs, and we really don't want to write the same thing 3 times. So ideally, we don't want to write all the same context building strategies and all of the same prompting strategies. We want to just write it once. The second is that we wanted to maintain flexibility. So we had a model that we were using at the time that was not a fine-tuned model. We were pretty convinced that a fine-tuned model was in our future. We wanted the ability to do things like swap the model or swap the prompting strategy out. And lastly, we wanted to be able to collect metrics. So in a developer, in their editor, developers care about latency. They care about whether or not the diffs actually apply. So we wanted to get kind of on-the-ground real experience of whether or not the diffs really were meaningful for people. This is the simplified version of the architecture that we settled on for this service. The AI development environment. Essentially, you have LLMs on one side, and then AID handles all of the ability to construct prompts and to construct context and to see the build status. And then we are able to just write these really thin layers on top of AID for each of the individual editors. And what's really neat about this is that AID sits as a sidecar application on the developer's machine, which means that when we want to make changes to AID, we don't have to make changes to the individual editors and hope that people restart their editors. We can just restart the AID service on all of the boxes. So we restart AID, and then everyone gets the most recent copy. This is an example of AID working inside of VS Code. So this is the sidebar in VS Code, very similar to something like Copilot, except this thing allows you to ask for it and get back multi-file diffs. And you can see it kind of looks like what you'd expect in VS Code. It's a visual interface that lays things out really nicely. This is what we built in Emacs, though. So in Emacs, developers are used to working in text buffers. They move around files. They want to be able to copy things the normal way that they copy things. So we actually built the 8 experience in Emacs into a markdown buffer. So users can move around inside this markdown buffer, they can ask questions, and then there are keybinds that essentially append extra content to the bottom of the markdown buffer. AIDS architecture lets us plug various pieces in and out, like I mentioned. So we can swap in new models, we can make changes to the context building, we can add support for new editors, which I think probably sounds far-fetched, but this is something we're actually just doing right now. And we can even add domain-specific tools. So different areas of the company can supply tools that are available inside of the editors, and they kind of end up in all the editors without having to write individual integrations. 8 also allows us to A/B test different approaches, so we can do something like send 50% of the company to one model and 50% to another, and then determine which one gets the higher acceptance rate. 8 is kind of an investment that pays off over time. Every time something changes in large language models, we're able to change it in one place downstream of the editors and then have it available everywhere. And things change like really often. We need to be ready when things change. What I've had time to show you today is only a small portion of what my team is doing. We've got a lot of other things going on. So we're finding new ways to apply RAG inside of the editors. We're applying similar approaches to what you've seen here to large-scale multi-agent workflows. We are working with reasoning models more and more. But the approach is the same through all of these. We keep things pluggable. We lay a strong foundation to build on top of. And we build the ways for the rest of the company to add to our experience by adding more domain-specific tooling on top of it. If you think what I've said is interesting and you want to talk more about this, I would love to hear from you. You can just find me outside, and thank you for your time.
Next up, the head of AI engineering at Bloomberg is here to present challenges to scaling agents for generative AI products. Please join me in welcoming to the stage Anju Kambador.
Oh man, it's really hard to see my photo that big or small. Thank you so much for inviting me. As I was trying to think what would be a good topic to present at this talk, the organizers were really nice, and so a lot of things that you'll hear today was influenced by what the organizers thought was important, because there are really so many things happening that are exciting to talk about in the agentic landscape. So let's get started. The first thing was late 2021, I think LLMs really were starting to capture the imagination. As a company, we've been investing in AI for almost 15, 16 years, so we decided we'll build our own large language model. Took all of 2022 to do that, and 2023 we wrote a paper about it. We had learned a lot about how do you build these models, how do you organize data sets for these, how does evaluation work, how do you coax performance in certain zones out of this. But then ChatGPT happened. I think the open weight and the open source community has come up so beautifully along. So while we continue to do very similar work, as a strategy, we pivoted to say, let's build on top of whatever is available out there. We have many, many different use cases, so I think we pretty much pivoted to say, we'll build on top. If it helps you in any way on how we are doing things, so there you go. The other was, I think there was a curiosity on how exactly does a company like Bloomberg organize its AI efforts. So I report to the global head of engineering, and we are organized somewhat as a special group, if you will. We work a lot with our data counterpart. Bloomberg has a really strong, large data organization that you can appreciate now helps us out a lot. We work with the product, the CTO in cross-functional settings. About 400 people, 50 teams, London, New York, Princeton, and Toronto. So that's a little bit about our group. Okay, so we've been building products using generative AI, starting with tools, more agentic for 12 to 16 months now. I think the effort has been really, really serious. And so there have been so many things we've had to solve in order to build something today using what's available today. And then I decided somebody must cover all of these topics, so I'm not going to talk about these at all, right? I think there are some wonderful speakers talking about this. I'll try to hang around a bit after this, and I'm really bullish on what the developments are in any one of those challenges that we need to solve. I think it gets easier and easier to solve those challenges. So please don't read these as being pessimistic. It's just realistic, right? I need to build and ship things today, and that means these are the things I need to deal with today. Again, we won't be touching on any of these topics today. So internally, it was really hard to say what's an agent and what's a tool because everyone kind of had their own vocabulary, and then this really nice paper came out. So when I'm talking today, when I say a tool, I mean on the left-hand side of that, it's Cognitive Architectures for Language Agents. If you haven't read it, you should try to read that paper. And then an agent is really like more autonomous, has memory, can evolve. So whenever I say agentic, it's on the right-hand side of the spectrum, and the other one is the left-hand side. So that's what my vocabulary will be. Finally, to set the stage for the talk, I don't know how many of you know about Bloomberg. I certainly did not know as much as I do today when I joined. So we are a fintech company, as you can imagine from my nice jacket or jumper. And our clients are in finance, but finance is a very diverse field. So I've listed here 10 different archetypes of people who are in finance, and they do very different activities, but they also do a lot of similar activities. And so what is like a short form of thinking what Bloomberg does? We both generate and accumulate a lot of data. This is unstructured and structured, so news, research, documents, slides. We also provide access to websites. There's a lot of reference data, market data coming in. So if you just want to know the scale, every day we get 400 billion ticks of structured data information, about 1 billion plus unstructured messages, millions of well-written documents which include news, and this is just every day, and we have over 40 years of history on it. So when we say we offer information as one of the things to our clients, this is the scale at which we are working. The rest of this talk, I will, as you can imagine, we are building a very broad set of products. So to focus the talk, I'll talk about one particular archetype, a research analyst. If you didn't know what a research analyst does, here is a short course. So there's a research analyst. They are typically an expert in a particular area. Think like, I'm a research analyst in AI or semiconductors or technology or electric vehicles. And the kinds of things they need to do on a daily basis are written at the bottom. So they are doing a lot of work with search and discovery and summarization, a lot of things with unstructured data on the left-hand side. They are doing a lot of work in data and analytics, structured data and analytics in the middle part of the segment. They are reaching out to their colleagues both to disperse and gather information, so there's a lot of communication. And then they're also, some of them are also building models, which means they need to normalize data. They need to actually program and generate models as well. So this is a research analyst in a nutshell. The other bit is, because we are in finance and we've been in finance for since founding 40 years ago, there are some aspects of our products that are non-negotiable, and those include things like precision, comprehensiveness, speed, throughput, availability, some principles like protecting our contributor and client data, making sure that whatever we build, there is transparency throughout. These are non-negotiables. It doesn't matter whether you're using AI or not. So these should ground you in the kinds of challenges we face when we use what's available today to build agents. Okay, so what was the first thing we did? Again, 2023 is when I think we got serious. So the first thing we did was, for the research in the zone of helping the research analyst community, companies, public companies in particular, they have scheduled quarterly calls that discuss the health of their company. They talk about their future. It's a conference call. A lot of analysts attend the call. There's a presentation by the company's executives, and then there's a Q&A segment. And during earnings season, it happens that on any given day, many, many of these things are happening. So I told you that a research analyst has to stay on top of what's happening every single day. So transcripts of these calls need to be generated. Again, AI is used. And in 2023, we saw an opportunity to say, well, we know what for every company which is operating in a particular sector, we know what are the kinds of questions are of interest, and maybe we can try to answer them for the analyst to take a look at, and that way they can be informed on whether they wanted a deeper dive or not, right? Seems like a simple product, and again, I'm talking about work that started in 23. So where the technology was, we still needed to do a lot to bring it to the market, keeping our principles and features in place. So what does it mean? Just focus on the right-hand side, if you will. Performance out of the box was not great, like precision, accuracy, factuality, things like that. And for those of you who are interested in ML ops, I think there was a lot of work done in order to just build remediation workflows and circuit breakers. Because remember, these summaries are not somebody just chatting with a transcript. It's actually published, and everyone gets to see the same summary, and anything that is an error has an outsized impact for us. So we constantly monitor performance, remediate, and then the summaries get more and more accurate. So a lot of, I think a lot of monitoring goes in behind it, a lot of CI/CD goes in behind it as well. Okay, so today, how are the products that we are building, how does the agentic architecture look like? Well, first of all, it's semi-agentic because this is an opinion, we don't yet fully have the trust that everything can be autonomous. So there are some pieces that are autonomous, the other pieces that are not autonomous. Guardrails is a classic example of, for example, Bloomberg doesn't offer financial advice. So if someone starts with, hey, should I invest in, then you need to catch it. We need to be factual. That's again a guardrail. So like those are not optional pieces for any agent. Those are coded in as you must do this check. So just keep this image in mind. It'll come back. Okay. So this is a talk about scaling. So with that long runway, let's get to scaling. So I just wanted to cover two aspects of scaling. I'm hoping that both these aspects will be more of a confirmation and not a surprise to any of you. So let's see. So the first thing is, if you want to build agents and you want each agent to evolve really quickly, because when you build the first time, unless you're a magician, it's going to suck a bit. And then it needs to improve and improve and improve, right? So how do you get there? Well, let's go back to how some really good software is built. When I was a grad student, I used matrix multiplication a lot. And this is a snapshot of the generalized matrix product. And if you read the API documentation, it lays out every aspect of the input, every error code, how long it will take is also available in documentation. It just works, right? And when you build software on top of such really well-documented, well-written software, your software also tends to be robust, your products tend to be robust. Even from 20 years ago, when we started using machine learning to build products, like there are tools like APIs that use models or pipelines of models behind them, you as a caller or a person downstream of such APIs, there is a bit of stochasticity, if I can pronounce it correct, involved, right? You don't quite know what the result will be, and you don't quite know if it'll work for you or not. And this is despite best intentions of establishing what the input distributions are and what the output distributions are. There's always a bit of stochasticity. It was still okay to work with them, and I'll tell you why it was okay to work with these. But when you enter using LLMs and agents, which are really compositions of LLMs, the errors multiply a lot. And that is something that causes a lot of fragile behavior. And we'll just take a look at it. And I hope my answer is mildly surprising to you on how to avoid the fragility. In 2009, we built a news sentiment product. It was basically to detect if a piece of news for a given company would be beneficial for that company or not. So the input distribution, we knew which news wires we were monitoring. We knew which language it was in. News wires also have editorial guidelines on how they write things. So while the API that sits in front of the model is not as clean as like matrix multiply, you still have a very decent handle on, okay, what is coming into my system? And the outputs are obviously just like, it's -1 to +1, pretty much. So like the output space is also very easy. Training data, we built it from scratch, so we know the training data. We could have really nice held out in time and space test sets, and then we could establish the risk of deploying this. We could monitor it. So despite all of this guardrail being present, we still ended up having a lot of out-of-band communication on anyone who's downstream of us. So for example, if you were consuming our stream of output on sentiment, we would give you a heads up. We would tell you that, hey, the model version is changing. If you have a downstream application using this as a signal, you want to test it out, things like that. This was the landscape that's changed a lot when you think about building agentic architectures. Like, you want to make improvements to your agents every single day. You don't want to have a release cycle where there is a purely batch regression test-based release cycle, because there are so many customers who are downstream of you who are also making independent improvements to your model. So I'll give you like one small example, right? So one of the workflows that we have agents for is, for a research analyst is, I told you that structured data is something that they look at. The question here is US CPI for the last 5 quarters, Q is just a quarter. There's an agent that deeply understands the query, figures out what domain it should dispatch to, and then uses a tool. There's an NLP front end to the tool, but uses a tool to basically fetch the data, right? Turns out that the data is wrong, and which is why you need the guardrails. The data is wrong because of one character that was missed. It fetched monthly data as opposed to quarterly data. And if you're actually building a downstream workflow where you're not even exposing the table, a good research analyst would catch it. But if you're not even exposing the table and you're just looking at an answer that says, well, it looks like the answer is 42, it's really hard to catch these compounding errors, which is why it is easier to not count on the upstream systems to be accurate, but rather factor in that they will be fragile and they'll be evolving, and just do your own safety checks. Even in, like, I'm talking about within my own org, people are independently operating. Every version of the data and analytics API tool that's coming out is better and better, but being better means being better on average. It doesn't mean it'll be better for you as a downstream consumer. So building in some of this guardrail, I just think is good sense, and that almost makes you go faster as you factor out individual agents, and each agent can evolve without having these handshake signals of, well, every downstream caller I have to make sure that they understand what's changed and they sign off that I can actually I can promote my new agent to like beta or production. I think we just need to like change that mindset and be more resilient. So that's one. The second thing is, as much as I used to code one fine day long ago, I'm a manager now, so I thought I'll talk about org structure, and I don't know how many of you will resonate with it. Bloomberg, like I said, we've been building these things for like 15 years, and traditional machine learning, it has a particular factorization of software, and that software factorization is then reflected in the org structure. If you are lucky, you have the reverse Conway law of design, but you really need to rethink that as you start using different tech stacks and start building different kinds of products. What do I mean? How many agents do you want to build? And what should each agent do? And should agents have overlapping functionality or not? These are some basic questions, and typically it's very tempting to just say, let's just keep our current software stack and see if we can build on top of that, or let's keep our current org structure and build on top of that. And so what I've learned is, on the columns here, you can see, the first 2 columns are vertically aligned teams, the next 2 columns are horizontally aligned teams. And there are some properties in the rows, and what we've learned, and we've actually done some reorgs, what we've learned are, in the beginning, you don't really know much on what the product design is going to be, and you want to iterate fast. It's just easier to like collapse the org, collapse the software stack, and just say, here's a team, go build what needs to be built and figure things out. And that's where you want like, really fast iteration. You want sharing of code, data, models, things like that. The more you have understood this for a single product or a single agent, the more you understand what its use is and what it's good at and what it's not. And you actually build many of these agents, and that's when you start thinking, okay, I can go back to the foundations of building good software and good orgs, and I want to have things like optimization on it. So I want to increase the performance, reduce the cost, make it more testable, make it more transparent. And that's where you move into the bottom right corner of the segment where you do have some horizontal. So in our case, like guardrails are horizontal. We don't want every team, every one of those 50 teams, like trying to figure out what does it mean for me to not accept user inputs that are thinly veiled financial advice inputs, right? Like it's something that you want to do horizontally, but you want to figure out for yourself what is the right time for you and your organization to start creating horizontals, to also start breaking out some of these monolithic agents, which are reflected again in your org structure, and start creating smaller and smaller pieces. So all that said and done, like, just again for the running example of a research agent, this is how it looks like today. So, I think taking in the user world and session context and deeply understanding what is the question and then figuring out what kinds of information are needed to answer that question. It's factorized as its own agent, reflected in the org structure. Similarly for answer generation, we have a lot of rigor around what constitutes a well-formed answer. Again, that's factored out. I call it semi-agentic, like I alluded to before, because we do have guardrails that are non-optional. There is no autonomy there. You have to call it at multiple points. And then, yeah, like we build on top of like years of traditional and more modern forms of data munging. Like, your sparse indices have become dense and hybrid indices now. So yeah, that's a little bit, and I think I'm right at time. So have a nice day. Thank you.
Our final speaker this morning will teach us how to distill accurate, actionable insights from vast, multimodal data sources. He's the founder and CEO of Brightwave. Please join me in welcoming to the stage Mike Conover.
Hey everybody, I'm Mike Conover. I am founder and CEO of Brightwave. We build a research agent that digests very large corpuses of content in the financial domain. So you can think of due diligence in a competitive deal process. You are pre-term sheet, you step into a data room with thousands of pages of content. You need to get to conviction quickly ahead of other teams. You need to spot critical risk factors that would diminish asset performance. It's a fairly non-trivial task. You think about mutual fund analysts. It's earnings season. You've got a universe of coverage of 80, 120 names. There are calls, transcripts, filings. It's a fairly non-trivial problem to understand at a sector level, but also at the individual ticker level, what's happening in the market. Or goodness, you get into confirmatory diligence and you've got 800 vendor contracts, and you need to spot early termination clauses. You need to understand thematically, how is my entire portfolio negotiating their vendor contracts? It's frankly not a human level intelligence task. And the reality, as we've stepped into this space, is that these professionals just get put in a meat grinder. Junior analysts are tasked to do the impossible on extremely tight deadlines. I come from a technical background. Prior to Brightwave, I was at Databricks and created a language model called DALL-E that was one of the earlier models to demonstrate the power of instruction tuning for eliciting instruction following behavior from open source technologies. And as I have met with these professionals, I have developed a deep sense of empathy for the stakes and the human cost of doing this work manually. When it comes to the role of the individual in finance workflows and financial research, we think of the parallels to early spreadsheets. You go to an accountant or finance professional in 1978 before the advent of computational spreadsheets. You say, what's your job? Well, I run the numbers. It's cognitively demanding. These people write this stuff out by hand on literally wide pieces of paper called spreadsheets. It's cognitively demanding, it's important to the business, and it's time intensive. It feels like real work. And now, nobody wants that job. And it's not because there aren't finance professionals. It's not because nobody's doing analysis. It's the sophistication of the thought that you can bring to bear on the problem has increased so substantially because there are tools that allow us to think more effectively, more efficiently. What we're seeing, what we're hearing from our customers is that a system like Brightwave that is able to digest, and not just Brightwave, this class of knowledge agents is able to digest volumes of content and perform meaningful work that accelerates by orders of magnitude the efficiency and also time to value in these markets. And so the purpose of this talk is to relate sort of the intelligence that we've developed in the course of building this high-fidelity research agent, and just things that we're seeing both technically, but also in terms of product affordances. I mean, the design problem that you have to solve is how do you reveal the thought process of something that's considered 10,000 pages of content to a human in a way that's useful and legible? That is not a UI UX problem. It's not a product architecture problem that existed 3 years ago. And the final form factor has not been determined. Chat, everybody's very target fixated on chat. That's probably not enough. So the first thing that I'll observe is that non-reasoning models are performing greedy local search. So the Bloomberg talk highlighted that sort of fidelity issue, like a really concrete example. You put a Reuters article in 4.0 and you ask it to extract all the organizations, goodness if it's not gonna give you products. And if you have a 5% error rate and you chain calls like that, you're gonna introduce sort of in an exponential way the likelihood of error being in these models. And so the winning systems will perform end-to-end RL over tool use calls, where the results of the API call are in fact part of the RL'd sequence of decisions so that you can make locally suboptimal decisions in order to get globally optimal outputs. The reality is that that's still an open research problem. You know, how do I avail myself of a knowledge graph, or I did not do that. How do you avail yourself of these tools in an intelligent way so that you get globally optimal outputs? It does seem like that is not a solved question. So the reality, and I think it's like heartening to see this is a theme, and I think everybody in this room can be sort of comforted by this. You got to build a product today, and like there's gonna be this talk of the bitter lesson that more data, more compute, better models dominate all other approaches. Like nobody wants an expert system. Nobody wants to use Spacey to do named entity recognition. Sorry, that was not in the speaker notes. You can think of being more circumspect about what is the scope of behaviors that the system, the agent, is going to engage in, sort of like a regularization parameter, which constrains the complexity of the model. And that limits the likelihood, reduces the likelihood that it will go truly off the rails and begin to produce degenerate output. You can think of it sort of like the most interesting interactions I've had with language models are deep into a conversational tree, where you can think of selecting at each branch, each response. There are a set of reactions that I can have to the model output, and I'm steering, I'm choosing. This is what knowing how to use language models, it's a skill. And many people who have real full-time jobs may not invest in developing that skill. This is not dissimilar to what these RL systems are doing. And if you can think of a multi-turn conversation as not just establishing a human orchestrated chain of thought, but really that set of tokens defines the activations of the model. And if you think of the activations of the model as defining a program, what you are doing when you respond to the model and say, no, not quite like that, more like this, is if you think of the activation weights or the activations as a point in a vector space, you are nudging the activations to a place where they can finally solve the problem at hand. And I think that's what the chain of thought process, or the sort of reasoning monologue, is performing. It's getting the activations to a position where it can actually solve the problem. So it's actually not, it's cute that you can interpret it, but I would prefer if it just got to the right set of activations automatically. And so from a product affordance standpoint, people are not going to want to really become prompting experts in a deep way. And frankly, it takes easily 1,000 hours. And so the scaffolding that products put in place in order to orchestrate these workflows and shape the behavior of these systems, I think these verticalized product workflows are probably going to be enduring because they specify intent. They take that weight off the user. So some of the things that we see with respect to archetypal design patterns in the space, consider a basic autonomous agent. You really want to mimic the human decision-making process and decompose what is it that a person would do. Well, if I need to understand how this polypropylene resin manufacturer is managing costs, I might look for public market comparables, and that would maybe entail going to the SEC filings or earnings call transcripts, and I would assess content potentially from a knowledge graph constructed from previous deals that I, as a private equity investor, have done. News corpuses, assess which document sets are relevant to me, distill down from those documents findings that substantiate premises or hypotheses that I might have about this question or this investment thesis, and then enrich and error correct those findings. And so a couple points on this. One is that it is actually, so I forget who it was, but they were talking about, it was the deep research team talking about on that next step, what are my intermediary notes? What is it that I believed on the basis of what I found? That's actually an extremely useful think out loud about what do we believe given the facts as they have materialized on that first pass through the data set. Enriching individual findings that are distilled down from documents is an extremely powerful design pattern. Likewise, you can ask these models, is this accurate? For that Reuters example, you can say, is this factually entailed by this document, or is this actually an organization? And the model can frequently self-correct. And what we've noticed is that you can do that in the JSON as sort of like a chain of thought behavior, but it's actually more powerful to do it as a secondary call because the model's kind of primed to be credulous. It says, well, I told you it was, and so yeah, I'm probably right. So it's interesting how you can tease apart some of these steps into multiple different calls, and then through this process of synthesis, you're able to weave together fact patterns across many, many, many documents into a coherent narrative. And that control loop, we think that obviously human oversight is extremely important. The ability to nudge the model with directives or sort of selecting, this is an interesting thread, I want you to pull that, is extremely important. And that's because the human analyst always is going to have access to information that has not been digitized. That's that conversation with management. That's your portfolio manager thinks this class of biotech is just harebrained. That taste making, I think, is going to be where you see the most powerful products lean. I firmly believe, with respect to the nodes in that knowledge graph, and many people in this room probably have reached this conclusion as well, but you still see this, we got a portfolio manager agent, and this is the fact checker, and that sort of needless, anthropomorphizing of these systems, it constrains your flexibility if the design needs of your compute graph change. And this is 1970, I think it was 1978, and Bell, the Unix philosophy, it's like, you think about piping and teeing on the bash command line, or I guess I date myself, I still use bash, not C shell. Just simple tools that do one thing and that work together well. And text is the universal interface. It's 40 years ago, 50 years ago, geez. So our friends at Latent Space put together this plot. With respect to the structure of these graphs, obviously that Pareto frontier, which is the sort of efficiency frontier, it's 2, batting 1,000 a day. The efficiency frontier for compute and performance trade-off, or price performance trade-off, that frontier is going to continue to move out, but I believe there will, for at least an enduring time, be a frontier. And what's notable about that is that you have to select then which tool, which system, which model am I going to use for each node in the compute graph. And the reason that this is important is what I call the latency trap. If you think about the plot of time to value and realized value for agentic systems, and I think this is extremely important, it's very easy to think, oh man, it's going to do all of these things. It's going to, I'm going to check it and error correct, and then, in 25 minutes, it's going to be banger. And I think even with high quality products like OpenAI's deep research, you're not always sure that what you're going to get out is high quality. So there's kind of like a question of which side of the diagonal, it's probably not a straight line, but is that product on? But also from a reps standpoint, the impulse response for the user, how well refined is, you can think of my expectation for what the report is going to look like and what the report actually looks like is the loss. And the user's mental model is developing a sense for how do my prompts elicit behaviors from these models. If it's an 8-minute feedback loop, it's a 20-minute feedback loop, goodness, you're not going to do many of those in the course of a day. And your faculty with the system and the product is going to be low. So synthesis is really where a lot of the magic happens in these systems. And a couple observations. So notice that I don't know, has anybody in this room ever had a 50,000 token response from any model? No? They say that it's, O1 is 100,000 output context length. I'm not so sure, and it's because the instruction tuning demonstrations, these synthetic or human-generated outputs that are used to post-train the models have a characteristic output length. It's hard to write 50,000 coherent novel words. And so the likelihood that the models are able to produce, even O1 still is about 2,000, 3,000 tokens. It's better than 4.0. And so what happens, it's kind of like there's a compression problem. If I have a very, very large context window for input, I'm compressing that information into a set of tokens. And so it's like the difference between writing a book report and a synopsis of each chapter. You can be more focused and specific about what is it that I want those N,000 tokens to be focused on. Here we have, I said, write an analysis of the global financial crisis. Goodness if I don't think the rise of the shadow banking system warrants more than 3 sentences. And so if you can be more granular and more specific, you can get higher quality, higher fidelity, more information-dense outputs out of these systems by decomposing your research instructions into multiple sub-themes. Additionally, the last point I'll make on this problem is that of the presence of recombinative reasoning demonstrations in the instruction tuning and post-training corpuses is low. So it is easy to say, given the text of The Great Gatsby, this is the epilogue, and write a new epilogue for The Great Gatsby, because the cost of internalizing that corpus is fixed, effectively. You read the book, and then you write 5 epilogues, and it's like, goodness, I got it. Synthesis really is about weaving together disparate fact patterns from multiple documents. Think about the applications to biomedical literature synthesis. I need to read all of these papers and then have something useful to say that actually brings together the facts from these documents. Now, there's like a cute trick you could try, which is to say, given the bibliography of any given paper, write the abstract as a post-training exercise. But it's just really hard to get high-quality, intelligent, thoughtful analysis of many, many, many different documents. And so there are limitations in practice for even state-of-the-art models in terms of how they are able to manage complex real-world situations. Factors like temporality, the perplexity at so temporality is hard. And being able to understand, something like a merger and an acquisition, these pro forma financial statements are different from those that came before the event. If they're addendums to contracts, it's important to propagate with evidentiary passages a metadata that contextualizes, why do I care about this? What do we think about this document? How should I consider this in relation to the other pieces of evidence in the context window? So I'll now shift a little bit with some examples from the product that we've built, which is how do you reveal the thought process of something that's considered 10,000 pages of text? And I think that it is more like a surface, and one where you're able to, it's kind of like this. Like, people you may know, the Facebook and LinkedIn recommendation algorithm for connections feels uncanny good, in part, not because, the algorithms are okay, not great, have gotten a lot better over time, but in your visual cortex, there is a bundle of nerves that are exclusively dedicated to face recognition. And the ability to say, in a 6x6 grid of faces, goodness, I know that person. And so you attend to the things that matter, even if it's actually a low precision product experience. And so the ability to give the person details on demand is extremely important. We'll see. So here we have a Brightwave report. I think the ability to click on a citation, and then get additional context about this, not just what document is it from, but how should I be thinking about this? What was the model thinking in the course of this? As well as structured interactive outputs that give you the ability to pull the thread and say, well, tell me more about that rising CapEx spend. In Brightwave, you can highlight any passage of text. So it's not just the citations, but you can highlight any passage of text and say, tell me more. What are the implications of this? I think OpenAI gestures towards this with respect to Canvas and the ability to increase the reading level of a passage. Having a continuous surface that's not just these citations, but in fact, any finding should be interrogable. Likewise, you can think of, I'm actually going to pause. It's not going to pause. I'm going to go back and do this again. You can think of the set of things that the model has discovered. It reads all of these documents. It develops a view. It weaves the facts together. As a high-dimensional data structure, and the report is one view on that data structure. It's kind of a low-effort point of entry into the space of ideas. You want to be able to turn over that cube and see, especially in finance, the receipts. What's the audit trail for this system that's read all of these materials? And so being able to, in this example, click into the documents is one level, but having all of the findings laid out for you, whether it's a fundraising timeline, ongoing litigation, I'm able to, if something catches my attention, click on it. And this is where that investor, hello? Investor or analyst taste comes into play. I'm able to say, tell me more about that. It's like a magnifying glass for text. Something catches my eye, this patent litigation. Goodness, that seems important. You had a factory fire in Mexico that wiped out a critical single source supplier. What are you going to do about that? That ability to drill in and get additional details on demand is extremely important in these systems. And I think, candidly, we do not yet have the final version, the final form factor of this class of products. But it's an extremely interesting design problem. And I will say, we are hiring. So these QR codes, not only is it a great place to work, we've got people from Goldman Sachs and UBS and Meta and Instagram and Anaplan, and we just hired a senior staff software engineer from Brave. Goodness, we got a stacked team. We also have a $10,000 referral bonus. So I'm going to see a lot more phones come out now. $10,000 referral bonus for all of these roles, primarily the product designer and the front-end engineer. We're hiring staff and senior staff level professionals. We have a small team of extremely experienced individuals. And this is structured like the DARPA Red Balloon Challenge, if you're familiar. So if you refer the person that refers the person that we hire, you get $1,000. And so on and so on and so on, all along that exponentially exploding referral tree. So we're Brightwave. We build knowledge agents for finance workflows. I appreciate your time today.
Ladies and gentlemen, please welcome back to the stage MC for the AI Engineer Summit, Agent Engineering Day, the founder of Turing Post, Ksenia Sa.
So wonderful to see you and see your faces. But I bring good news. I'm bringing good news. It's lunchtime. Thanks to Mike, who already left, for this amazing deep dive. If you have any questions to any of the speakers, please find them in the Q&A areas. One is right here on this floor, other two on the lower level. And I just wanted to say that this session was amazing. What a morning. I feel buzzing with insights, and I hope you got a lot of interesting things for you to think about. Each talk was an absolute gem. We got the sneak peek into Aladdin Copilot's enterprise multi-agent platform. We learned Jane Street's tooling for OCaml. Bloomberg's challenges in scaling generative AI agents, and we learned about Brightwave's knowledge agents. All these companies are hiring, so go talk to them if you're interested. That's it. Enjoy your lunch, and we'll see you back here at 2 p.m. Thank you so much.
Ladies and gentlemen, lunch is now being served. In the MC for the AI Engineer Summit, Agent Engineering Day, the founder of Turing Post, Ksenia Sa.
Welcome back. I hope you enjoyed lunch and some sessions from our sponsors downstairs. It never stops, right? AI just never stops. It constantly something, something, something. And how are you feeling? Are you ready for some more awesomeness? Awesome. So this sprint is sprint of sessions is packed with action and some valuable insights into AI engineering. Let's see what's on our list. It's agents are built in the fringe, getting from 90 to 100. How to scale 500 million AI agents in production with 2 engineers. Voice AI, your bot isn't special, and how to scaffold wisely. With that, please join me in welcoming our next speaker, Head of Product Engineering in Windsurf, Kevin Howe.
That's crazy. All right, how we doing, New York? So my name is Kevin. This is our first ever Windsurf presentation, so you could say it's the first time we're kind of spilling the beans on what the IDE is all about. So thank you all for coming. I'm going to be talking about Windsurf, the first AI agent-powered editor. So my name is Kevin Howe. I lead our product engineering team. We're a team based out of San Francisco. And thank you so much to Swyx and Ben and the whole AI Engineering Summit team for inviting us here and letting us speak to you all. It's been a pleasure talking to people in the audience, at the booth, and just generally talking about AI. So let's dive into it. Windsurf is an agentic editor, and we're going to talk a little bit about some of the principles that we use when we're building a product like this. So we believe that agents are the future of software development, and you all are here, so you kind of understand the power of what agents can do, both for software engineering and otherwise. But to start, I'm going to take you down a trip down memory lane. Right? Let's go back to 2022. Copilot was the state of the art. It just came out of beta. People were experiencing the ghost text. They were seeing their completions. And it was one of the first times that people really got to see the magic of what AI could do for developers. It was making them more productive. And we, Codium, decided we were going to be one of the first companies to also launch an autocomplete product. So we garnered a couple million users on our VS Code, JetBrains, Vim, Emacs extensions. Raise your hand if you were one of those Codium users. Nice, nice. But we always knew that intelligence was going to get better. Right? Back then, we were doing short completions, maybe finishing your functions. But we knew that there were going to be better models, larger models, better training paradigms, completely new RL, new tool use, all this stuff. And so we knew that we wanted to build the best experience for devs possible. So even back then, we started looking at agents. We started thinking about what could the future of software development be if models just got bigger. And so we built the best experience that we could at the time. And that was a chat autocomplete product. But we always knew that copy-pasting from ChatGPT was going to be a thing of the past. We also knew that people were going to probably tab less. We were going to have LLMs that we'd be able to generate more and more. And who knows? We always think, all right, agents are the best now. But as a company, we're always thinking about the future. We're technology optimists. So if an IDE in the future, who knows? We might not even be writing code inside of IDEs. We'll just be there building the best product for SWEs. And so this year, 2025, is finally the year where I feel like we are all recognizing the power of agents inside of software development. Agents are here to stay, and Windsurf, I'm proud to say, is pushing the envelope of that technology. And we're going to talk about some of those features, and we're going to keep pushing that agentic future because we believe that agents are going to move software engineering in a direction that no other LLM has done in the past. So this slide, I guess, is titled Vibe Coding with Windsurf, or also just coding in Windsurf. So I'm going to give you a quick demo about, this is the Windsurf product. Here, you have a sidebar. This is our agent. And you can see that we're going to be building a Python web scraper. So what this is going to do, it's going to build a Python web crawler, give us some stats about the website. And you can see it's actually installing dependencies from pip. It's doing so inside of the terminal that you use, so you can interact with it. It's suggesting edits, setting up your virtual environment. And we give a user a very helpful accept and reject so that you can go through and have confidence that the code that it's generating works for you and your code base. This is, of course, there's a lot more features under the hood. Some of the things that our users like to do, they like to look up documentation. We have web search enabled by default. It always looks at your code base, so you can grep through your code base. We can generate commit messages. You can drag and drop images, right? The possibilities are truly endless. And I'm going to be talking about these features are powered by a handful of principles, a handful of through lines that we as an engineering team hold true as we're building. And as a team, we always go back to the same mission, which is to keep you in the flow and unlock your limitless potential. Right? We want to handle the grunt work for you. We want to handle looking at your debug stack traces. We want to handle modifying your original source code. We want to pull the correct version of documentation so that you never have to worry about pulling in the correct context. These are problems that we are trying to solve. And we want you to spend time on things that you are good at, right? The things that make us all excited, which is shipping products, building great features, and generally just shipping code. And so with that goal in mind, how do we tell what to work on? It's a game of input and output. So we want to allow users to give the least amount of explicit input possible to produce the most correct and production-ready code, right? We want you to contribute less, and we want our agent to contribute more. And we do this by reducing the amount of human in the loop required by doing things like background research. We are always trying to predict your next step, and we'll make decisions on your behalf so that you can move faster. And this might all seem like a fantasy, but Windsurf launched 3 months ago on November 13th. That date is forever branded in my memory. And these are the results that we're already seeing. So in 3 months, we've been generating 4.5 billion lines of code. That is an absurd number. And since the time I started this presentation, we've actually users have probably sent thousands of messages to Cascade, asking it to refactor code, to write new features, to build new pages on their website. And also, a fun statistic, since we're all engineers here, we've had 16 nights in the last 90 days where we've been woken up in the middle of the night from PagerDuty on call because we've had some reliability issues due to us exceeding our capacity, right? These problems, we've had immense success getting people onto the platform, and we've been very fortunate to have the issue of being some of Anthropic and OpenAI's largest consumers. And so with this mission and metric in mind, let's walk through some of the principles that we use when we're building this agentic editor. And for those of you that have used Windsurf, you might learn about some of the new ways that you could use the product. And also for my own curiosity, how many of you have heard of Windsurf, just so I know who we're talking about? Oh, let's go. That's sick. How many of you use Windsurf? OK, everyone who put their hand down, doors over there. All right, let's get into it. So the first principle, trajectories. What is a trajectory? We use trajectories to read your mind. So unlike other editors like Cursor, the elephant in the room, our agent is deeply integrated into the editor. And we'll talk about what exactly that means. But on one half, you can imagine an agent has to understand what you're doing. And then on the other half, it either has to understand and be able to execute things on your behalf. And this has led to features like, one of my favorites, quote, continue my work. So we are building up an understanding of the user as you're writing code, as you're executing terminal commands. And then you can actually just go into the agent sidebar and just say, continue my work. And it'll actually continue executing that, and it might even give you a full PR or a full commit, right? We also have things like terminal execution mode, right? It can automatically use the LLM to decide what is safe and not safe, so that if you're running something like Git, it'll just work. Or it'll probably prompt you if there's an RMRF somewhere. You probably don't want to run that automatically, and the LLM will be like, oh, we should probably flag to the user to confirm this. These are just some of the ways that we try and let the human be in the loop, but as minimal as possible. And then finally, we also have a stellar UX, a stellar design team that's been working on how to integrate these sort of cutting-edge features into a product in a way that allows the user to feel like they're in control, to be able to accept and reject changes into their code so they can have confidence in the code that they're pushing to production. So here's how a trajectory works. We have this notion of a unified timeline. So an agent is working in the background, behind the scenes, to understand what the user is implicitly doing. So this includes things like viewing files, navigating around your code base. Let's say you edit a file, and then the agent will edit a file. This all kind of goes into a shared timeline of actions. And you can imagine this includes things like searching, grepping, making edits, making commits, right? The user has this sort of holistic understanding of what you're doing. And this entire experience is unified by this shared timeline. So you can contribute to it, it can contribute to it, and in this way, you never run into the problem where you're talking to the agent and it undoes the change that you just did or has some outdated notion of what the file state is. So this is a first-class principle of ours, and when we decided we were going to build an editor, we were going to build it around this notion of an agent in a shared timeline. And so here's an example of this feature in action. Here we're adding a new function, and you're seeing the autocomplete and all the kind of like bells and whistles of that feature. And in the right side, we just ask, continue my work. This is a new function. We probably want our form handler to use this new function. And you can see, based on the context that we gave it by making edits, it's guessing. OK, we probably want to make this file change to this file, maybe some others. And then at the end, it's actually just saying, OK, let's just run npm run dev. And it can run terminal commands on your behalf in the background in your kind of like command J terminal pop-up. And in this way, we're keeping you in the flow, right? Something that would have taken minutes is now taking seconds. And here's another example. The terminal is now deeply integrated into the agentic timeline. So here, if you're typing commands, the classic example is like I npm install a new package, or I pip install a new package. The agent should know, oh, you just installed this package. Why don't we go ahead and implement it into your project? And based on context that it's able to pick up around the code base, it can continue that line of work. So we very strongly believe in a future of no copy-paste. right? You should never have a situation where you're in a terminal or you're in a document or even on a website and you're copy-pasting text into an agent. That's just not how the way the world works. And in the same way, we strongly believe the future is not going to be at terminal. Here's another example of commands running inside of your terminal. I've been talking about this for a little bit. And this concept of a trajectory allows us to automatically execute things inside of a sandbox that is as similar to the way you run commands as possible. So instead of running some shell script in the background, what we do is we put this right inside of the place that you would actually write terminal commands. So if you pip install something, or it pip install something, it's going to the same environment. You'll never have this instance of kind of weirdness. And this is all part of our effort to bring these two sides, the agentic side and the human side, close together as possible. And you do this through building a unified product. We believe that developers are here to stay. And if you want to work seamlessly with a developer, that means the agent has to understand what they are thinking. Windsurf has to be ubiquitous. And the agent will be reading more and more of your mind, doing things that you might not even know it's doing. In the future, we'll be looking not just 1 to 5 steps in the future, but 10, 20, 30 steps into the future. It'll be writing unit tests before you've even finished defining the function. It'll be performing code-base-wide refactors on multiple files based on you just simply editing a variable name. All this is part of this unified trajectory concept. Now, the second principle is meta-learning. So even if Windsurf understands what you're doing in the moment, there is still an inferred understanding of your code base and your preferences and your organizational guidelines that, let's just say, senior engineers at your company have built up a notion of over time. We call this concept meta-learning. So Windsurf, we've built from the ground up to adapt and remember these things about you and your company. So if you think about a frontier LLM, right, the best LLMs that they exist in the world, they're very, very smart engineers, definitely more capable than I, probably more capable than most of you. They can just write an enormous amount of code and do so correctly, and it probably runs and compiles pretty well. But what they do not have is the exposure that you've had, the education that you've had, and the ability to kind of remember and know how you personally or your company writes code. And so what does this mean for our product? We've implemented a concept called auto-generated memories. So over time, we build up a memory bank of what you are doing. So you can say, remember that I use Tailwind version 4, or remember that I use React 19 instead of 18. And these things will be remembered. You say them once, and they'll be remembered forever. We also allow people to implement things like custom MCP servers. So you can plug in your favorite tools. We can adapt to your workflow. We will also allow you to whitelist and blacklist commands. Going back to that same concept, we want to keep you in the flow as much as possible. But we can tell the agent, hey, never run an RM command without my approval. And so in this way, it learns about your preferences over time. And if you think about what makes a developer effective, it's because they remember things that you tell them. And Windsurf must also model this behavior if we hope that AI should write and maintain projects for us. So in the short term, this means you don't need to prompt the agent again and again to do the same thing over and over. But in the long term, the AI should just feel like a seamless extension of yourself. It's this idea of explicit versus inferred context. And we always have this saying at the company, ideas are cheap. So here's an example of auto-generated memories in action. Here, we're not even explicitly telling it, hey, remember this thing. We're just giving it an architecture overview. We're asking, what does this project do? And it's remembering based on a couple tool uses. It's looking at a couple different files, looking at the routes. And now it's committed to memory. Hey, this is the project that this person is working on. Here are the endpoints that are available. And we can reference that in the next message that we send, right? So in the future conversation, we can now one-shot things because we have a notion of a memory bank. In the same way, documentation is auto-learned. We know what packages you're using because of your package JSON, because you've explicitly told us, and we're able to look on the web for documentation that matches those versions, and we do so all implicitly. And so the dream of meta-learning is that you can have an entirely inferred sense of context based on a code base or based on the usage of the product. And auto-generated memories are a step in that direction. We strongly believe that having a rules file, we do allow users to add a rules file. We strongly believe that a rules file is a crutch. By the end of 2025, 99% of the things that you're going to put in a rules file will be interpreted or inferred based on your code base or your usage. So our dream is that every single Windsurf instance, every single user using Windsurf, regardless of the company or the type of person, the skill of the developer, will be personalized to that user, and you only have to tell it one thing. And finally, my favorite principle, which is scale with intelligence. So what does this mean? Now that Windsurf understands what you're doing in the moment, right, the first principle, and can improve over time, the second principle, how do we actually build an agent that will scale with the rates at which LLMs are scaling? And while we're trying to always give you the best tool today, we recognize that new models are coming out every other week, right? Every day there's some new article about some new pattern, and it's really, really hard to keep up. But we always think at Codium, how do we stay on top of this? How do we build the best product for not just today, but 3 months, 6 months, 12 months out, 3 years from now? So in 2021, when ChatGPT came out, you probably like me, we all had our imaginations running wild. We were like, okay, we're going to solve AGI, post-economy, whatever. But obviously, there's a lot of things that need to happen between then and that future. And so models at that time were, quite frankly, a little bit too dumb to be able to accomplish everything that we wanted them to do. So we built up a lot of infrastructure, and you and I have all probably done this. We build out embedding indices. We build retrieval heuristics. We have output validating systems to make sure that the code that it's generating is good. Right? These are all things that we're able to help at the margin. But this is all predicated on the assumption that we were operating with a fixed notion of intelligence. 2021, 2022, these models, we were building all this infrastructure to compensate for areas and edge cases that models could not handle. And what's very different about the way we're approaching Windsurf is that we want our product to scale with the models. So if the models get better, our product gets better. And I'll give you one such example. It kind of surprised me. I was, when I landed in New York, I tweeted that we deleted chat in Cascade. I was like a very, I don't know, I had thoughts. And weirdly, a lot of you picked this up. And this is an example of something that we feel very strongly about. One example of this principle in practice is that we deleted chat. So what does this mean? We only have an agent, and it's called Cascade inside of Windsurf. Chat is a legacy paradigm. And we completely replaced it, and as you can see here, users are enjoying it. Or in fact, they might not even know the difference, but they're just enjoying the higher quality. An example of this is app mentions. We built app mentions, and probably you all have used app mentions because context was not very good a year or 2 years ago. Today, Windsurf can dynamically infer the relationships between bits of code and documents. 90% of the time, you do not need to app mention something. All you need to do is let the retrieval system in the agent kind of plan out what it needs to do, and then reconstruct the context automatically for you. So at file and at web, these are very helpful patterns when you're working at kind of the margin, but these are eventually eking out basis points. In the long term, we believe that LLMs are going to improve, and they already have improved to the point where you don't need to explicitly specify an app mention. The LLM should be intelligent enough to pick it up. And so in this example, previously, I was implementing Supabase inside of a Next.js app. Previously, you'd be at webbing, you'd be at docs, at codebase, at this, at that. No, just add Supabase, right? And it's able to infer and plan out, let's search the web. Let's behave like a human would. And to get into this, there's also web search built into Windsurf. And what's very special about this is that it reads the web the way a human would read the web. So instead of these hard-coded rules, and we probably could have created an embedding index, but we would probably get very low-quality results. And so instead, we said, the LLMs are very, very good. Let's let the model decide what it wants to do. Let's have it decide which search results to read, what parts of the page to read, and then finally, give us an answer. And so we believe that as models will continue to get better, we're going to be continuing to do unsupervised work. We're going to generate full PRs. We're going to read complex documentation. The possibilities are truly endless. And so here are some of the principles that we just talked about. Where are we going with this? There's a lot of ways we can take this, right? The engine underneath Windsurf is really, really the secret sauce. And we believe that 2025 is going to be a whole new world. No rules files, generating PRs, generating commits. It's going to be crazy. And we're already seeing this. 90% of our users, or sorry, all of our users, 90% of the code that they're writing is generated with Cascade. That's an astonishing number. Autocomplete was more in like the 20, 30%. This is insane, right? People are using agents today to accomplish so much more than they could have in the past. And we're all software engineers. I want to make sure that every single person in this room is armed with the best tools. And those best tools are agents. And like every good thing in the city, I expect tips. 25% of your ticket price, which I heard was quite a lot. Here's the actual QR that you're probably curious about. This is Windsurf's download link. We offer a free tier. So go ahead and scan that. Start using the magic today. And then finally, We have some killer swag at our booth. You can also connect with me on Twitter. I try and stay active with the community. But thank you so much for watching. I hope that you all learned something about how we're building at Windsurf, and enjoy the rest of the conference. Thank you.
Our next presenters will tell us how they scaled 500 million AI agents in production with just 2 engineers. Please join me in welcoming Senior Software Engineer at Method Financial, Mustafa Ali, and the founder and CEO of OpenPipe, Kyle Corbett.
All right. Hey, everybody. I'm Kyle Corbett from OpenPipe, and I'm here with Mustafa Ali from Method. We're going to be talking about how Method has scaled in production to over 500 million agents, and basically all the tricks they use to make that actually work.
Yeah, so a little bit about Method is that we essentially collect and centralize liability data from across hundreds of different data sources. This includes tapping into the credit bureaus, connecting with the card networks like Visa and MasterCard, and just direct connections with the financial institutions and various other third-party sources. And we sort of aggregate and enhance this data and serve it to our customers who are typically other fintechs, banks, or lenders. And they use this enhanced data to anything really to do with debt management, so refinancing, loan consolidation, liability payments, or just personal finance management.
Yeah, and at OpenPipe, what we do is we help you build, train, and deploy open source models for actual usage. We also let you use in production your signals you get from users, from the environment, to improve your model continuously over time. And that's some of the things we'll be talking about, what we did with Method.
Nice. So one of the early challenges that we faced at Method while coming up with this aggregation pipeline was that some of our customers basically came to us and said, it's really nice that you can give us the balance and payment information on a specific liability for their end consumers. But what would be really nice is if you could also give us some of these liability-specific data points, like the payoff amount on an auto loan or the escrow balance for a mortgage. And we said, OK, let's do some research. So we go back to some of our data partners and basically ask them, is there anything we can plug into to get these kinds of data points? And what we found was there's really no central API that we could get access to that would allow us to get some of these data points. And of course, ideally, we would want to work with directly with the banks. But having already worked with banks before, and just from initial conversations, we realized that it would easily take up to at least a couple of years before getting anything solid done. And we're an early stage company, so we want to build for the customer fast. And so that's really what we're trying to come up with, a solution that we can just push into production tomorrow. And so just to get a better understanding of how some of these companies are operating today, the services that they're providing today, how are they doing that in the first place, right? They must be getting that data somehow. So we go back to some of these customers and basically ask them, how are you guys operating? And what they tell us is kind of interesting. So a lot of these companies, they basically hire offshore teams of contractors. And these teams are basically responsible for calling these banks on behalf of the company and the end consumer. They authenticate with the banks, gather the necessary information. Somebody has to proof check it. It gets sent back, and then it gets integrated into the financial platforms. And it gets surfaced to the user, is used for underwriting, stuff like that. And so that's the status quo that we're dealing with here. And when you think about it, that's a very inefficient manual process, right? It's when you try to think about scaling, it doesn't really scale. It's it has a lot of problems. It's expensive because one person can only do one thing at a time, right? So if you want to scale, you basically have to hire more people. And for the same reason, because it's so synchronous, it's also really slow. And the biggest problem with that is also that there's a lot of human error involved. And you need to hire a team to fact check it, to proof check it. And it's the worst thing that you can end up with is to surface basically inaccurate financial information. And so conceptually, though, if you think about it, it's kind of like an API, right? You have the request component, you have the authentication component, you have the response, validation, all that stuff. So essentially, when you drill this problem down into the core problem, that's really just trying to make sense of unstructured data, right? So if only there was this magic tool or software that we could use that was really good at parsing unstructured data. And lucky for us, around the time that we were trying to solve this problem, OpenAI announced GPT-4. And as people like to call it, there was this Cambrian explosion of AI or LLM-enabled applications all around us, and the results were just mind-blowing. And we thought to ourselves, this is the perfect thing for us. This is like a godsend. So we tried to we tried to see if there's anything there that we could use. And if there's one thing that we all know in this room is that advanced LLMs, especially post-GPT-4, are really good with parsing unstructured data. So tasks like summarization or classification, they're really good with that kind of thing. So we wanted to test that theory out and see what that can get us. And so we put our heads down, hacked together this agentic workflow using GPT-4. And as expected, it worked really well. So we tried to expand some of our use cases because the API costs are high. So we wanted to get as much as we could from a single API call. And it turned out to be really good at that. So we tried to, obviously this was in a very controlled manner, but this was in production. And so we were testing out different extractions basically, and everything was going really good. But as soon as we started to increase a little bit of traffic, what we found was, the bill had to come due. And it was a lot. So $70,000 for our first month in production with GPT-4. And this made leadership really unhappy, and but it was something they were fine with because the value that we were getting out of GPT-4 was so immense. And so we actually kept this thing in production for at least a couple more months as we tried to work around this kind of cost problem. And cost wasn't the only thing that we were concerned with. As we started to scale some of these use cases, we quickly ran into a wall with prompt engineering. It only takes you so far. One thing we realized that even though GPT is really smart, it's not a financial expert. So you had to give it really detailed instructions and examples to really make it work with all kinds of use cases that we were trying to target. So it's hard to generalize those kinds of prompts. They become really long, convoluted. It's always a cat and mouse chase with you fix it for a certain scenario and it breaks for another one. You fix it for that one, it breaks for the previous one. And so you're always going back and forth. We didn't have any prompt versioning, so we had to figure out a better way to make this work for all of our use cases. And so the TLDR here is that we didn't want to adopt that initial solution that I just talked about earlier in the slides because of its scaling challenges and just because it was so inefficient. But we kind of ran into the same scaling challenges with GPT, where it was expensive because we couldn't really optimize for caching because of the variability in responses and the prompt tweaks we were making all the time. And the baseline latency that we were finding was actually really slow. So we couldn't, overall, we couldn't scale concurrently. And similar to human errors that were kind of in a different nature, we had AI errors, which were just hallucinations that were hard to catch. And we just couldn't scale with this kind of system. But we still kept it in production because for specific use cases, it was actually really, really good. And so now the problem shifted from solving that core problem of trying to make sense of unstructured data. That was solved with GPT. Now the problem shifted to how do we scale this system? How do we build a robust agentic workflow that can handle this kind of volume reliably? And so some of the ballpark figures that we came up with is that we're going to be at least making 16 million requests per day. We're going to have at least 100K concurrent load. And we need minimal latency to handle this kind of real-time agentic workflow, so sub 200 milliseconds. And so the natural next step for us was we thought to ourselves, do we buy more GPUs? Do we host our own model? What do we do at this point? So at that point, OpenPipe comes in.
Yeah, so about a year ago, we started working with Method on solving these issues that Mustafa just listed. And we actually found that those three issues he listed, right, which are quality, cost, and latency, are very common. These are things that across almost everyone we work with, at least some subset of those are really top of mind. And so with Method specifically, we were working on, okay, how do we solve those problems in a way that makes this a viable business for you? So the first thing we did was start measuring error rates. Like he mentioned, even AI models are not perfect. These are all probabilistic systems. Getting to a 0% error rate was not really feasible, but we were able to see different models had different performance characteristics there. So on modern models, on the tasks they're doing, these are the rates we're seeing. On GPT-4o, we're at about an 11% error rate. And with O3 Mini, it's much better. It's around a 4% error rate. The way you measure that is going to be specific to your business, and that's actually true to some extent for all three of these things we'll talk about. In the case of Method, this is actually relatively easy to measure, luckily, because they have this agentic workflow, but like ultimately what the agent is trying to do is fill out, extract all this information he was talking about, bank balances, things like that. And so you can have a human go through the flow and figure out what the real number should be, and then you can compare an agentic system's final outputs to that and see if it was successful or not, which made this part relatively easy to calculate. So these are kind of the error rates we're getting. On the latency point of view, we see that GPT-4o is around a second to respond, and then O3 Mini takes about 5 seconds for their specific task. Again, this is somewhat task dependent, depending on how much, for example, O3 has to think. As you're measuring this, you also want to make sure that you're using real production conditions, that you're actually doing, like a real diversity of tasks that match what you're actually doing, and at a reasonable concurrency level that matches your production. And we also measured the cost. So again, cost, this is something that is going to obviously be specific, and how much it matters is also very specific to your use case as well. Interestingly, O3 Mini, even though it has a much lower per token cost than GPT-4o, if you just look at like the pricing page on the API, for their specific use case, we found it was a little bit more expensive because it generates many more reasoning tokens, so it has much longer outputs. Again, though, this is somewhat task dependent, so I just recommend, actually, just as an aside, I would recommend once you get to the point that you're trying to optimize, that you have sort of that initial proof of concept with some model, something that works, I think it's really worthwhile it can be as simple as like literally just writing like, 3 different Python scripts that like are able to categorize each of these for a different model. And then as new models come out, you'll be able to quickly tell how they're doing. OK, once you've done, or in this case, once we've done this sort of benchmarking of where the models are, the next question is, all right, where do we need these models to be? Where do we need to get to? And so again, this is very task dependent. In the case of Method, they do have extra checks that happen after this, where they look and see, okay, are the numbers that came out plausible? Do they match, the types of things we've seen before? All these different kinds of checks they're doing. And so they didn't need to get all the way down to a 0% error rate. But of course, those checks are still fallible. And so if it's over a certain point, then some fraction of those errors are going to get through, and that's going to be bad. So we found around a 9% error rate was able to get them what they needed. From a latency point of view, so the way their agent works is a real-time system. It needs to be able to respond quickly to move through basically like through the whole flow to get the information it needs. And so they did have a hard latency cutoff. We see a wide variety in this for what it's worth. We have some customers that I talk to who it's like, hey, if I get a result back at some point in the next few days, like that's totally fine. This is a background batch process. We have other customers who are doing real-time voice with a human on the other end of the line, and it's like, hey, if I'm over 500 milliseconds, that's not going to work for me. And so again, you just have to know for your specific case how much this matters. Same with cost. In their case, because of that very high volume, as Mustafa was mentioning, cost is pretty important to them. Again, depending on your use case, usually mostly dependent on how high volume it is, will determine how much cost matters to you. But it's something you should know these numbers for your specific task as you're comparing different models. OK, so we're looking here at this. Of course, as you're looking at this slide, you may see there's a problem here, which is of the 2 models we're comparing at least, none of them actually meet all 3 of the requirements we need to be able to deploy this in production. And GPT-4o on both the error rate as well as the cost, we're not quite there. And then O3 Mini on the cost, but especially on the latency, it's just not going to work for what we need. So this is the point at which Method came and they talked to us. And we're like, hey, we're not able to hit what we need here. Because again, we're not, these models aren't getting us where we need to be. So what we work on at OpenPipe is fine-tuning. We work on building custom models for your specific use case. And so I'm going to talk about why you would want to do that and how that helps in this case. First, I would say fine-tuning is a power tool. It does take more time. It takes more engineering investment than just prompting a model. So you don't really want to do that until you have actually benchmarked the production models, just prompting them and seen whether they work or not. So in this case, in Method's case, and in all of our customers' cases, they found that they were not able to hit the numbers they needed. And so that's the time you want to bring in fine-tuning. So let's look at, we were able to fine-tune a model and see how that was able to help, because it can actually really bend that price-performance curve a lot. So on the error rate, which is basically just the inverse of accuracy if you want to measure it that way, we were able to get to a place where we were doing significantly better than GPT-4o, and importantly better than that threshold they needed. This used to actually be much harder to achieve. It required a lot of manual labeling of data and things like that. It's actually become much easier over time because of the existence of models like now O3 Mini, which allows you to just use your production data. You can use your, basically the inputs you're using in production. You can generate outputs for them using a model like O3 Mini and train on them. We find, like in this case, that often you're not able to quite get to the performance of the teacher model, the model O3 Mini in this case that you're using, but you can get quite close to it and usually do much better than a slightly less good but much larger model. In this case, the model we ended up deploying with them is just an 8 billion parameter Llama 3.1 model. And we find that actually for the majority of our customers, a model that large or smaller is good enough and is able to hit the numbers you need from quality. Yeah, the important thing is to be able to benchmark that and to answer that question for yourself. On the latency point of view, because actually this is sort of the magic of being able to move to that much smaller model, because we've got this 8 billion parameter model, it is way easier to deploy in a low latency way. There's just fewer calculations, fewer sequential calculations with a number of layers, and so you can get just a much lower latency. You can even, and we didn't actually have to do this in methods case, but something you can do is you can train this model, you can deploy it within your own infrastructure, co-locate it with the application code that's using it, and even completely eliminate the network latency. And then finally, on the cost front, again, just because this is such a smaller model, you end up with a much lower cost. And so that, for many of our customers, is incredibly important, is to be able to get that performance number you need while still maintaining a relatively low cost. In methods case, we were actually able to far exceed the sort of cost thresholds that they were looking for to make this viable, which means that they don't have to worry about this from sort of a unit economics point of view in the way that they did when they were using the larger models. So just to sort of reiterate what I started with before, this is a power tool. The fine-tuning it does take a fair amount of work, not an extreme amount of work, but significantly more work than you do for prompt engineering. However, if you're not able to get to the reliability numbers you need through just prompt engineering with the models that exist out there without tuning, it is a viable way to very strongly bend that price-performance curve and get to a much better place, which can help you get to a very large scale in production, just like Method did.
Nice. So yeah, just to wrap up here, one thing that, or at least a couple points that we want to highlight is that the reason we put 2 engineers in the title is also because it's not that complicated, right? You can get away with we identified a specific use case, and we got away with just using the cheapest model that was out there. We fine-tuned it. We already had the data from GPT in production. So we already had the data. We didn't have to go digging around for the data in the first place. So we already used that, and we used the cheapest model that gave us the fastest performance. And you don't need to buy your own GPUs. And the other thing that we realized is that productionizing AI agents actually requires a little bit of some level of openness and patience from the engineering team, from the leadership team. It's because when you write code, we're all used to writing code that just works. You push out a feature and never breaks because you're not changing anything. But with AI agents, it takes some time to get to a point where it's like production ready and actually gives you the responses that you're looking for. And I feel compelled to say something to mark the top of the traditional software engineering job. So I'll leave you with these last few words. If you're in SWE, pivot to AIE. Thank you.
Thanks, everyone.
Our next presenter is a staff software engineer at SuperDial, and he's here to tell us how to make reliable voice AI agents. Please join me in welcoming to the stage Nick Karyotakis.
Hey everyone, I'm Nick. I'm an engineer at SuperDial, and first of all, big thanks to the organizers. This event has been awesome. I've had a blast talking to you guys, connecting with you guys, and hearing all these great talks. Somehow, I'm one of the few voice AI talks today and this weekend, so I have a lot to cover. We're going to dive right in. If you're new to voice AI, I hope I can provide a nice little framework to think about this very fast-moving space. And if you're building with voice AI already, I'll be sharing some little anecdotes from our own scaling journey that I hope will help yours as well. So, voice AI in 2025, extremely exciting. We're seeing these new smart, really fast, really affordable LLMs that are supporting a lot more complex conversational use cases. But you still kind of need some tricks to take your chat agent and turn it into a voice agent. We have these low latency, really realistic, super generative text-to-speech models. But sometimes we have audio hallucinations, and we have to deal with things like pronunciation and spelling. With all the new things that people are building, there's this explosion in voice AI infrastructure and tooling and evaluation systems. And a big question becomes, what's actually worth owning? And the big one on everyone's mind are these new speech-to-speech or voice-to-voice models. And our take is that for a lot of production applications, they're not quite yet ready. And a big reason for that is they start to output things that aren't actually speech, aren't actually things that you can use to build a reliable conversation. And we saw this when they first came out. They were like imitating people's voices. And from the start, that's why we've kind of been favoring reliability over this sort of realism. So today, I'm going to talk about how we at SuperDial approach agents as a service, how we think about the voice AI engineer, and the last mile problem. So once you have your little voice MVP, all the challenges that you're going to face trying to actually make it reliable and put it to work. So at SuperDial, we're in the business of phone calls, specifically one of the most annoying phone calls ever, that phone call to your insurance company. So for mid to large-sized healthcare administration businesses, we sell the SuperDial platform. And with SuperDial, you can build your script, so design the sort of conversation, ask all the questions that you need to get answered over the phone. You send us your calls via CSV, API, or we also integrate with a lot of EHR software systems. And then, within the next couple hours and the next day, we send you back your results in a structured format. And this makes for a really interesting agentic contract that we sort of have with our customers. So from their perspective, they're paying for results. They tell us who to call, which questions to ask, and we tell them the answers. Internally, we have a little agentic loop set up so that we go out, we wait for these offices to be open, we wait for the call centers to open so we can actually make these calls. We will attempt to make the call with our voice bot, and then if our voice bot needs to bring in a human to complete the call, or cannot complete the call after a certain number of attempts, then we send it to a fallback team. And this is something that, of course, we're transparent with our customers. In fact, it's a benefit to them because it's kind of inevitable with these healthcare phone calls that sometimes you need to bring in a human. So with us, they know that no matter what happens, the call will get made. Whether or not it gets made with a human or a bot doesn't matter to them. They get their answers reliably and in a structured format. And with all these calls, we try to do our best to learn from them. So we'll update the sort of office hours for the given phone number we're calling and learn from the sort of phone tree traversal that we just tried. So that when we call it again, we get even better at that sort of call. And because they're sensitive healthcare phone calls, we want to make sure our system always works. So randomly, we'll take out some of these calls, audit them, make sure everything's working. For a quick little demo, this is actually a prior authorization call. This is after the point where we've traversed the little phone tree by clicking the right buttons, and now we're talking to a human and trying to get some questions answered for a customer.
May I know your first name? Hi, this is Sarah. Are you calling from a doctor's office or from a facility? I'm calling from supervisor's office. Do you have a member ID or a case number?
The member ID is...
What is the CPT code?
The CPT codes are 81243.
Okay, hold on. So there's a case on file that was initiated for the code 81243. It is pending. So this case number is, and we have not received any clinicals for this case yet.
Okay. What is your name again, and what is the reference number for this call?
My first name is. You may have the pending case number as a call reference number, and the fax number on where to send the clinicals is.
Thanks so much for your help.
You're welcome. Thanks for calling. Have a great day.
So that's it. If that call was really boring to you, thanks. If that call was really boring, that's kind of just how these things go. A boring call for us is an excellent call, because it turns out a lot of work is boring. So with this system, we've been able to save over 100,000 hours of human phone calling time, and we're on track to save millions more in 2025. And what's really incredible about voice AI today is that we did this with a really lean team of 4 engineers. So building the whole full stack web application, these EHR integrations, the bot you just saw, all while bringing on new customers, supporting new conversational use cases really quickly. And a big part of why that was possible was because we really all embraced this role of a voice AI engineer. So let's kind of uncover what's unique about a voice AI engineer today and what hats they may be wearing. So starting from Swyx's original draft, we can kind of see that a voice AI engineer is going to deal with multimodal data. So MP3s, audio bytes, in addition to transcripts, you're dealing with transcription models, voice models, speech-to-speech, all that sort of thing. The application you're building, it's in real time. Latency all of a sudden matters so much more. You're going to be dealing with async in Python a lot more than you probably wanted to be doing. And the product constraint here is almost always going to be a voice conversation. So people have really high expectations of how these sorts of conversation goes. For us, we're slotting ourselves into an existing business interaction, and people expect us to be conversational and fit into that use case. So to grapple with all these challenges, we kind of have 2 sayings at SuperDial that we've been saying over the past year and a half. Say the right thing at the right time, and build this plane while we fly it. So the trickiest part for us is customizing all these scripts and all these use cases for each customer individually, and then we really rely on this kind of horizontal voice AI stack to help us out with all those other problems. And this is kind of how we think about the voice AI engineer today and its unique roles. And in the larger context, we're really at this inflection point where it's so easy to build out an MVP for these sorts of applications that ultimately what is going to make your voice bot unique isn't its voice or its interruption handling or how realistic it sounds or how it does turn taking. Ultimately, it's going to be in the conversational content and the design there and the vertical integrations around it that make your agent's work actually valuable. And if you're like me and your favorite classes in college were the AI ethics ones, everything I just said about moving fast, building with generative AI could raise a few raise some alarms. So it's not hard to imagine how voice AI apps specifically could be biased against people with certain accents, speaking with certain dialects, or be really spooky when they sound so real and then say weird things. So in the US, we both enjoy and suffer from a lack of AI regulation, and that leaves the onus ultimately on the AI engineers and leaders in this room to think about these sorts of problems. This is not gonna be a talk on AI safety and ethics, but I think for voice AI specifically, with how it's such a new modality of interaction with artificial intelligence today, I think it's really important how we go about building it. So for AI engineers, when we go about making tooling and infrastructure choices, remember that developing AI should be really accessible and collaborative. And the work that AI does should be for everyone. And a key part in making sure that's the case is choosing tooling and infrastructure so that a really diverse set of stakeholders can be involved in that process from the start. So with the role of the voice AI engineer kind of scoped out now, let's dive into some of the last mile problems in voice AI that we've been dealing with. So when we started out, we had a really strapped together pipeline of a transcription model and an LLM and then a text-to-speech model. This was awesome to get started at, but we faced a lot of problems very quickly. And a lot of what we were learning was not new at all. So though the voice agents we see today are better than ever, voice UI itself is not that new. So when we were just getting started, around a year and a half ago, I had the chance to speak to Kathy Pearl, who is a close family friend and has been working on the UX of Gemini. She's been in the conversation design game for like 20 years or something. And back in the day, like voice UI was lots of phone tree design, and then it became these Alexa and Siri type things. And now we're just in this whole new world, but a lot of the principles remain the same. And one of the biggest things that's changed with developing voice UI is this shift from prescriptive to descriptive development. So we no longer prescribe what we want our bot to do over the course of the conversation by mapping out every possible direction that it could go. Instead, we describe what we want to do and then kind of pray to the generative gods that it happens. And for this, there's a lot of things I'd talk about with conversation design, but it comes up really quickly when that becomes your main interface. One thing for us is when we're asking these questions, should we be really open-ended with it or kind of constrain the user into selecting from a list of choices? And for us, because these are existing conversations, we find it's often better to just go general, hope the call center representative gives us a ton of information, and then instead of trying to prevent them from saying the wrong thing, we try to adapt to whatever they say. So Kathy's recommendation was hire a conversation designer. If you're thinking about these sorts of problems, they're experts in this. And if you're just a voice AI engineer and you want to get started in this kind of thinking, a great recommendation is to do little table reads. So have one person pretend to be the bot and the other person to pretend to be a user. And the sort of like transcript that you may write out by hand, immediately the sort of gaps and awkwardness of it comes out when you say these things out loud. So knowing all these things, we were really excited to work on our conversations, but we kind of had to deal with the tech debt of the orchestration framework that we had built. So we really hit our stride when we started using PipeCat for our voice AI orchestration. This is an open source framework maintained by the guys at Daily. It's really easy to extend and hack upon, which is important for our use case when we need to do transfers and stuff. And we make really long phone calls. These can be like an hour and a half long. So a big decision for us in choosing PipeCat was that we can self-host it and deploy it and scale it how we want. So with some of our voice orchestration headaches dealt with, we really wanted to get back to focusing on our conversations. And everything in this slide, for us, is really not unique to voice UI and AI. So I'm going to kind of speed over it. Two interesting decisions we've made here because we just have an LLM in the backbone. We chose to own our own OpenAI endpoint. We find this leads to a better interface with a lot of these new voice AI tools. So behind our OpenAI endpoint, we can kind of route to different models that are maybe more latency sensitive. For all of our generative responses, we route them through this tool called TensorZero. TensorZero is relatively new. They have this nice framing of LLMs. If that quote interests you, I recommend you look them up and talk to them. They're awesome. This is like a little open source tool, so you can do whatever you want with it. They give us kind of structured and typed LLM endpoints that we can then experiment with in production. So that's our gateway to our LLM. And then all of our logging and observability, we self-host LaneFuse. And we self-host these things also because these are like healthcare calls. We have to be HIPAA compliant. That's often an easier way to deal with the rapid growth of this space. So there we do like anomaly detection, evals, and data sets. So with a good plan in place for our LLM sort of work, another big challenge is our text-to-speech system. So when you make these sorts of phone calls, your password is basically your name, your date of birth, and then your member ID or something, which is like a 12-digit long string of characters that you have to be able to communicate over the phone. And something we quickly realized was that what our LLM is outputting is not necessarily what we want to shove through our text-to-speech engine, and neither of those things may actually match what's in the recording. So a little example of this, and this is like a personal last mile, is that if you're building me a personal voice UI application, it should say my last name correctly. So my last name is pronounced Karyotakis. Most people and most models will say Karyotakis. But with a lot of new tools out there, this is the syntax this company called Rhyme uses. You can spell out the exact sort of pronunciations you want. And then for things like spelling, where you may have kind of an intuition for like the sort of pauses and breaks you might want to use to say a really long word, you can use something like this little spell function. And then with all this stuff, like, because this is outputting audio bytes, we usually review recordings to make sure that this all sounds okay, in addition to checking the transcripts. And to start wrapping things up, I have a couple little mini last mile problems that we've had to deal with. Oh, and yeah, with voice-to-voice models, all this sort of rule-based stuff gets a little more complicated. So, some little mini ones. We used to be called SuperBill, and we called our bot Billy, because we thought that was a fun name. Turns out that's an awful name over the phone, because we would constantly have these conversations where people were like, hey, nice to meet you, Billy. And we would say, it's Billy, not Billy. So yeah, think about your persona a lot. Dial that in early. If you're just starting, don't build from scratch. What's gonna make your bot unique is the conversation, and there's so many new tools out there, like PipeCat, that you can use to get a quick jump start. Track latency everywhere. Time to first byte for each of your little processors is the new most important metric, and is something you always kind of have to keep an eye on. Upgrade paths. This is a big one for us when we need to make sure we have really high transcription accuracy. So we use DeepGram for our speech-to-text engine, and we know that whenever we kind of want to improve that part of our system, we can work with them to fine-tune a better model. Have fallbacks ready. It really sucks when OpenAI goes down for a little bit, and all of a sudden, all the concurrent conversations you have are just down the drain. So have fallbacks ready for each part of your stack. It's really easy to set that up with something like TensorZero. There are lots of other tools that'll help you figure that out. And then end-to-end testing. This is pretty unique for voice UI or voice AI. It seems like people are kind of settling on telephony as a boundary layer to test your bot with like an external service. We do a couple different things. The easiest test for us is to create a kind of fake phone number that just plays an MP3. If your bot can't talk to an MP3, then you probably have bigger problems. Next, we can kind of create a simulated voice tree with like different like phone tree building tools and have our bot pseudo-navigate it. And then there's lots of generative services like Koval and Vocera where you can have your bot talk to another bot. So some takeaways for a quote-unquote vertical voice AI engineer. Choose your stack wisely. The better decision you make here, it will allow you to focus on the things that are really, truly unique to your conversational experience. Laser focus on the last mile, because this is where ultimately you can provide a lot of value and put your agents to work. And then ride the wave. There's so much new stuff happening in this space, and whenever new models come out, you want to be able to use them quickly. And you also want to be able to use them safely. So thank you very much. I'm excited to talk to you all, and to hear about what's so special about your conversations.
Our next presenter is a head of applied AI at RAMP, here to teach us how to scaffold our agents wisely. Please join me in welcoming to the stage Rahul Sengotuvalu.
All right, while we're getting set up, can anyone find what the problem is with this slide? Yeah, working on it. There we go. Nice. I think I'm the only presenter using Figma slides, so I had to use my own laptop for it. Cool, guys. So the problem here is it's a bitter lesson, but lemons are sour. So I only realized like 10 minutes ago, but I like the graphic on there. So a little bit about me. Head of applied AI at RAMP. I've been working on LLMs for 4 years, which is, well, kind of a long time, I guess, in LLM land, because everything started happening really when ChatGPT came out. So I was trying to build what people would now call an AI agent company. Back then, we were just doing customer support. We're trying to make our chatbots smarter, and we're trying to figure out what models to use to, or what tech to use to get them to respond to customers better. And we were messing with GPT-2 on BERT, and models were so frustratingly stupid. And the context windows were small, and they were not very smart at reasoning, and it was just incredibly annoying. And we just wrote lots of code around these models to get them to work at least somewhat reliably. And along the way, as models got smarter, just kind of had to delete more of that code. And this ended up seeing a lot of patterns in what code needs to get deleted, how to build agents in what ways that will scale with more intelligence. And clearly, we're going to continue to get a lot more intelligence. And I just wanted to maybe talk about a single idea throughout the talk through various examples. We'll do some setting, but I'll also have a bunch of demos to kind of like drive home the point, and maybe I can convince you guys that there's a certain way of building agents that's slightly better than other ways. I also built a structure extraction library called JSON Former. I think it was the first one. I'm not fully sure, but timing-wise, it was before all the other major ones. And that was also scaffolding around a model. Models were too stupid to output JSON, and we were just really begging it, pleading it, and forcing it to act in ways that we want it to be. So as I said earlier, just have one core agenda item here, which is want to convey one idea. We'll start off, all of you probably read the essay bidder lesson, just quickly go through what it is. We'll go through a production agent we have at Ramp and how it works and 3 different ways of architecting it. And then I have a demo to really push maybe how we all think about how software and backends and things will work in the future. So very simply, the idea is just that systems that scale with compute beat systems that don't. So there's 2 systems, and without any effort, one of the systems can just think more or use more compute in some way. That system tends to beat systems that are rigid and fixed and just deterministic. So from that idea, it's pretty clear, like if you're building systems, you might as well build systems that improve with more compute. And this seems pretty obvious, like obvious conclusion from the bidder lesson. Taking it a step further, why is this true? It's because exponentials are rare. Like they just don't exist. Most things in the world aren't exponential. So when you find one, you just should hop on, strap on, and just take the free pass and go for the ride. And you probably shouldn't try too hard. And there's a lot of examples from history that kind of reflect this. So for chess and Go and computer vision, Atari games, like people have tried to build lots of systems and written a lot of code. And my way of thinking about rigid systems is just like spending a lot of time grinding weekends and writing very clever software, well abstracted, maybe trying to synthesize human reasoning and thought process into features, and then using them in clever ways and trying to approximate how a human would think. And if you actually fix the amount of compute, that approach will win. But if you turns out if you end up scaling up how much search you're doing, the general method always ends up winning, even like in all these cases, so Atari, Go, and computer vision. A little bit about Ramp. So Ramp is a finance platform that helps businesses manage expenses, payments, procurement, travel, bookkeeping more efficiently. And we have a ton of AI across the product, so automate a lot of boring stuff the finance teams do and employees do with submitting expense reports and booking your flights and hotels and submitting reimbursements, all of that. And so a lot of the work behind the scenes is just we're interacting with other systems and helping like legacy systems and helping employees get their work done faster. So let's actually talk through one of the systems we have today at Ramp and maybe talk through like the different versions of the system and how it evolved over time. So we're going to talk about something called a switching report. It's a very simple agent. All it needs to do is take in a CSV arbitrary format. So the schema could be seriously anything from the internet. And we want these CSVs to come from third-party card providers. So when people onboard to Ramp, we want to give them a nice checklist and say, hey, here are all the transactions you have on other platforms, and we want to help you move them over. And the more transactions you have on Ramp, the more we can help you, and the more you'll use our software, and more everyone benefits. And so the switching report is just really a checklist. But to read people's CSV transactions, we need to understand those. And other platforms have all these kinds of crazy schemas. And so the description of the problem we have here is just for an arbitrary like CSV, how can we support parsing it and then into some format that we understand. So let's just start with the simple approach, right? Is like, let's just take the 50 most common third-party card vendors, and then just manually write code for all of them. Now, obviously, like this will just work. It is some work, Not a lot of work, but you still have to maybe go to 50 different platforms and download their CSVs, see what schemas they have, and then write code. Maybe if they decide one day they change their format, your thing will break, but that's OK. You'll get paged, and you can wake up and go fix it. So let's maybe introduce some LLMs in here. So from the over-engineered code where you ended up writing 100,000 lines, maybe we want a more general system. So let's introduce a little bit of LLMs, a little bit of AI in here. And so in the deterministic flow, let's maybe add some, or just like scripting in classical scripting land, let's add some more calls to OpenAI, or you have an embedding model, you want to do semantic similarity or something like that. So then let's just take every column in the CSV that comes in. Let's try to classify what kind of column it is. Is it a date? Is it a transaction? Is it a transaction amount? Is it a merchant name? Or is it the user's name? And then we map it on, and then we probably could end up in a schema that we're happy with. Again, most of the compute is running in classical land. Some of it is running in fuzzy like LLM land. But this is somewhat looking like a more general system. Let's go maybe a different approach, when like we just go all the way through. Let's just say we're just going to literally give the CSV to an LLM and say, you have a code interpreter, so you can write whatever code you want, pandas or all the faster Rust-based ones. You have all these Python packages. You're allowed to look at the head of the CSV, the tail, whichever rows you want. And then I just want you to give me a CSV with this specific format, and here's a unit test. Here's a verifier that you can use to tell if it's working or not. Turns out this approach actually doesn't work. Like, we tried it. If you only run it once. But instead, if you run it 50 times in parallel, it's actually very likely that it works really well and generalizes across a ton of different formats. The amount of compute here is actually probably like, what is that number? 10,000 times more than the first approach we came up with. But again, like, what is truly scarce in the world is engineer time. Maybe not in a while, but at least today. And we'd rather have a system that works really well. And even with the 10,000 times more compute, it will probably cost less than $1. And every transaction that's switched over, every failed CSV will cost the ramp way more money than whatever money we spend on this exact architecture. So this is a very specific example. It's like, how does this apply to the agents that we all build and maybe the systems we're all working on? Turns out something like this actually generalizes. So if you look at the 3 approaches, and let's assume like the black arrow is just classical compute, and then the blue arrows are fuzzy land. So it goes into neural net, and all sort of weird matrix multiplication happens, and then we're in latent space, and it gets all alien intelligence-y, and then comes back to classical land. First approach, there was no AI. We just wrote code, and it just worked, mostly. The constrained agent, so the second approach, we broke into fuzzy land from classical land when we decided we wanted similarity scores or something like that. And then the third approach is actually flipped, where the LLM decides it needs to go into classical land. So it writes some code, it writes some pandas or Python code, and it decides to break into this classical land when it needs to, but most of the compute is fuzzy. Actually, this is maybe not the most accurate graph, like, because I proposed that we run it 50 times. It more so looks like this. But if you look at a backend in general, they're all request response. So some sort of message is going in. It's like a post request or get or update or read, any sort of CRUD operation. And we're really just asking the backend to take this piece of information, do whatever you must with it, run out whatever mutations you want, and return me a response. And almost all systems we've built so far as like humanity, I guess, like look like the first one. But more people are using OpenAI. OpenAI makes billions of dollars, and probably a lot of the systems that use them look like number 2, where just regular programming languages are calling into OpenAI servers, and we're running some fuzzy compute. What we're seeing in like more and more parts of the RAM code base, we're moving to the third approach because it just tends to work well. Because all the blue arrows, if you did nothing, absolutely nothing, we all went to vacation for the next year, the big labs are still working and spending billions of dollars making those models better. And so the blue arrows will get better. And so how much blue arrow you're using in your code base actually will help directly your company without much effort from your end. So this is what I was saying is like the bitter lesson is just so powerful and exponential trends are so powerful that you can just hitch the ride. Let's take this idea like further. Let's actually like go all the way, like something crazy. On the left, you'll see a traditional web app. So usually the way it works is you open gmail.com, and some static file server and Google is sending you a bunch of JavaScript and HTML and CSS. Your browser renders that and shows you some nice UI, nice HTML that's user-friendly. Maybe you see some emails. Maybe you click on one of them. The front end makes a request to the back end. The front end asks the back end, give me the content for email and whatever ID it is, and then the back end hits the database and gives you the result. And maybe they use CodeGen. Maybe they use all the CodeGen tools available to make Gmail. So that was probably, the LLM only worked when the software engineer was writing the code. But once the code is written and it's like pushed to production, it's just classical compute. And on the right, I'm actually proposing a different model, which is the backend is the LLM. It's not CodeGen. It's this LLM is doing the execution. It is the backend. So the LLM has access to tools like code interpreter and potentially has access to, through that, making requests, network requests, and also has access to DB. So I have a mail client, actually, that works with this principle. And this is my test email. So if y'all want to see any emails you send to me in a minute or so, you can send me an email. But please be nice. All right, I think it's probably enough time. So I'm going to go over So we have this email client. I mean, we still have some regular JavaScript to hook into the LLM, hook the LLM into the browser. But when I do log in, I'm going to use my email as just showing you. Oh. What? Oh, it's probably. Okay, we're good, we're good. All right, we're saved, I think. Thankfully, I have a room full of engineers. So there's a dot, but the reason it's so slow is because when I open this page and log into Gmail, the Gmail token is actually being sent to an LLM. We're saying, literally, this is an LLM chat session. What we're seeing on the screen is like, hey, LLM, you're actually simulating a Gmail client. You have access to all the emails. You have access to Rahul's Gmail token and a code interpreter. And so just render some UI based on what you think is reasonable for the homepage for a Gmail client. And so looks like it decided to render as Markdown. I think we actually tell it to render as Markdown. And it's rendering all the emails that a bunch of people sent me from here. So it looks like it says, hello from California. So I'm going to click on that. When I click on that, we're actually not running any like backend calls or anything like that. We're just telling the LLM the user clicked on that piece of text. In this case, it was hello from California and the ID number. So the LLM now has the information on what the user clicked on, and it has the chance to re-render the page, much like a web framework would. So again, it goes back. It probably hits a GET request for that specific email and pulls the body. What is this agent going to do? I'm watching you live. So the LLM just decided this is the appropriate UI for a Gmail client. And also, I have other features the LLM thought was reasonable, so it looks like I could mark it as unread or delete the email if I want to. Maybe I'll delete it because it's not that good of an email. I'm sorry. It is very slow because we're doing a lot, but wanted to push you in this direction because this kind of software barely works. Dang. I guess not. Also, I clicked on it, and now the LLM is trying to do something with me clicking on it. But anyway, this kind of software barely works today, and it doesn't mean it won't work in the future. But with exponential trends, like things like this might just take off. So just wanted to push you all to think in this direction. Yeah, will more software look like this? I don't know. We'll see. Thank you.
Ladies and gentlemen, please welcome back to the stage MC for the AI Engineer Summit, Agent Engineering Day, the founder and CEO of SuperIntelligent, NLW.
All right, guys. Thank you, Rahul, and everyone else who presented. The theme of this whole event is agents at work, and one of the things that we called out this morning is that what makes it so different than events that we've had in the past is how much this is about real-world happenings, what's actually being built, the challenges that we're facing in deployment and production. I think this session was a great example of that. We are headed into another break. We have about 30 minutes now. A quick reminder, you can go meet speakers in the Q&A lounge, or you can check out the sponsor expo. There is also coffee and snacks down there. So see you in about half an hour.
That concludes this session. Please enjoy one final break in the expo with sponsor demos, food and drinks, and a special panel on the expo stage with welcome to the stage, MC for the AI Engineer Summit, Agent Engineering Day, the founder of Turing Post, Ksenia Sa.
Hello. So this is our last stretch of sessions. It's been such a long day, and I'm excited still. This is going to be 3 sessions. There's one change, but you don't want to miss these sessions. They're amazing. The first one is creating agents that co-create. The second one is about education. This is a change. It's called the next AI engineers. And the last one would be, what does it take to build a personal, local, private AI agent that augments you deeply? Sorry. It's all about building now. It's all about building AI that is truly integrated into our lives, and now from very, very early age. With that, please help me to welcome our next speaker. She has a very interesting experience on working on both ChatGPT and Claude. Please welcome Karina Nguyen.
Hey everyone, my name is Karina, and I'm an AI researcher at OpenAI. Before that, I worked at Anthropic for about 2 years, working on Claude. So today, I would love to chat more about what kind of scaling paradigms that has happened in the past 2 to 4 years in AI research, and how those paradigms unlocked new frontier product research. I'm also going to share some of the vignettes from some of the lessons learned by developing Claude and ChatGPT products, some design challenges and lessons, and how do I think about the future of agents as they become from collaborators to co-innovators in the future. I would also love to invite you to engage in the conversation. So I'd be more than happy to answer some of the questions at the end. Cool. So not sure if probably the majority of you know this, but I think there are 2 scaling paradigms that has happened in AI research over the past few years. The first paradigm is the next token prediction. And you might have heard this as called pre-training. And what's really amazing about the next token prediction is that it's a world-building machine. The model learns to understand the world by predicting the next word. And I think fundamentally, if you think about it, this is happening because certain sequence is caused by initial action, and this is irreversible. And so the model learns some of the physics of the world to understand. And the token can be anything, right? The tokens that we pre-trained are strings, words, pixels. It could be anything. And so to predict what will happen next, the model needs to understand how the world works. And this is why pre-training works. And so you can imagine the next token prediction is the massive multitask learning. And what's amazing about this is that during pre-training, some tasks are really easy to learn, such as translation, right? Like the word boarding in French is. The model also learns a lot about the world. The capital of France is Paris. And because some of the information is much more present on the internet and in some of the knowledge artifacts, the model has much easier time to learn this. But actually, the reason why compute is so important and scaling compute in the pre-training stage is so important is because there is a new class, there is a class of tasks that is really, really hard to learn. And for example, the model learns a lot about the physics. It learns so much about the problem solving, generation, and the logical expressions. It learns some of the spatial reasoning, although it's not perfect. But we are getting to the complexity of the tasks, such as math, when the model has to compute this number during the next token prediction. It's actually really high. So that's why you need chain of thought, or might spend more compute on the chain of thought to help the model to reason through more computational such tasks. Another class of tasks that I was thinking a lot about is creative writing. It's actually really, really hard. And the reason why it's so hard for the model is because you can predict very nicely the style of the writing, but a lot of the creative writing is actually world building and storytelling and the plot. And it's much, much easier for the model to make a mistake for the next token prediction in such a way where it will completely deteriorate the plot coherence, which is really important for the stories. And this is an open-ended research problem, creative writing in itself. And the reason why it's because it's really, really hard to measure what is a good creative writing, what is not a creative writing. And obviously, we would love for the models to invent new forms of writing and be extremely creative in their generations. But this is actually one of the hardest AI research problems today, is how do we make models to write novels and have coherent stories over the long course of the period of time. So I think the era of 2020 to 2021, that was an era of scaling for training a lot, both at Anthropic and at OpenAI. And actually at that time, one of the first products was GitHub Copilot. And I thought it was a completely interesting product, the autocomplete, because it's so, in pre-training, the model has learned so much about the code and the next token prediction for the code by the billions code tokens using from GitHub, open source projects, et cetera. And what has happened for the autocomplete tap, tap, tap in the cursor or GitHub Copilot is that the researchers pre-trained via RLHF, reinforcement learning from human feedback, and then reinforcement learning from AI feedback to make it a little bit more useful to use. And this is where the era of post-training has gone off. So in post-training, we teach the model how to complete function bodies, understanding docstrings, how to complete, generating multi-line completions, predicting the next diffs, apply the next diffs. And I think we are still in that era where there is so much more to be explored in the post-training stage of RLHF, RLAF, to push the capabilities of models to reason through complex code bases. The next paradigm in AI research, which has happened last year, and it was published by OpenAI with the new model 01, is scaling reinforcement learning on chain of thought. And this is why we call them, it's highly complex reasoning. And you can imagine you spend a lot more test time compute on training to scale reinforcement learning. And the reason why it works is because the model learns how to think during the training and learn from the feedback by having really good signals in RL. So on the left, you can see the output of normal GPT-4o or GPT-4. And on the right, you can see the entire chain of thought that the model has thought about to solve the complex problems. And as we think about harder and harder tasks, if you want the model to go from translation towards solving medical problems, you actually need the model to spend a lot of time just thinking through the problem and completely creating more complex environments with tools and other tools and more complex environments to think through and verify its outputs during the chain of thought. So as you can see, the chain of thought itself is very interesting, and the model has certain words that it does. But there is a lot of science to be done in terms of faithfulness in the chain of thought. How do we measure the faithfulness? What happens if the model goes into wrong direction? Can it backtrack itself? I think there is a lot of science around that, and we are only at the beginning of it. One of the first projects that I've done at OpenAI is actually how do we, the interaction paradigm is very different now. So the interaction paradigm is the model thinks a lot to solve the problem, if the problem is hard. So, but how do we create this new interaction paradigm with humans such that it will be much easier so that humans don't have to wait for 15 seconds or 30 minutes for a model to come back? And one of the things that we did as a simple approach is to have a streaming model's thoughts to a user. And that way, we had to communicate what exactly the summaries of the thoughts with the model and communicate very wisely to human. But I think it's still one of the design challenges. As the model's capabilities and interaction paradigms change, you have new design challenges that you need to solve for these types of models. So, and I guess this year at OpenAI is the year of agents. And the way we think about it is highly complex reasoners, such as models trained on RL and chain of thought, using real-world tools, such as browsing, search, computer use, over a long horizon period of time, over a long context. But what's the next stage? In my view, the next stage level is co-innovators. And the way I'm thinking about it is it's agents that is built upon all the things that we've done with reasoning and tool use and long context, plus creativity. And creativity is enabled only through human-AI collaboration. And I think this is where I'm really, really excited about in the future, is to create new affordances for humans to collaborate better with AI, such that we both can co-create the futures that we want. And so those two scaling paradigms in AI research has unlocked us new kind of product research. And you can imagine product research being, oh, we have API from the model, and now we have to integrate in the products. But it's actually what's happening on the ground is we have a very nice rapid iteration cycle of the product development. And the reason why is because we can use those highly reasoning models to distill back to smaller models, or the models that we can iterate very, very fast. And we can use those highly complex reasoning models to synthetically generate new data such that we can create new post-training, new data sets, new reinforcement learning environments. So, so one of the things that we can do is creating completely new class of tasks. And if the task is how do we create a multiplayer collaboration with a human and AI, you might want to simulate different users. And how do you do that? You might want to synthetically generate data sets of different users, conditioned on the different users, and post-train on that. So it actually highly depends on what kind of product experiences that you want to create, and extrapolate that to a new class of tasks that you want to post-train the models. I think we are moving towards more complex reinforcement learning environments, which means we can allow models to use search or browsing or much more collaborative tools like Canvas during RL, such that they can learn how to become better at collaborating. We can leverage things like in-context learning. I think models are extremely, extremely good. So you can essentially create a new tool, and then the model will learn just via a few short examples. And this is extremely rapid iteration cycle for any developer. As I mentioned before, synthetic data via distillation is another thing. I think we can also invent new model behavior and interactions to utilize user feedback. So now we're going to go through some of the vignettes that has happened from Anthropic to OpenAI. I think the first concept that I've learned is how do we bring unfamiliar capability into a familiar form factor? And the reason why 100K context was successful is because we found file uploads is extremely familiar form factor. Everybody is working on documents. But you can imagine we could have deployed 100K context via infinite chats, such that it's like one huge long chat that you can interact with. But I think finding the simplest form factor sometimes for unfamiliar capability is one of the design challenges in this new era. The next project that I worked, the second project I worked on at OpenAI is called ChatGPT Tasks. And actually, I did not realize about this until it was shipped. Reminders and tasks, scheduled tasks, it's a very familiar thing that people do almost every day. But what's amazing about this product is that you can scale this with new kind of capabilities in the models. So ChatGPT Task is not just scheduled reminders and to-do lists. It's actually you can ask the model to continue the story every day for you. Or you can ask the model to search everything that you are interested in every day or every other day. So in a way, you can also help yourself to learn new language by having extremely multimodal and interactive visualizations that ChatGPT can create. And so I think this concept of your product feature should enable modular compositions that will scale very nicely in the future as the models will develop much higher capabilities is something that I've learned by doing ChatGPT tasks. I think another design challenge that we have here is how do we bridge together real-time interaction with models to asynchronous task completion, and where we can ask the model to go off for 10 hours to research or write code and then come back with a solution. And the bottleneck here is trust. And I believe that giving trust can be solved by giving humans new collaborative affordances to verify, edit model outputs, and having them to give models real-time feedback so that the model can self-improve. And one of the first products from Anthropic was actually Claude and Slack. And it was the first attempt to have a virtual teammate in your organization. And it was an amazing concept because Slack had all the affordances with tools and image uploads and multiplayer collaboration that you can create. And there is something in there that is still, I think there is still a lot of things that we can do here and take the lessons from Claude and Slack to the next generational products. Again, the task was also very much inspired by Claude and Slack prototypes when Claude could just summarize channels, Slack channels across the organization every Friday and have the summaries for everybody. My first project at OpenAI was Canvas. And I thought that human AI collaborative affordances could scale and create new creative capabilities. And what I really loved about the Canvas and the way we operate in Canvas as a team is that it was an extremely flexible interface that we could come up with. And here are some of the vignettes that we had. So the Canvas itself can become a co-creator and co-editor. And you can have a very, very fine-grained editing interaction. The model can also do search in order to generate the report. And then you can also ask a question back, hi, verify this output. And you can imagine this interface scales to multiplayer when other people can join your document, or even multi-agents. If I can create a model critic or an editor, they can use, you have a multi-agentic and multiplayer collaboration at the same time. And so this is a new design challenge that we need to navigate. How do we do that? I'm also excited for personalized tutors. I think the models are becoming extremely multimodal, extremely flexible, that you can learn new things in a new way the way you like. If I'm a visual learner and you are more auditory learner, the model can adapt to your personalization. Sorry. One thing that I did yesterday is that I was on the plane, and actually I used Canvas to create me a game. And so I really like this generative entertainment on the fly. Anyone can create their own tools and web apps now. And I'm not sure what the future will look like, but I think it will be extremely amazing if a person who never had to touch code ever before in their life, for the first time can create the tool that they really wanted and deploy that for themselves, or to start a business from scratch. And I think there's something around pair programming and code creators that we can use in order to create the future that we want. And so Canvas has also becomes more of a pair programmer. So the reason why Canvas is so flexible is because it was trained both to become collaborative for writing and coding. Because it has tools such as search and can search for API documentation, it can become a data scientist too. And especially if you upload the entire CSV docs, it can generate a real-time analysis. And finally, what I'm really, really excited, and what everybody is excited in AI, is how do we actually help models to become better at research and creating new knowledge. And here you can see that the model and the human can co-create a document or co-create a new artifact that has never been happened before. So here's a demo of the paper that I've co-published. And then I'm asking the model to kind of reproduce it. And you can imagine this is like maybe one of the most common tasks in research is to reproduce, or you can imagine to reproduce like open source GitHub repo. And you have like this very nice interactive paradigm where, because the model can also leverage its own internal knowledge, you and an AI can work together to come up with new research hypotheses and verify certain like research directions together. And you can also delegate the tasks to an AI assistant to do that. Finally, what I'm really excited about the future is that there will be this layer of invisible software creation for all. And especially what I'm really excited is like from the mobile itself, people can just create their own software tools. I think the way you interact with AI fundamentally changes in the way that the way you access the internet will also change. My prediction is that you will click less and less on the internet links, and the way you will access the internet will be via model's lens, which will be much cleaner and in a much more personalized way. And you can imagine have like very personalized multimodal outputs. Let's say if I say, I want to learn more about the solar system, instead of it giving me a text output, it should give you a 3JS interactive visualization of the solar system. And you can have like highly richly interactive features to learn more. And I think there'll be this like kind of cool future of like generative entertainment on the fly for the people to learn and share new games with other people. I think the way I'm thinking about it is the kind of interface to AGI is blank canvas that kind of self-morphs into your intent. So for example, you come to the work today and your intention is to just write code. Then the canvas becomes more of an IDE, like a cursor or like a coding IDE, although the future of programming might change. Or if you're a writer and you decided to write a novel together, the model can start creating tools on the fly for you such that it will be much easier for you to brainstorm or edit the writing or create character plots and visualize the structure of the plot itself. And finally, I think the co-innovation is actually going to happen with co-direction, creative co-direction with the models itself. And it's through collaboration with highly reasoning agentic systems that will be extremely capable of superhuman tasks to create new novels, films, games, and essentially new science, new knowledge creation. Cool. Thank you so much. I think that's the end of my talk.
The next generation of AI engineers will be learning more and more from language models and agents, like me. Here to provide a glimpse into the future of educating the next generation of AI engineers is Stefania Druga, research scientist from Google.
Thank you. Thank you so much. Hello, New York. How are you doing? Okay, so I know you've been hearing a lot of amazing talks, and before I get started, I wanted to see a quick show of hands. How many of you are here for the first time at AI Engineering Conference? Wow, that's amazing. How many of you are international, outside of US? Incredible, thank you for coming. So today I'm gonna talk about how do we open up this conference and how do we open up this knowledge to the next generation of AI engineers, which are young and start much earlier. And why does that matter? It's because 70% of AI users are actually from Gen Z. And we've seen the potential of multimodal AI to transform education. We know that students are using generative AI tools for their homework, and I think they can use it in a much more interesting way. We also know that in many cases they prefer it to human tutors. And I want kids to actually be part of the engineers and the designers that create the tools for them to use. And I turned to Scratch. I don't know, how many of you know Scratch? Wow. There are over 100 million children using Scratch worldwide. Scratch is a platform. It's free, it's open source for coding for kids. It's visual programming. It was developed at MIT. And I was part of that lab during my master's. And that's in 2015 when I started working on Cognimates. Cognimates expands Scratch to actually allow children to learn about AI by building games, training their own AI models, and programming hardware as well. So it has these kind of blocks. They look like Lego blocks, and they can put them together in order to create their programs. Does anyone want to guess what this program do? Any guesses? So Tiana here, who is 9 at the time, she wrote this program for the first time and then played with the robot using the program for half an hour, which was super fun. So it's a hide and seek game, right? So she would like run around the room, and the robot would turn around and say, every time it would detect a person, the number of people was like higher than 0. It would say, I see you. There is a problem with the program, though. Can you spot it? How many times are we going to play if we have it like this? Yeah. Yeah, so what do we need, Nick? We need a loop, exactly. Awesome. So the time to fun and the time to play is very short in Scratch, which is why I used it when I built Cognimates. It has this library of blocks, a coding area, and a stage. And I'm going to show you a quick video of how kids use it in order to learn more about AI.
So we were programming robots. You could play rock, paper, scissors. You did rock, paper, scissors into the camera, and on shoot you did one of the motions, and the camera did one of the motions, and it's like rock, paper, scissors, shoot. The computer gets like better as you play the game, because like us, we might not know everything at first, but if we keep trying, we get better.
Everyone has heard about like machine-based learning or artificial intelligence, and there was a sort of no questions asked for a lot of the more tech-savvy parents. It was like, go for it.
Technology is going to be a huge part of their lives, much more so than my life. If it's scary for some people, this AI technology, I totally get it. But as a parent and as a teacher, I thought it was really important because these are skills that 21st century kids need to have.
When my dad was young, he bought a car and took it apart to see how it worked. So you teach people that young how these things that grown-ups mostly program, how it works.
So we did this in 2015, 2016. These AI engineers started very early. And at the time, they were training these custom models with basic classification models for images and text. But they also had access to the entire library of extensions that we built for them, so they could use off-the-shelf sentiment analysis, image classification. They could program their voice assistants because they realized the voice assistants were really limited. So they could program the voice assistants to remember things about them and their preferences, program microbits, robots. And this is what the training page looks like. They can drag and drop examples of images. So for example, one kid wanted to make a game about unicorns and narwhals. So this was like what his training data looked like. And then this is what the program looked like. So he can choose his custom model, unicorns versus narwhals, and then show different drawings into the camera and see what the model predicts. And moreover, he or she can see, they can see the level of confidence of the prediction, which really helps them understand, oh, yes, in this case, it guessed that my drawing was a narwhal, but the confidence level is very, very low. What do I need to do? I'm going to go back to my training and add more examples of images that are hand-drawn because most of my images are cartoons. So it really creates this AI literacy, data literacy, and demystifies everything that kids learn about AI or hear about AI, that it's evil, Terminator, or all sorts of things, right? And they built projects that went across different domains. So it was a project where they could look at things in their food by transforming a webcam into a microscope. They could build games like the rock, paper, scissors that you've seen in the video, or a literature program where you speak and it analyzes what you say and it's seeing if it's in the style of a famous writer or different other types of styles. And what's important, like I tested this with kids in public, private schools and community centers. And what I found is that kids are actually like little scientists. So if we give them the right tools, they engage in the scientific process. They formulate hypotheses about how the model works or how the robot works. And then they test those hypotheses and they refine their understanding in the process. And it's the same with the model training. So we need to create tools that enable them to engage in the scientific process as fast as possible and create tools that are fun and sticky that they want to use. And why does this matter? Before allowing them to program with Cognimates and train their own models, I actually asked them questions about voice assistants and other smart toys and smart robots at the time. And I asked them, do you think it's smart? Do you trust it? Do you like it? Is it friendly? And I asked the same questions about those technologies. We didn't have ChatGPT at the time or Gemini at the end of the study. And what I found was that there was a significant difference in the intelligence attribution after they engage in this process of learning how to train a model, learning how to program it, understanding why the data matters. So it does make a difference in demystifying the intelligence that we talk about. And this platform is used around the world. It's actually translated in 50 languages. And I realized after I worked on this that it's not just the kids. Like the pandemic came, and a lot of young people were stuck at home. So I had to like really think about how do I create and how do I work with families. So started to do a lot of other experiments. And I figured, like, what are the type of tutors or games or platforms that families could use when they're at home and maybe they want to learn how to code with their kids? And I'll show you an early prototype.
Hi there, I would like to know your name. So let's do a program that allow me to learn it. Let's start with the green flag block. There you go. You did it. No, I need you to help me ask a question. For that, we'll need the ask block. See if you can find it.
Awesome. So
in this case, they're learning how to program a robot. It was a Jiba robot. And the robot itself, it's participating in the process. So you're having like this reflective conversation with the thing that you're programming, which is pretty cool. And we could do that much more than that now. But because not everyone can afford to buy a robot, or like it's not a required thing, I wanted to build something similar, like a pair companion for programming that works in the browser. So during the pandemic, I started doing this design studies with families in 10 different states in US, very different backgrounds, very different ethnicities. And this is very important, and I wanted to highlight that here. Before building the system, I mocked the system. So we didn't have a functional copilot or a functional assistant. I was the AI. And it was a Wizard of Oz study. Like the kids did not know initially. We told them afterwards that they're interacting with a person, but they would interact via chat. And I really wanted to understand, what is it that they want? What kind of supports do they need from a pair programmer when they code on Scratch with their parents? And what I found was that they really want to generate coding ideas. They don't want the copilot in Scratch or in Cognimates to do everything for them. They want to kind of brainstorm, like, what if I want to do a game about bears? Or what if I'm into soccer? Like, give me some ideas. That was a really big one. And here are some quotes. Like, one of our participants who's 12 said, most people would like coding with AI friends because one of the hardest parts of our project is when you start and you run into a wall. You are out of ideas. So it really helped with the ideation process. It also helped them kind of express and elaborate their ideas. Like if they would play a Pong game, it would ask like, okay, so how do we make the ball move? Or like, how do you make it move faster? So it was very helpful in that regard as well. And it supported their creative coding identity, right? So another quote, I like it because sometimes when you code, it gets frustrating. You finally get it to work. It's so good that it lets you feel good. It's good when you have someone that says to you, good job. And what's interesting is that the kids participating in the study spent double the amount of time programming that they would spend normally. And I got that from parents. And it didn't always work. Sometimes like the parents were needed in the loop, like if it was too distracting, or if it wasn't able to moderate turn-taking between siblings. Or if the, agents have limitations, AI has limitations, or it wasn't always able to explain the most complex concepts. Like in Scratch, there is this thing called clone, when you create multiple instances of the same object, or broadcast. That was harder to explain. So after doing this first design study and identifying like what are the core features that kids and parents want, I created an evaluation benchmark. So I actually had over 100 cases of Scratch programs, and I would run this against like different state-of-the-art models and see how good these models are at explaining the Scratch code, at explaining it with learning exercises, at debugging it, at generating ideas. And the results were very promising. So the next thing was to build it. And this is the first time I'm showing these results. I just finished running the study, so it's very off the press, very fresh from the oven. And I just tested this Cognimates Copilot with young people, 18 young people from 11 different countries in different languages. And it was kind of cool. Like, it's very simple. It's the code editor, and it has this AI chat. It's sending a message to a web server and then gets a response. I'm using and evaluating different models, including a fine-tuned model on Scratch projects. And it can also generate assets, art, like images for their games. And here's an example from a session with a kid from Mexico. So all the session was done in Spanish. I speak many languages, so I could do this session in different languages. And so does the Copilot. And what I found in analyzing these sessions from 18 kids is that the Copilot provided all sorts of supports. And it was conceptual support, design support, positive encouragement, platform navigation. There were instances where it failed. And I also saw lots of instances where the kids would refuse the suggested help or the suggested ideas. And here's an example of code support. This was a student from Jamaica. And he had never programmed in Scratch before. So he was able to go from 0 to actually having a fully functional program with the support of the Copilot. And the Copilot was actually very helpful, not only in giving him ideas, but also helping him understand how to navigate the platform for the very first time. Like, this is where you find the loop block, and this is how you create variables. So it was very helpful for people who were new. For people who were advanced, it was also very helpful because it would generate assets that they really liked. It would give them ideas like for how to refactor. It didn't call it refactor, but like improve the code, or how to add new features or new levels. And it was interesting because kids would use it in a lot of ways I didn't predict. Like besides like generating the background in this game, also like they wanted to get names, ideas for names for characters and ideas for plots. And this is a great example like where a student is actually pasting an image of the code and it's asking for an idea and he actually doesn't like the answer. So he said like, I don't want to do that type of movement. And then the Copilot says, no worries, it's your game, have fun, right? So we want to have tools that are actually prioritizing and encouraging young people's agency in this process. Some lessons learned, to prioritize users' agency, to balance the support and the challenge that we give them. By default, the Copilot does not give the answer. Initially, it asks questions, and if the student is really stuck, after asking the same question 3 times, it would give a hint. To see these agents as motivators and starting point, right? Like the effect of the blank page when you start to write. The effect in Scratch is called cold start. We see a lot of students that go to the platform and they really don't know where to start. So it's very helpful for that too. And we learned that it was important to allow for flexibility and customization. I had kids that really wanted to use voice and other kids that did not want to use voice. They just wanted to type, right? Or I had kids that said, I always wanted to give me 3 ideas, and other kids that was like, no, just 1 idea is good. So everyone wanted different things. And design agents that support creativity is features. So a lot of the participants told me they want the agent to be able to go and move the blocks with them. And they want to have like see simulations of agents programming, like how would an agent build a Pac-Man game? I want to see like how 5 agents would collaborate to build this asteroid game. Or I want when it generates the assets, instead of giving it to me in the chat, like to have it directly on the stage. So the next phase of the prototype is to actually hack the OS entirely and integrate the agent at all different stages of the UI. And then support multimodal AI capabilities, like including like sound generation and maybe reaction to camera stream. And then the part that was very important is when it doesn't work or it cannot do what they ask of it to do, you should tell them why, right? Like, should be like, okay, I cannot generate this type of images because my training set does not include it, or I can only give you answers about Scratch because that's what my prompt is. Or so it should be really transparent and explain its limitation in order to set the right expectations. So I'm going to show you a quick demo. Let's see if it works. And this is just a prototype. And I learned that I'm giving this talk 2 hours ago, so please be kind. Oh, oops. How do I get it there? Thank you. OK, so let's see. I'm going to reload it. Looks like this. So if you come here and you don't know what it can do or not, we could just say hi. It's going to be like, what do you want to work on Scratch today? What should I say? A racing game. I love that. Racing game. Give me some ideas. Turbo boost button, extra speed. That sounds great. But the cool thing is that it actually integrates with Scratch. So I can go and get like any project from Scratch. Like people build really crazy stuff on Scratch. So let's say like they build some OCR programs. This is a bit slow. but people are actually building OCR implementation in Scratch. And if I find a project that I like, if this works, then I could actually load it in my Scratch. I have one that is downloaded, so I'm just going to load that. And then, let's see. So first, let's see how it works. Like, I can draw any number here. And then ask it to recognize it. OK, it thinks it's 2 and 8. But this is a pretty complex program, right? So if I don't know how something works, like, I can actually do a screenshot. Oh, I did not expect to have 2 screens. I can do a screenshot and then like attach it to the chat, and it would explain to me what the code in the. Let's see if I can get it fast enough. Yeah, I can't get the screenshot from the other chat, but you got the idea. So that's kind of what the program is, and let me go back to this. And it's free, it's open source. Like I mentioned, there are a lot of new features coming. I hope you can contribute and give us feedback or share it with your young friends. And the reason why this matters is because AI literacy is now actually part of the law. I don't know if you know, but this was passed earlier this month. It's part of the EU AI Act. And it basically says that all providers and deployers of AI systems should take measures to ensure, to the best of their extent, sufficient level of AI literacy of their staff, but also of the users of their products, right? So we need to, in order to ensure this AI literacy, we need to start early. And that's what I'm hoping and trying to do with my work. If you want to learn more, there are lots of papers and studies about AI literacy, about AI education, work done on other domains, math, misconceptions, and science. It's all on my website. Thank you so much. And yeah, I don't know if we have time for questions, but yeah, thanks.
What does it take to build a personal, local, private AI agent that augments you deeply? We are pleased to welcome to the stage the co-founder of Meta PyTorch, Sumit Chintala.
Hello, hello. How's everyone doing? Last talk of the day, last talk of the conference. Hopefully, I'm not the most boring. So why do I, well, first of all, who am I? Do you know this thing called PyTorch? A lot of people in AI used to know it, but now a lot of people just use high-level APIs and don't know what's powering things underneath. But like PyTorch is the software probably powering your AI APIs. So I work on it. I co-founded the project. And it's a big project that is majority funded by Meta, where I work at. And so I'm talking about, so I'm not talking about Llama at all. I work on Llama a little bit, but unfortunately, I am not in charge of Llama to try to sneak in some secrets for you guys. I'm not going to tell you when the next Llama is going to come or anything like that. So why am I thinking about personal local agents? Well, as AI kind of started becoming more and more useful, one of the things that saved my time the most every single day was Swyx's AI news. And it's basically like I have to keep up to date with all of what's going on in AI. That's my job. And now, instead of basically spending 3, 4, 5 hours a day looking at a bunch of sources, like the AI was aggregating a bunch of news for you. And I thought that was like one of the first applications I thought was like mind-blowingly personally like effective for my own productivity. And that's when I started going into like, hey, I'm gonna like augment AI within my day-to-day in a deeper way. That's not an agent though. AI news is more like an aggregator. But that's how it kind of started. The other thing is I also work on robotics. And robots are essentially agents. They act in the world. So my goal is to build home robots so that I don't need to do any errands. And so as part of that journey as well, I've been like kind of getting into like, okay, how do I get into understanding AI agents more deeply? The key takeaway I'm gonna really like drill down to you today is agents, like especially personal agents, have so much possible agency in taking actions on your behalf and stuff. And they have so much of your life context to actually be useful to you that you're better off keeping them local and private. And I'm gonna try to like sketch out a plan on how to do it, but I don't think I have a complete solution either. So first, like agent, what is an agent? Like, and why did I say swyx is AI news is not an agent? Well, an agent is something that can act in the world. Like an agent is something that has agency. It can actually like take an action in the world. Anything that can only get context and do things, but then eventually can't act in the world is not an agent. That's how I think about it. And what I think is like a highly intelligent agent without the right context is as good as a bag of rocks. It's like really useless. I'll give you a couple of examples very quickly. Let's just say I build a personal agent. It has access to my Gmail, my WhatsApp, my calendar. And I was like, did I get my prescription renewed? And it's like, no, not yet. And like, it's totally lying, except it didn't know because like I got the text from CVS on my iMessage, and it didn't have access to that source. And it was doing the best it can with the information it has, but if it didn't have the context, like it's not gonna like know how to do better. Similarly, I mean, you can make up like 100 examples like this where like you have access to one bank account, but like your money came into a Venmo, and you're like, the agent lied to you. What happens is like a personal agent that doesn't have the right context, it's largely going to be irritating to use. It's like you don't know when it is useful and when it is not useful, so it's essentially not useful. Like even when it gives you some answer, you're like, is this actually right? I'm going to have to go dig in, right? So unless it hits a certain level of like reliability and predictability that you know it is right, it's not going to be actually useful to you. So now, like, why am I talking about personal agents specifically? And how do you get all this context to the agent? So let's just say you have like your OpenAI API or some other API or some local LLM. What is all the context in the world that is personal to you, and how do you give it to the agent? Well, like the number one thing that you possibly want to do is like just have variables, right? You're just like, you can, your AI should see everything you see and listen to everything you hear. And that is like obviously the best case of providing context to your AI agent, except like there's no battery life for any of these variable things, so that's not really practical. Maybe one day when you have like crazy batteries, but that's not really gonna work. The other thing could be like, okay, like most of my life is on my phone in the ways that I care about from like an agent perspective. What about just like running an agent on my phone? It's running the background and it's just like always like watching my screen or something. Well, that's where like Apple kicks you, because they don't let you run a bunch of stuff like on your phone asynchronously. Even if you do, they have a lot of restrictions. So like the ecosystems kind of like kill you and not allowing you to do that. And unfortunately, I use like Apple. So that's out. So the next one is like, okay, actually like the thing that I found like relatively useful is like if you use like Apple in your daily life, you can actually get a Mac Mini and like just put it somewhere in your home, connect it to the internet, and you can run your agents asynchronously. There's no battery life issues. You can just log into all your services on your like Mac Mini. And it also can access all the Android ecosystems because Android is actually open. So I work at neither of these companies, so I can say whatever I want. So I think that's like what I think is a feasible device to use to like run your AI agent right now. The next thing I want to talk about is like, okay, why are you talking about local and private? Why can't you just like run this in the cloud, like just subscribe to one of the large tech companies' agent services and run your life out of it? Well, I want to give you like a few points here. First is I want to talk about how this is different from you using other digital services. And I think it is different, meaningfully, and I think it's also easy to understand. So let's just think about, like a lot of you in this room probably use like a cloud email service that is free for all of your life. All your taxes are going in there, like everything personal is going in there. Why do you trust it? The reason I think you trust it, at least the reason I trust it, is because it has a very simple mental model on how it will act on your behalf, or how it will act in general. Email in, reply out. It's not, it's basically not trying to do something sneaky under you that is unpredictable. It's a very simple mental model. Your trust of that service is correlated with whether you understand how it behaves on your behalf. So imagine tomorrow if some unknown email service that you've been using forever says, oh, for some of your emails that I have confidence in, I can auto-reply on your behalf. And you're like, OK, well, first of all, that might be true, but what is the worst case action you can take? Maybe you'll like reply to my boss like something nasty. And like, I don't want that to happen. And like, that's like, once the action space becomes powerful enough and unpredictable enough, you get uncomfortable with using a service that you're not fully in control. And it can get like worse, right? Like companies have to monetize in a million ways. And so what if like you're using like an online service and they suddenly are like, oh, every time you ask for a shopping query, we're gonna like start making the agent only buy from like stuff that gives us kickbacks or something. So like I think like your personal agent is so personal to you and so intimate that I feel like ultimately you want to be in control on many aspects that you might not have control on eventually when you have to like trust an online service. So that's like one of the biggest reasons like why I feel I want to build a personal agent that's local to myself. The second is decentralization. Like, I mean, you already see all these ecosystems that are walled gardens and like fighting with each other and don't allow each other to interoperate in various ways. And if you build one of like your personal life, your personal agent around one ecosystem, like, is that something, like, it works fine for compartmentalized things like maps and email and various things, but like, is that something that you want to really subscribe into for like an agent that can take so many different kinds of actions on your behalf in your day-to-day life? That's like the other reason I feel like you should try to, we as a world should try to get to like local personalized agents as the norm. And the third one is for various reasons. Okay, this is what I called, are you going to be punished for your thought crimes, right? Like, okay, you have a thought, and it is not a good thought, and like, should you be punished for it? And usually, like, the answer is no. Now, if you have a personal agent that is effectively augmenting you in such an intimate, personal way, you might be asking it stuff that you generally wouldn't say out loud ever. And in those cases, like, do you really want to take the risk of like putting it out into like some provider? Because like, you can actually ask Perplexity like enterprise-grade cloud API contracts that like are like enterprise-grade, not consumer-grade, where they like get sloppy. Even they have to like do a bunch of like legally mandated logging and then safety checks and stuff. So there is a possibility that like you might or might not want to take a risk on. But for me, I'm like, I don't want to ever get into a scenario where like I will be like prosecuted or persecuted for my thought crimes. And like that, I think, is like another really powerful argument for myself, at least, to focus on like local agents for my most personal augmentation. So now coming to, well, I hope you're convinced that yes, we actually if you're going to build a personal AI agent, it has to be local and private. Well, OK, what's the problem? Well, let's go to the technical challenges first. First, OK, you got to run this stuff, right? There are great open source projects to run a bunch of local models that are one of the key components of these agents. VLLM and SGLang are pretty great. They're both built on top of PyTorch. So effectively, there's this one time we wrote a bug in PyTorch, and a bunch of us had a Tesla car, and Tesla uses PyTorch. And we were like, man, this is so scary because are we writing bugs on ourselves? That's an aside. It was totally fine. The bug was not that bad. So yeah, VLLM, SGLang are great. But local model inference is still, as of today, slow and limited. It's not as fast as if you just use a cloud service. Even if you spend enough money on a beefy machine, I think that's also rapidly changing. For example, locally, if you're using a 20 billion or distilled model of some sort, it actually runs pretty fast. But if you want to use the latest R1, full unquantized, then it runs super duper damn slow. I think this is in a state of it will fix itself. So you probably wouldn't get to run the latest and greatest. And I think the challenges are not so much the technical and infrastructural challenges. They will kind of get to a place where they're fine. I think there's some challenges around both the research and product that people need to think a bit more about. I think there's a bit of a gap, and this is just an open challenge for this room, for all of you AI engineers. One is the open multimodal models are good, but not great. I mean, they're not great in a couple of areas. One is just computer use. Even the closed models, in the latest and greatest APIs that you can just pay money for, they're not that great for computer use. They break all the time. So that needs to definitely get into a better state. The other thing I noticed is if I ask a model to do shopping for me, from clothes to shoes to furniture to whatever, it'll basically give me the most boring shit, right? It's the basic stuff. And if I ask it, if I'm look, I'll tell you my tastes, and my tastes can get very specific and fine-grained. The more specific I get, the more bullshit it gives me. It's the same. Oh, you asked for a red velvet sofa with oak wooden legs. Here's a green sofa that has velvet. And it doesn't have oak wooden legs. They're not very good at identifying actually visually what you're asking for. They mostly rely on a bunch of text matching. The other thing you will notice, and this is a big one, is we don't have good catastrophic action classifiers. What do I mean by catastrophic actions is there's many actions an agent can take. A lot of them are reversible or harmless. Even if it takes the action and that's not the action you wanted it to take, it's whatever. Oh, it had to go to that particular Wikipedia link, but it went to this other one. OK, big deal, whatever. It'll just backtrack and go. But there's some actions that are actually catastrophic. For example, you ask it to go purchase a renewal of your Tide Pods, and then it goes and purchases a Tesla car. This is not the best thing for you to do. And some of these are called catastrophic actions. And I don't think there's a lot, there's some open research around how to really get agents to get good at identifying catastrophic actions before taking them, and then maybe notifying the users instead. But there's not enough. And so if you want to really trust your agents, personal or in cloud, I think we got to get a bit better at these things. So that's a big one. And I think open source voice mode is barely there. I feel when I need a personal local agent, I definitely want voice mode because sometimes I want to talk to it and not actually type out everything I want to say. But still, why am I bullish about this whole thing? I am, because one, I see open models are actually like compounding in intelligence like faster than closed models, like based on how many resources are being put on them. Like, what do I mean by that? Like, OpenAI is only improving their own model. Anthropic is only improving their own model with all the billions they have or whatever. But open models are improving themselves like in coordination across board. And you know, people didn't really believe it until Llama came out, and they didn't really believe it until Mistral came out, and then they didn't really believe it until Grok came out, and then they didn't really believe it until DeepSeek came out. Like, basically, like people are like, oh, you know, like open models, you know, will not really win, but I think they are. Like, basically in open source, like I've worked in open source like all of my life. There's a starting coordination problem. Like, initially, you don't have enough of a critical mass to coordinate with each other. But once you have a critical coordinated mass, open source kind of starts winning in like an unprecedented way. And you see that with Linux. You see that with a bunch of projects. So I am pretty bullish that open models would actually start getting like better than closed models like per dollar of investment into open models. And that's what I said. Well, OK, I have some plugs. This is like gr.inc from my friend Ross Taylor, who worked on this model called Galactica, which got a lot of like criticism when it was released out of Meta. It was this open science model before ChatGPT released. Now, like doing science with like LLMs is pretty common, but like they got a lot of shit when they released. And he like quit. He like unreleased Galactica, and he quit doing like a bunch of stuff publicly. But then like he's working on like plugging the reasoning gap between open models and closed models, and they released a bunch of open reasoning data that will help. So just a nice quick plug. The other quick plug is I work on PyTorch. PyTorch is working on enabling local agents, especially the technical challenges that I talked about, and we're hiring. So if you are more than an AI engineer, if you're an AI engineer who's also like a systems engineer, then like PyTorch is hiring. Well, that's what we got. The other thing, obviously, is I welcome you all to come to LlamaCon, which is happening on April 29th. And save the date. It's going to be very exciting. Lots of Llama stuff will happen there. That's it. I think it's in California. I actually didn't look it up. So thank you.
Ladies and gentlemen, please welcome back to the stage NLW and Ksenia Sa.
Thank you, everyone, for being such an amazing audience. We know you each to get out of your seats, but please, please hang out with us for 2 more minutes. First, on the website ai.engineer, you can find information about after parties that are happening this evening. Please check it out.
And then tomorrow, there's a full day of workshops. They are not here. You can find the address on the website, but it's J Suites, which is 109 West 39th Street, 2nd floor, and AWS at AWS JFK 27 on 12th West 39th Street, so both of which are right next to each other. Before we go, we'd like to invite the organizers up for a quick message of thanks. So please join me in welcoming to the stage the co-founders of this AI Engineer Summit, Benjamin Dunphy and Swyx.
Hey everyone, how are we doing? Did we have a good time? Long marathon for us, I'm sure for you as well. We won't keep you too long, but we just wanted to chat with you for a little bit because this has been such a blast for us. I know it has been for Swyx as well. Behind the scenes, he's really putting together all the content, and he's doing a lot more speaker wrangling than we'd like him to do. So this guy is doing so much work. So I just would like everyone to give him a rousing round of applause. all of the incredible people here, and also you in the audience. I mean, you're not coming for me. I'm putting together the show. You're coming for him. So, yeah. And everyone else here.
But like, you know, I think a lot of the show is also just how everything smoothly runs. Like people don't see behind the scenes how much chaos there's back there, and it's all due to Ben and team. And Leah's back there as well, and we have a whole team that's helping us as well. So yeah, we ought to thank that. And I'm very grateful to work with you on this stuff. I mean, this is like our third conference, and I still feel like I feel like it's getting better, but I still feel like there's always like chaos. And we kind of make it hard on ourselves because every conference is slightly different. For example, this one is the first one in New York. Yeah.
We also didn't decide on this venue until like December 15th. So this is like less than 2 months of planning. So maybe we can do a little bit more with World's Fair for June.
Yeah, I mean, that's what, like we're doing it 1 year ahead. Yeah, so World's Fair coming soon. I don't know if we have like a URL or something.
No, we're just chatting.
Okay, cool. Yeah. What else?
But I mean, we get asked this a lot, so I just wanted to address this to the whole audience. Like, why did you come to New York? Like a bunch of San Francisco people. So we get asked this a lot, and it's really just a few simple reasons. I mean, first, like, we just want to get out of our San Francisco bubble. We had 2 successful AI events in San Francisco, and then secondly, as swyx said to me about the AI scene in New York, what did you say?
Yeah, show me what you got. You know, like I think New York, people talk a lot about like, you know, the great engineering that's happening in New York. We saw some data yesterday about, you know, the hiring that's going on in New York. And basically I felt like New York was kind of underserved. The kind of frequency of AI events that we have in San Francisco we take for granted. Apparently, you know, I was checking my biases. I was like, maybe I'm just ignorant. But I talked to some of you here, and you're like, yeah, you know, this quality of event doesn't really happen that often in New York. So yeah, we just wanted to bring a little bit of the sort of AI engineer magic to New York.
Yeah, and it's been a blast so far. And I think the last reason is like, if I get an excuse to go to New York, I'm going to take it. Yeah, even if it's in February. Us Californians we're not that accustomed to this weather. But
yeah. So I really felt like we needed to do something early in the year so that we have context, we have relationships and whatever for the rest of the year. So I think like the timing is important. I'll just say like, you know, if you come here even though it's cold, then like you're really here, you're really serious anyway. So
God smiled upon us this week. Those blizzards did not show up. So.
Yeah. It was supposed to be 2 feet of snow on Thursday, and then someone cleared up. So I don't know what we did, but we did it right. Global warming for the win.
Yeah. So I was talking to someone about what it takes to put an event on like this, and like everything's really tight. Everyone's got 19 minutes. Yesterday was 20 minutes. Everything's back to back. So it's like, to go from the plug-and-play conferences where you're like coming in and doing this, like meetup style.
Which is
like
what I
this,
do, yeah.
It's literally like 1,000x more work and a lot more stress on like us. And then we kind of pass that on to the speakers a little bit because it's a little more strict. So I just want to thank all the speakers for putting up with me and putting up with the crew for saying, you know, urgent, we need your slides now or everything's going to break. And, you know, swyx doesn't think it's that big a deal, but I do.
It's a big deal, but I think we have to tell people why. You know, when we have such high expectations that they're not used to, like you have to give a rationale. Yeah. It's like, you know, you have to show your reasoning to arrive at some kind of conclusion. Like it actually helps, you know.
True that.
Yeah. What else?
There's just so many more people that go into making this production. We have an entire crew back there. We have Argus HD back there.
Yeah, thank you,
Time
Argus.
Center helping to run this. But not just that. We have a whole organizational crew. We have Leah, we have Franz, we have Peter, we have Scott joining us. We're actually starting to really build a big team so we can actually cross that chasm, because right now we're like, you know, you see me running around or you don't see me at all because I'm, you know, putting slides together last minute or I'm doing something last minute. That should all be done way ahead of time, but with a bigger team, we're going to be able to do that. So I think as we prove this model, we're going to continue to grow and grow the team.
I mean, don't forget our MCs.
MCs, yes.
Thank you. Wonderful job. Mostly, I wanted to. I think I have a theory that professional yappers are like very good like improvisers, like they like are involved in industry. You want to meet lots of people. Like that's my theory. Like I want to kind of bring people into the fold. So I hope that you guys are familiar with each other and that you can get something out of it as well. But thank you so much for all the work that you did today.
And then, of course, in that sponsor expo down there, did you guys see that? That was Motif Events. They put that together. Really, really good expo down there. Really, really professional looking. And then our sponsors themselves who manned those booths and showed you those exhibits. Who were our favorites? What do you think? Shout them out.
What? Daily? The PipeCat cloud thing? Yeah.
CloudCat? Yeah. Everyone else too scared? All right. Don't want to show favorites. Sourcegraph, all right. Galileo. All the company reps are now shouting their names.
Yeah. I would say we added the expo stage at kind of the last minute, mostly because we were like, we have some ability to set up AV, but it was noisy in there. Yeah, I mean, it was like hard to hear.
Yep.
I think in future we would want to separate it all a little bit more, but we couldn't really tell the acoustics before running the thing.
True, and that was kind of a last minute addition, so we didn't really get a chance to test that. And when we added that, they were like, well, we can get speakers in there, but it's going to be overhead. It'll sound good though. But we did get some complaints from sponsors saying, it's too loud in here. We can't have conversations. Probably getting some same feedback from attendees as well. So I think those are like little things that we need to optimize and fix. Yeah.
Anything else?
That gets smoothed out.
Yeah. Anything else? I don't know.
Yeah. So we want to do one more thing, and we want to invite you all. And apologies to everyone I didn't get to thank because too many people go into this thing. But one person, Randall Gee, is our photographer. There he is. And he is going to take a photo of, ideally, all of us. And Max Video Productions, who does our B-roll and did the interviews out there, hopefully they'll be getting some B-roll of us as we do that. So I've never done this. I don't know if you've ever done it, but I'd love to get everyone, as much as everyone wants to come, on stage. Just one caveat before we get up. These things will break if you step on them, and we'll have to pay for them. So just don't step on those. They're like grates. They're hard to see, but just don't go past this line, and don't touch that. But yeah, who wants to come up and do a group photo? It's going to be a good memory. Yeah, this is like the Solve conference.
Come on up.
Yeah, let's do it. Randall, you want to grab a word?
Sam.
There you are. You can shout. Just a reminder not to step on the grates behind you. They will break. Thank you. All right. Very good. Look at this group. We get the lights on all of you now. All right. All right. We got to turn it back on. Swyx, you got to be in the red carpet. Can we get maybe MCs over here? Red carpet if you want to, if you're comfortable. We're going to get to know each other really quickly. Come on in, everyone. And Randall's going to tell us if he can see us. How are we looking? All right, let's do it.
So the cutoffs are going to be the signs on the sides. So if you're in front of it, come in a little bit more. If you're in front, we're going to swap, but not yet. Just save your body.
Swyx can actually sing. Do you guys know that? Go for it.
Okay, so this side just switch a little
Started spreading the news.
So people in front, go ahead and film.
I'm leaving today.
Everyone fall in, fall in, fall in.
Film the spots in front of Ben and Swyx. There you go. That way. And then you guys over here, the guy with the white cap.
Do we have some volunteers?
Okay, this works. Okay, so this one, I'm going to have the front row squat just a little bit. Here we go. On three. 1, 2, 3. Smile. 1, 2, 3. Okay, now everyone give me a yeah! Yeah! That's a wrap.
Thank you, everyone.
Thank you. One more thing before everyone goes, a little bit of a surprise. Ben didn't mention this, but it's actually his birthday today. And we got him a little thing. So thank you, Ben, for taking apart like your personal life, putting your personal life on hold, and doing this for us. Day to you.
Hello.
Happy birthday to you. Happy birthday, dear Ben. Happy birthday to you.
And I don't think...
Yeah, we shut your mic off.
Just a reminder, one last protocol item from me. We are actively breaking down the venue. You're welcome to stay for a little bit, but we gotta be out of here 5:30, 5:45. So there are plenty of side events happening, but of course, this is New York. You can go anywhere you want. We'll see you at the workshops tomorrow. Those are nearby. Those within walking distance of this venue and also the hotel. That's at AWS Hank and J Suite. So that's all on the website. Check that out. You can get the address there. You're all welcome to come to that. We'll see you there.